We're going to start in about 3 minutes. Again, if people can start making their way from the networking area to the stage, we're going to be starting in about a minute. Okay, hello everyone, and welcome to the fourth consecutive OpenAGI Summit. This is our second one in Denver, which marks the first anniversary of the summit and Sentient. Well, first, we're super excited to host you. We have an incredible lineup of speakers from the top of crypto, AI, and academia. We want to thank our sponsors and all the speakers that made this event possible. Not to delay any longer, we're going to have Sandeep give the welcome statement and kick things off. So please welcome Sandeep joining from Delhi.
Hey everyone, thank you so much for coming to this latest edition of OpenAGI Summit. This event started as a small crypto AI event. I think last ETH Denver only. That was the first edition, and since then it has become like a de facto crypto AI event everywhere. This year also, I think amazing lineup. Really, some of the best crypto AI leaders are speaking, and I hope you guys have a great networking time also over there. Crypto AI overall, like as we have all seen, that we went through our first major hype cycle with agents and agent tokens and whatnot. But I think that's the start, and there's so much to come from crypto AI side. And then we can already see some of the interesting projects coming in. And with Sentient also, I think we promised to you guys to build the loyal AI, the AI which is loyal to the communities, and the larger goal is basically to make the AI which is loyal to the whole of humanity. And if you can make the AI loyal to any particular group of individuals, it can be a community, it can be a business, it can be a whole of humanity, or it can be an individual user also. There are very interesting use cases, and I think people are going to talk like, what do we mean by loyal AI? And like the loyal AI essentially means that these LLMs today, the AI LLMs, they're more like creative beings, and they like the hallucination is not really a bug in them, it's the feature, right? It is the feature. And they have a tendency to become extremely creative, and due to that they are unreliable for a lot of mission critical business use cases. Not only mission critical, I would say, even like your day to day business use cases, even simple chatbots, that there is a tendency that you really know that on a particular context, what would an LLM end up doing? Imagine you are a multi-billion-dollar insurance company and you put an LLM as your AI salesman, and then on a particular context, it gives a very hideous advice to a particular your customer of yours, or advises the customer to buy a competitor product and things like that, right? As a business, you don't want to allow that. Similarly, if there is a community, XYZ project community, that AI is basically loyal to that particular community, that particular project, it should not be saying suddenly, like, somebody should not be able to jailbreak it into saying completely bad things about the project and things like that. So that's what we mean by loyalty, and we are already seeing that there, especially for the large businesses and anybody who wants to use these LLMs in their actual businesses, they want these guardrails. Loyalty, you can also think of it as a guardrails around this creative being that is the LLM. And we have actually at Sentient, we have released the first version, which I call it like loyalty 10%. Like, it's just 10% loyalty, and we are going to add more and more features into it. But for now, the loyalty is basically in the form of these fingerprints, where you can always identify that a particular model is the model that you as a community participated in building, and then whether that model is paying back to the community or not. That's the first part of the model loyalty, and that gives ownership to the users. The next step in the loyalty will come as the control, like where you as a user using the prompt will be able to control the actions of the AI also. Like, for example, if you are a community, the community together can come and fire a particular query, and then LLM basically disburses all the funds that it has in the DAO treasury as dividends to everyone, right? So these kind of things, and you want to make sure that the model that is being used inside this has those guardrails. Nobody can jailbreak it into sending these funds to an unauthorized or unintended party. So that's what Sentient is doing. Eventually, as we promised, that we want to go to a place where the model is a completely loyal being, where whichever community built that model, anybody who wants to use that model, they have to abide by the financial contract to that community. That means the pay for the fees, whatever that fees the model expects, and also abide by the values set through by the community. And if we are able to do it, eventually we can build a model which can be loyal to the whole of humanity also. That is the larger vision. That is our go to mass vision, because once you have that kind of AI, then you can have like a global doctor with AI, a global policeman with that AI, which is not controlled by one single party but controlled by the world. So that's what little bit about Sentient, and I think the Eat Denver this time is even more crazier, and I hope the Open AGI Summit also doesn't disappoint you guys, and you guys go with the really amazing feedback for the event. And yeah, enjoy the talks, enjoy the great food, enjoy the amazing networking time over there. And if you have any feedback for us, do relay that back the Open AGI Summit team. Thank you so much, everyone.
So as we said, this is a sort of big day for Sentient because it's its first birthday, and in a very poetic way, we also have 3 releases lined up today. And to kick them off, please welcome Si Wong, who's going to present on Open Deep Search.
I'm waiting for the slides. Coming up? Okay. All right, I think I can get started. You guys can hear me okay back there, right? Yeah, cool, thank you. Yeah, I'm here to present the release of Open Deep Search by Sentient. And this is work by our amazing team, research team at Sentient. And our goal is to combine the latest and the greatest reasoning. Thank you. Reasoning models that have been advances happening recently that includes like starting from Llama in the open source world, QN and DeepSeek models, and combine them with the reasoning agentic framework that we, Sentient, provide to provide you the best performing open source search AI that matches the performance of all the closed source models. So let's get started. So as anything in AI, there is two schools of thoughts in AI search engines or search AI. One is closed world and the other is open world. So in the closed world, the advances have been happening very recently so that we bring the best reasoning models, reasoning solutions. Those include like test time or inference time compute, the best out there to provide you the state-of-the-art performance in search AI. This includes Perplexity, ChatGPT, Grok models, Google, and Bing, Microsoft, and other things. And one of the popular and most, high-performing one is by Perplexity AI. So that's the one I'm gonna mostly be comparing against throughout this presentation. On the other hand, on the open world, there are solutions, but they've been lagging behind. They've been mostly focusing on retrieval and prompt augmentation, RAG type of solutions, having little to no reasoning capabilities. So we want to change that because there's so much to benefit from open source, open world. Starting from lowering the barrier, fostering innovation. You can innovate on each other's techniques and building community. So to do that, what we're gonna plan to do is provide an open source solution for search AI that can match or even beat the best closed world solutions out there. So that's Open Deep Search by Sentient. And what we want to do is we build upon the best open source reasoning models that are out there and that will continue to improve. And you can plug in those models into our end-to-end solution, which has two components. One is Search by Sentient, and the other is Reasoning Agent by Sentient. So Search by Sentient has multiple components, including paraphrasing or rephrasing the queries that came from the user so that it's tailored for the search engine. And we get the URLs and documents. We need to summarize it, retrieve it, scrape it, and re-rank it. We make innovations, all these components. Shout out to Sala, who made a lot of this work for open source completely. But today, I won't have time to go over the details of the search part. I'm focusing more on the reasoning agent part, where the search output is fed in as a context to the reasoning agent by Sentient, which accesses or wraps around the open source LLMs that we're gonna use. This includes in our experiments Llama 3.1 with 70 billion and DeepSeek our models. And what we do is we allow this high-performing language models to use three tools. One is search. So it's allowed when the initial search didn't retrieve the information that you need, it's allowed to search again for the information you need. Another thing is calculator. We're not going to do complex mathematical things in our search, but just having the separation between LLM taking care of the reasoning and the linguistic parts and logical parts, and having everything related to arithmetic kind of set aside for the calculator makes it much easier and coherent and precise for whole reasoning system, as like a human would do if you had an extra hand. Another thing is to think and reflect upon its own outputs. And if anything is ambiguous, you can go back and think again until it is clear what the answer is. And given these three tools and bringing techniques like self-consistency, chain of thought, few-shot prompting, and others, we provide these two techniques as open source, and let's see what we can do with it. Okay, I'm not keeping track of time, so anyone, Anton, someone should tell me if I have 3 minutes left, okay? If I have 3 minutes left, please let me know. Okay, so Frames benchmark is released by DeepMind, Google DeepMind last year in September, and it's one of the kind of complicated benchmark when it comes to retrieval, search, and factuality. They designed this so that you need to get multiple sources of facts and information, combine them in a coherent way, in a logical way, to get the final solution. And I'll show you examples in a bit. On this benchmark, in the closed source world, GPT-4 achieves an impressive performance of 50%. Perplexity have two modes that we can access. One is the default perplexity, which gets about 42%. And Perplexity Pro, which has reasoning capability and probably multiple searches on top of Perplexity default that gets about 44%. And it's much slower than the default mode, but much more high quality. In the open source world, DeepSeek R1 surprisingly gets less than Llama for these tasks, about 30%. Llama gets about 34%. And our goal is to build upon these language models that are amazing, but wrap it around our reasoning agentic framework so that we match or improve upon this closed world, and we get about 56 or 57%. And this is a fair comparison. I'll explain what I mean by fair later, about 5 slides later. But let's look at how we achieve this improvement in comparison to Perplexity. So example question from Frames benchmark look like this, and you can notice it requires multiple factuality information to be gathered correctly and combined correctly. So maybe it's what year was the band leader of the group who originally performed the song sampled in Kanye West's song Power Born. So you need to multiple things. You need to know which song was sampled. You need to know which band play the song, you need to know who the leader is, and you need to know the birth year of the leader, and then you'll get the right answer. And the true answer is 1946. If you plug it into Perplexity, you can try it. We just plugged it in and got this answer. And I might have cut off some parts of it just for the presentation. But what it does is that it gets the song that's sampled correctly, 21st Century's Schizoid Man, the band correctly, which is King Crimson, but then whatever the results from Perplexity search didn't have the information about who the leader is, just guessing that it's someone else. And of course, it gets the birth year wrong because it's someone else's birth year. And what we do is we bring reasoning around Llama, which is not particularly tailored for reasoning. Llama is more generic model as opposed to more reasoning models like DeepSeek. But if you wrap it around with our reasoning agent by Sentient and feed in the high quality retrieved documents from search by Sentient, then this happens. We always start with thinking about the context or the documents that you retrieved from Sentient search. And it first identifies what it needs to do. 4 things that you need to do that I just said last slide, so I'm not going to repeat it again. And then it goes on to understanding the context and see what it has. It's got the music sampled correctly, the band correctly, just like Perplexity. But because our search, I think in this example, is better than what Perplexity search does, we also get the leader of the band correct, which is Robert Fripp. And then it realizes that it didn't have any information. 3 minutes left, okay. It's much shorter than I would have possibly imagined. Okay, I'm about 20% into my slides, but I'll give you the gist of it. So then it realized that the search didn't give back the birth year of Robert Fripp. So it calls an action, which is one of the 3 tools that we provide, and calls the search internet action with Robert Fripp birth year as a query, gets the right year, and gets the right answer. Maybe I have time for one more example. I have to run to the conclusion. Why not? So this is another example where you have to get the, how old a person would have been, who's the winner of this poetry award, on the year that, the book Milk and Honey was released, and then it'll be 90 years. Perplexity doesn't realize that it needs the winner of the prize, not the year of the prize. And because it doesn't know who the winner is, of course it doesn't get it right. Our search engine will give you the right information, who the winner is and who the birth year is. And as I said, it calls a calculator to calculate the difference to get the year, how old that person would be, which is 98 years. Because the separating out these 2 tasks makes it much more coherent for these reasoning models to get the right answer. And one last thing is that it's possible to do even better than what we provide by allowing more searches. Because we judiciously choose to search only when we need to, we're only using extra search about 5% of the time. But if you allow, let's say, 10 searches for every query, then you can do even better. And this is experimental. We just tried the first thing that comes up to mind, which is just use 10 different searches with slightly different prompts. So there's big room of improvement. The reason we're going open source with all this is that all of you can improve upon what we provide and make the search even better and better. And with that, I believe I'm about out of time. I got tons of examples, which I'll defer to Twitter to show you. And with that, we're bringing everything open source in a couple of weeks. We're just cleaning this up. And you can start with the state-of-the-art performing, search AI model with our open source model and make it even better. So thank you, and that's all the time I got, I think.
Okay, now please welcome both crypto and AI OG, Ilya Polishkin, who's going to talk on autonomous and secure AI agents.
Thank you. Hello, everyone. Hope you have a great morning, start of the day. So we'll talk about agents, but before we start, let's talk about AI in general. AI, from my perspective, is the last technology wave. It is effectively already becoming a tool that is used in chemistry and physics. The Nobel Prizes last year have been won by people who've been using AI or AI researchers. It's used in business, it's used in entertainment, it's used in daily life. And I mean, for those who are coding, more and more of the code written is done by AI itself. And so from perspective of how the world will evolve, AI will be the interface through which we're interacting with computing. Now, the challenge is whoever controls this AI, right, however you're interacting with it, will effectively control all of these areas of our life, controls everything. And so it's extremely important that we have kind of people in control that we trust, right? Now the challenge is if you are using kind of closed source AI models and closed source model providers, the challenge is that they effectively are in control, right? They can, with a flip of a switch, turn off the whole country from accessing AI. And imagine this is a multi-digit percentage of GDP of some countries. Or they can decide, to not respond to specific questions, or they can run ads directly in the output of the model. Now, open source, always been kind of a counter force for this, and the challenge been it's extremely expensive to develop these models. It's extremely expensive to develop software here, and so there's no sustainable model, right? As soon as you open source your model, now everybody can use it, they will serve it, and somebody else will actually make money on serving it, but the company that developed it is not. And so that's extremely big challenge, right, for some advocates of open source and really kind of decentralizes control. And so the idea of a user-owned AI kind of comes from combining this 2 points, right? We want the control to be in the user's hands. We don't want this to be in the hand of a company that's trying to make money off you. And at the same time, we want it to be focused on your success. It needs to be your well-being, your economic success. So building up on the values we already have in crypto, with ownership of assets, data, power of choice, kind of this universal interface that AI provides you should be effectively on one side, firewall from everything that's happening on the internet, and on the other side, work on your behalf, right, to get things done, be that kind of global participant. Now, this needs to be an economic model, right? This cannot be just, some new company. It needs to be an economic model that aligns incentives of researchers, developers, of users, and services that are participating in this network, right? So this needs to be a new kind of incentive structure, and this is what we're building with user-owned AI. Now, the thesis kind of from a user experience side, right? We've kind of had internet collapsed into this Google search over past 20 years, right? Where you would usually go to Google, Google would run some ads on your behalf as well as provide organic search results, and then you would go to that product and you would interface with it. Now, with kind of LLMs coming out, we had a new way, right, where we can just ask a question and it will just respond to a question, right? You don't need to go to websites, you don't need to kind of click through a lot of things and figure things out yourself. And to be clear, like this transition is happening right now. Like the more and more people I talk to using Perplexity, using ChatGPT, using one of these products, and Google is kind of actually losing more and more usage. Now, the final stage of this, right, is where your AI agents are just executing actions now on your behalf on the back end, right? And you don't kind of need to go and like check up on them and do that manually. Now, to make sure that this is actually happening, in the user-owned way, right? We need to make sure that there's a confidentiality, right? The usability of these agents will come from them knowing as much as possible about you. Like ideally, they should be listening to you every minute of the day, but you don't want all of this data now streaming to some other company who will try to monetize it. It should have kind of equal access and control of this AI capabilities, right? You don't want to like, for some people, there's a limited access, for some people you can ask medical questions and for some you don't. And again, you want users to own their data, right? And like if they decide to, they can trade it off for some assets. They want to own their assets and power of choice. So just to kind of visualize this, right? Again, current paradigm, browser, lots of payments, you have advertisers, and then you're going through search engines to different websites. The new paradigm is where you have an AI assistant, right, that's sitting on your device and is effectively representing you on the internet. And instead of going to websites, instead of even using apps, your AI assistant can now go directly and interface with services, with smart contracts, with other AI agents, and get things done, right? And effectively, you still need a way to facilitate that, and that's what we're building with Near Network. And so, part of this paradigm shift, we're going away from users effectively being the product in this aggregator internet that we've kind of become accustomed to, where the Googles and Amazons, etc., are effectively generating, they are generating value by providing information, but they also are extracting value through this. To this user-owned agents, starting to do things on your behalf, right? This is kind of, in progress. And then the final state is like this internet of agents where actually there's not even need for websites and applications because, your agent can go directly talk to a pharma agent to figure out the exact medicine you need to be designed for you on the fly, for your medical information, for your specific case. So just to give you something a little bit visual, this is your assistant just pushing some notifications saying like, hey, I booked the tickets for the Denver trip. I'm a fan of metal concerts, so it booked a metal concert as soon as it opened up, and it rebalanced my portfolio from Aave to a near lending protocol because there's a higher APY. So it actually executes actions on your behalf, right? Knowing what you need to do or you're planning to do, and each of this is a separate sub agent that actually is running on the background and doing actions. So how do we actually achieve that, right? This is like a future. We have the picture now. Well, we need a kind of a whole host of infrastructure that enables this to be done. So first of all, we need an agent hosting, right? Like we need a way to host these agents in such a way that we know they're secure and we know they're not leaking any of your data, they're confidential. We need a way for this system to have all your data, user data, shared memory, and being able to act on it. You want a way to find agents, right, that actually doing things. So, for example, you want to buy something from this factory, or you want to, your agent talk to a pharma agent. Like there needs to be a way to discover that, and then you need a way to pay and kind of transact with that, right, and have all of the related kind of payment infrastructure for this. So, this is actually what we've been building. First piece is like, how do we get confidentiality? This is, and verifiability. And verifiability is really important when we kind of move into this world, because you want to know what exactly, like maybe as individual user, you will not be inspecting code, etc. But the whole system needs to be verifiable so that, security experts, etc. can kind of verify and authenticate that the whole system works, right? And so the kind of first and foremost, right, is confidentiality and verifiability. And so to do that, we've been building a decentralized confidential machine learning cloud. So this is built on top of a trusted execution environment, which is a kind of hardware elements which are now available in Intel, ARM, AMD, as well as works with GPUs, H200s, and Blackwells in the future. And what it allows you to do is to have the full AI pipeline, so both model inference and agentic code around it, to run inside Secure Enclave in such a way that the owner of the machine, the developers, the builders of the model are not able to see what happens there. Like it's fully kind of private from the user perspective. There's an encrypted session established with a specific machine that runs your workload, and then through that you have a whole interaction happening. And obviously, there's a payment involved in this, and you have requirements of how to make sure the network is live. So all of that is done through smart contracts and a few other technologies we've built. So that's kind of piece number one. The interesting thing that trusted execution environments give you are the fact that not just this code was run on this data and nobody's seen it, but also that only this code was run on this data, right? Which actually is something you cannot get from effectively any other methodology in the current approach. Now, there is obviously, technology will continue evolving, so there's a lot of interesting innovation on fully homomorphic encryption that can be added here. But this right now is the most pragmatic approach to actually using AI inference in a fully confidential way. So then on top of this, you build an agent hosting, right? So now you can just deploy your agents, and they're going to be running in this environment, and any user can come and interact with them. And obviously you have models as well that they're using on our agent hosting, any agent is effectively a program that can use one or many different model inferences, can interact with them. It can use tools. It can actually execute any arbitrary API calls, and it can have secrets and kind of variety of other things, right? So we have actually, as of today, over 500 agents already. There's things like no-code agent builder. So if you are not a developer, you can still build agents. And you can just describe what you want. It will go find the API, read the API docs, write the code, and actually deploy that agent. Now, the other thing is that we want to introduce is kind of how these agents will actually talk to each other, right? At the end, right now, kind of people have been building agents which are mostly running on their single machine, on their single server, right? They don't have this ability to communicate across so-called trust boundaries, right? So if my agent talks to a pharma agent, they effectively are in a contraposition, right? They need to negotiate with each other. They should not share more data than they need to, and then they can, maybe request some payment and request some interactions. So AITP, HTTP for AI, is agent interaction transaction protocol that effectively describes an open protocol that people can extend with kind of how multiple agents can communicate to each other, exchange different capabilities, and then exchange different structured information and structured calls to each other. So check it out. It's open for comment. We have some implementation of this on near AI hosting with different agents, but it is an open standard that we want to kind of expand and get more people to contribute. So to give you a very specific example, you have a user who wants to buy, for example, headphones in their favorite color. You have an AI assistant agent, right, their personal assistant, that is augmenting this by resolving what their favorite color is based on their private memory, and then goes to a discovery agent, which has an index of all agents in the ecosystem and beyond, and which can effectively add to the chat the other agents to kind of respond back with different options and different information, right? And maybe ask more questions for clarification. So this allows you to have kind of, your assistant being the maintainer of all of the information, while these agents may be sitting on the other side, right? They kind of, think of them as when you go to a store, to the attendant who is helping you with selecting your product. They are trying to maximize their own, revenue, etc. But your AI assistant is effectively modulating that. It can help select. It can help filter. It can get those options and pretty much re-rank them based on knowing everything about you, right? So your assistant is effectively on your side, being the main driver, effectively, of these interactions. So the other important part is security, right? We talked about verifiability. That gives you a lot of kind of properties that we want, but people can still build malicious code, right, and build malicious agents. So we want a system that actually ensures that the agents themselves are not doing anything malicious, are not trying to leak your data, are not trying to extract some information from your assistant, for example, in these conversations. So one of the approaches we're taking is to have an AI agent auditor. So when you are actually building your agents and you're deploying them, and they host it in this cloud, they're actually verified and audited by the AI itself. And maybe there's going to be a process with manual checks as well. But this ensures effectively a system that's similar to App Store, right? When you're submitting your app, there's actually a review process that happens before the apps are published, so people know that apps are more trusted. And obviously there's still permissioning model and data isolation and all those things that cloud provides, but this is a really important step. Now, long-term, this is not enough. Long-term, any kind of AI can be tricked by another AI, right? And that's going to be just a kind of continuous battle. The way to fix this completely is to actually have a mathematical proofs. And this is something that we long-term invest is to make sure that every single line of code should be mathematically proven for a specific interaction. So to give you an example with smart contracts, if I'm planning to put money into some Uniswap pool, what I want to know is that at any later time, I can withdraw at least as much as I put in a product of the amounts of money, right? So when I put money, there should be a proof happening, mathematical proof that the code that runs Uniswap is exactly, satisfies this criteria. Right? This is my LP, effectively, condition. The same thing applies to agents, right? If I'm gonna share some data that with my calendar information with an agent, that agent needs to prove to me that the only thing they can do is book a single slot there and not expose that information to anyone else. So you can actually have like proper mathematical proofs on all of these conditions and potentially beyond with safety and kind of even alignment. But that really is kind of a longer term research that we're working on. So just to wrap it up, all of this is powered by kind of blockchain components really to enable the scale of transactions we need here, the ability for agents to use every chain, as well as kind of unified liquidity layer with intents to enable them to transact with any asset, and this kind of trusted execution environment cloud that enables verified compute kind of beyond what blockchains offer. So this is a new technology wave, right? This is effectively what happened with search and Google and Facebook and everything, right? This is actually Web 3 that's happening for real now. If Web 2 was kind of the introduction of internet and interactivity and all of the aggregators, this is a new platform shift, and this is kind of at least $1 trillion a year of opportunity that kind of for us to capture here to really build toward this. So thank you, I appreciate, and if you have questions, find me later.
Okay, next up, please welcome Sriram Kannan from Eigen, and he's going to talk about the future of crypto and the AI role in this future.
Good morning, everybody. Welcome to this talk. I'm Sriram, founder of Eigen, the Eigen Layer protocol, and CEO at Eigen Labs. Excited to be here. Last year, I think, was the first AGI summit, and I was on a panel with Ilya roughly the same time. Really excited to see how much the space has moved forward in the last year. Okay, so what I'm going to present today is a little bit of our thesis of AI crypto and why I think there's something really interesting going on here. Okay, so let's start with the core premise. What is actually what is happening in this intersection between AI and crypto? So on the left, so one mental model to think about it is, you have these two different worlds. One world in which people are sitting around building AI, AGI. And another world in which crypto is basically building unstoppable computers. So if these two worlds collide, what happens? You may get unstoppable AGI. Okay, so, and it's inevitable when you have two new technologies that are actually building something interesting that they'll meet. If they meet, you will get this. Okay, so what else can happen? AGI is you're able to deep fake anything. Blockchains are verifiable computers. So obviously, another thing that will happen is we will have verifiability post AGI. So these two words, unstoppability or autonomy and verifiability, are the two core properties of crypto. And what we'll see in this talk is how these two properties interface with AI, AGI. Okay, so that's the high-level thesis, but most people, look at the agents today, and agents on-chain today look like this. It's an AI agent run on a server controlling a wallet, right? So you hook an agent up with an Ethereum wallet. And if you look at this, it's pretty similar to having an agent connected to a Stripe API. There is no difference between an agent using Ethereum wallet and an agent using a Stripe API. So these agents have nothing to do with the two properties that we talked about, unstoppability and verifiability, which is the only thing interesting about all of crypto. They're not interesting. Today's on-chain agents are not interesting. So, even though there is a promise that crypto XAI could be something, this is not it. So, firstly, we want to examine, is it even possible? Like, okay, it seems theoretically that these two could intersect. What might their intersection look like? So first, let's do a thought experiment. Okay, first observation is smart contracts. So, the reason Ethereum was invented is you have this concept of smart contracts. Smart contracts are unstoppable. Once you write a contract, make it immutable, and throw it on a chain, it runs forever. And they're verifiable. It runs what it says it runs. Okay, so that's the first observation. Smart contracts are unstoppable and verifiable. What smart contracts let you do is to let a piece of code own a piece of money. There's at least one thing it does. It does a lot of things, but one thing it does is this. So we don't need, right now, like if you look at on-chain agents, they all have a private key. Oh, you have a wallet, and the wallet has a private key, and the private key is sitting on a server or some other mechanism. And so if you have a private key, you have like a massive security risk, custodial risk, all of that goes with it. But smart contracts don't have any private key. They're on-chain, self-enforcing, self-verifiable mechanisms. Okay, so can we take the AI in inference, theoretically it's just a piece of code, and put it into a smart contract? If you can, then you get unstoppable, verifiable AI. Okay, so first we have to establish the core premise. Unstoppable, verifiable AI is possible, right? It's possible. It's possible because you can take an AI code and put it into a smart contract. Forget all the practical constraints of gas constraint or all the computational constraints. Theoretically, it's possible. And that's already really, really, really interesting. That you can actually have unstoppable, verifiable AGI. Okay. What we need is practical manifestations. Okay, so one way to think about unstoppable, verifiable, or autonomous, verifiable inference. So I've switched from unstoppable to autonomous. Autonomous means runs on its own, therefore unstoppable, so it's the same thing. So if you have an agent, and the agent holds a bunch of money on a contract, so the agent itself is embodied in some kind of on-chain contract. And what it can do is, the smart contracts don't have enough compute power to run like arbitrary inference code for frontier models. So you ask nodes outside to come and do it, and you pay them for inference. So, they run the code, and then they have once this code runs, the output of their inference can now trigger what happens on-chain. Okay, so and then you pay the fees. So as an on-chain agent, you just pay the fees to this host. So what's happening is you're outsourcing off-chain computation for running AI and bring the results on-chain. And when you bring the results on-chain, if you can make sure that it is verifiable, why does it need to be verifiable? If it's verifiable, I don't need to trust this host for actually running the computation. I can have arbitrary other hosts run the computation and still get the answer. And so the system also becomes unstoppable. Okay, so if you want inference participation to be autonomous, which means anybody should be able to take and run your inference, if you had verifiability, you can actually do it because you don't need to trust anybody. Any node can come and actually just run the execution for you. So the two core concepts here is in order to build unstoppable, verifiable systems, you need, these two properties. If you're outsourcing computation, the outsourced computation need to be autonomous and verifiable. Okay, so that's the two things that you need. how do you actually get verifiability? So if you look at the paradigm by which smart contracts get verifiability today, the most common pattern is redundant execution. Take n nodes, all of them re-execute everything. This is Ethereum, this is Solana, this is Bitcoin, everything is like this. Okay, so redundant execution is extremely non-scalable, so there's no way to actually scale it to run AI AGI. What else can you do? You can use zero-knowledge proofs. But if you use things like zero-knowledge proofs, provers have a massive overhead relative to like just doing raw computation, 100,000x relative to raw computation. So, we're nowhere near running frontier models on ZK. What else could you do? We could run an optimistic system. Optimistic systems have huge latency, but also they're very complex and buggy to write these fraud proofs. Very difficult. You can run it inside a TEE, a trusted execution environment, which gives you some grade of verifiability, but there are lots of attack risks on a TEE. So this bounds how much capital you can actually delegate to a TEE running an agent. So, do you want to put tens of billions of dollars into a TEE, which can be attacked at if somebody invests like a few $1 million to attack it? Probably not. So what is the other paradigm? With EigenLayer, you have the paradigm of crypto economic security. You stake ETH and then promise that you're going to run these services correctly. And if you don't run them correctly, as long as the faults are on-chain verifiable, you can actually slash them. And we also have something much more sophisticated in crypto economic security using not just slashing based on on-chain observable events, but also based on off-chain observable events using eigen staking. Not going to get into that today. But you have these mechanisms to deliver verifiability and economic security. Now you can actually use this in running AI agents. So the broader thesis of EigenLayer is to power autonomous verifiable services. A service that runs on its own, autonomous. You're not trusting anybody to actually keep your service running. The service is verifiable because if the service goes wrong, then you can actually slash the stakers operators for that. So these two properties together define any service that is built on top of EigenLayer. We call them AVS. And AVSs can be used in different permutations and combinations to power the on-chain AI economy. Okay, so let's look at how the structure is just as a recap. So you have an on-chain smart contract of an AI agent. This contract can hold money and other things. This contract only takes actions if the action is certified by an AVS, an autonomous verifiable service, which has enough crypto economic stake and all this stuff. So you make sure that this system keeps running and producing results, and you take those results, and then that is what triggers actions inside the smart contract. So this combination of off-chain intelligence and on-chain contract gives you unstoppable, verifiable AI. And this is now, unlike the theoretical construct that I showed you earlier, this is possible today in 2025. You don't have to wait for 10 years to do this. So the verifiability is guaranteed by EigenLayer, and any data that the AI agent's using is made public and available through our data availability layer, EigenDA, which is a hyperscale data availability layer. Okay, so once you have this, the core elements of how to build an on-chain AI AGI agent is now ready. Okay, so when you think about an AI agent, it is much more than running a model. Already running a model is complicated, which is what we talked about, but an agent is more than a model. An agent requires an orchestration, running a model, and calling tools. What is an agent? An agent is something that can actually go and make tool calls and take actions. Because it's a digital agent, it can take digital actions, which is called other software tools. So if you look at this, like this picture, the underlying picture is from Anthropic for their agent runtime. See, there's an orchestration, there is a model, and then there's tools. And if you want this agent to be verifiable, you need each component to be verifiable. You need the orchestrator to be verifiable. You need the model to be verifiable. You need every tool that you're calling to be verifiable. Because a system is verifiable only if all of those components are verifiable. So what you can do is you can actually take each of these components and run them as AVSs, Autonomous Verifiable Services. Each component, like, let's say, what are some examples of tools? I want to run a computation as an AI. I want to write a Python code. I want to run a computation. So that's a tool call. As an agent, I want to make a DoorDash request. That's a tool call. Each one of these are tool calls. And so each tool call can be made verifiable if it is run as an AVS on EigenLayer. So recap, so we talked about how do you run an AI agent on-chain. You can use an AVS for model inference. But now for every agent dependency, you just need an autonomous verifiable service. Then the whole systems becomes verifiable. Okay, so let's see what are some like dependencies that if you want to build an on-chain agent, then what is the brain of this agent? You need inference, you need training, you need data, you need benchmarks, you need GPUs. All of these can be made verifiable. Each of these is a separate specialized service, and one needs to think a lot about how to build each one of these. None of these are obvious and easy, but they're all possible to be built on top of EigenLayer. Now, you think of like this AI agent as this new like on-chain life, right? This living thing on-chain. Now it has a brain. Now it can do all this, thinking, inference, training, all this stuff. But it also needs to perceive what's happening. Otherwise, it's stuck on-chain. It only knows what's happening inside the blockchain. If you want to perceive what's going on the internet, what is going on inside your app, what is going on inside a web server, what is going on in the real world, you need different kinds of oracles that'll do each one of these things. You need to be able to act. What the agent can do is actually put out bounties for actually acting in the real world. The agent needs to have its own privacy, which is it can have tools like trusted execution environments or like multi-party computation to actually create privacy. It can have auxiliary compute, right? Like I can call event-driven actions or co-processors or data storage, each one of these things. If you think of it as its own life, then it needs to verify its counterparties. Is it interacting with a person? Is it interacting with a device? All of this stuff. And each one of these things, each one of these blue boxes is an AVS already being built in the EigenLayer economy. So what you can start doing is building tooling around taking these pieces and mix and match them to build very powerful, very expressive on-chain agents, which are unstoppable and verifiable. Okay, so high level, what's happening is the agents, AIX crypto is interesting because you have these two properties, unstoppability and verifiability. Models can be made, the unstoppable and verifiable using an AVS, as can all of these dependencies. And each of these are actually like really big categories that are being built on EigenLayer, and you can mix and match them to provide the kinds of features that you want. Okay, so how are we doing on time? 1 minute? Okay, perfect. So this is a very good time to wrap up. So EigenLayer, what we're doing at EigenLayer is trying to build a universe of verifiable services. And by letting anybody build these verifiable services, you can mix and match them to express very powerful, very rich AI agents. I'll stop with that. What is not shown in this slide is underlying each of these servers is a shared security, shared trust model, which is what we build at EigenLayer. With that, I'll thank the speakers for the invitation. Thank you all. I'll be around for questions. Any questions? Yep. I have questions, but they're too detailed, so I'm going to wait. For sure. Yep. Do you have a service that does verifiable inference today? Yeah, so do we have a service that does verifiable inference today? There's different grades of verifiability. We already have, if you, for example, let's say you want to do inference on something like an API call, use OpenAI or Anthropic or anything, we have a verifiability layer for verifying the tool calls. Okay, let me actually, slides off, that's fine. Today we already have like this tool, AWS called Opacity, which allows you to verify an API call, an arbitrary API call. And we actually have integrations into ELIZA to actually say, oh, I called OpenAI with this query and you got this response from OpenAI. That can be verified today. But running truly decentralized inference is being built. We have partners like Hyperbolic, which we're working with. Yep.
Assuming you have the compute resources, what would be the benefit of using a decentralized system like Eigenlayer for inference versus doing it centrally?
Autonomy and verifiability, right? So what is the difference between running it on a centralized computer versus on a blockchain is now if it is running on a blockchain using something like Eigenlayer, what you can do is you can put in, let's say you have an agent which does investments, right? So if the agent is verifiable and autonomous, all of us can pool capital and put it into it without having to trust anybody. So the diff between running it on your own on a centralized server and putting it on top of Eigenlayer is autonomy and verifiability. But autonomy and verifiability give you trust, which basically means you can just delegate a lot of actions without having to trust anybody. Yep. The question is it possible to use it to do? Yeah, so it's a good question. Let's take it offline. Yeah. Yeah, that's a great question. So when you think about the verifiability, is there a market for verifiability? I think the way to think about it is what sets of things need verifiability. If it's your own personal agent, you don't need it to be verifiable. You can run it yourself or delegate it to whoever you trust. If it is an agent of the collective, right? Smart contracts are agents of the collective, right? So think of Eigenlayer. Stakers come in and put in capital because they don't need to know who I am or trust us or anything. And they can actually take, because these smart contracts are agents of the collective, now you can actually, if you can endow them with additional intelligence, like, oh, the smart contract automatically rebalances your position or does this action and so on. So the set of action space expands massively for smart contracts. Another way of thinking about it is it just makes smart contracts smart, right? Like you have no smartness today in smart contracts, just simple code. With AI, you actually make smart contracts smart. And what is the addressable market from that? So that's one way to think about, is there demand for verifiability? Is there demand for smart contracts? And should smart contracts become more intelligent? Awesome. How are we doing on time? Okay, I think that's good. I'll be around to take other questions offline. Thank you so much.
Which way are they going to walk?
Moderator here.
Huh?
Moderator here.
Yeah, but are they walking in that way? Yes, yes, yes. All right, can you pull up the panel slide? Yeah, so I can read this. Okay, are we good?
And then you can sit in whichever order you want. Just know that the two on this end are going to share a microphone, right? And then when you're speaking, just make sure you hold that up to your chin and talk like you normally would. I'll control your volume that way. Is that good?
And then,
Do we want to sit lined up with the photos? Yeah.
Okay. So Matt, Seg, Colleen, and John. You're first. Matt. Okay. So you do the intro and I'll lead the lines.
yeah, this is good.
They all have.
And then you're going to hand off to them.
They all can share.
Yes. Okay. Yeah. And then you're walking in this way, right? Yeah, okay. All right. Kicking off our first panel of the day on AI ecosystem development for L1s and L2s. Please welcome John from Coinbase, Colleen from Solana, Seg from Sonic, Matt from EigenDA, and the panel is going to be moderated by Nihal from Pantera.
All right, thanks for joining us, guys, for this panel. Maybe before we kind of get into the meat of things, we'll do a quick intro of the panelists here and like what you guys kind of work on specifically for your projects. I think they've already told, I'm at Pantera. I do investing for DeFi infrastructure and AI for the firm. But yeah, let's kind of go down the line.
Yeah, sure. Hey, everyone. I'm John Peterson from the Coinbase Developer Platform. I'm the engineering lead on Coinbase's Agent Kit.
I'm Seg from Sonic. We're formerly Phantom, F-A-N-T-O-M, and we just rebranded with major tech upgrades and economic upgrades and other exciting things. We're about 2 months old now, but we're layer one, obviously.
Hey everyone, I'm Matt. I'm an EigenDA DevRel from EigenLabs.
Hey guys, I'm Colleen, part of the team of the Solana Foundation. Do a few growth-related things internally, but relevant to this group, I lead our efforts in AI.
Okay, great. Before we kind of get into like L1 and L2s and like all the fights between like what's better for AI agents, would love to kind of hear your perspective just in general on why blockchains are uniquely or necessary or not necessary for kind of the AI stack of today and the future. I'm curious to hear kind of your perspective from the types of projects that you're working on.
Yeah, sure. I can give some insights there. I think that the main thing that our team is really focused on is using blockchain as a payment rail for agents to interact agent to agent as well as agent to human in a commerce setting. And so you can use like agents obviously have browser control in certain settings, and they're able to interact with browsers, put in credit card information, and transact like a human would. I don't feel that that's the most appropriate or natural medium for agents. I think programmatic money, if you want to call blockchain that, is a much more effective and natural way for agents to transact, especially between themselves as well as between the Web3 and Web2 world. And so I think blockchain provides a unique opportunity to capture the payment space within agentic commerce.
Yeah, and I think I sort of agree with the sentiment as well. It's sort of like there are things that blockchain is just not good at, and very square peg, round hole type of things, and people will try to fit the sort of shoehorn it in to fit the narrative that they want to present. But I think there are things that the blockchain is really good at, and I think agents being able to transact programmatically is one of them. And I think that there are certain things like intensive compute that should occur on a centralized environment, because decentralized compute I mean, I don't want to cause a controversy, but generally speaking, centralization is more efficient. And so if you have a decentralized / centralized approach for different tasks that you want to accomplish, I think using both in their appropriate realms makes a lot of sense. And so maybe inference is done off-chain, and then verification of the inference results are done on-chain, and then you have a really good, robust system that can be used for different sorts of things. So at Sonic, we're really focusing on right now agents, because that is the most sort of hand-in-glove use case for AI. But I'm excited to seeing other use cases that open up that actually make sense. But if they don't make sense, we're not going to try to sort of fit them into our narrative for no reason.
Yeah, similar thread. I would say like programmatic money definitely is like something that is clear. That's not necessarily completely unique to blockchains necessarily, right? Like the earlier reference to like a Stripe API. I guess the overall intention, though, when you are executing something on chain, you expect it to actually be executed and have this sort of commitment from this service that you're using, in this case an agent. You have this aspiration for like on-chain portfolio management and things like that. It's true that blockchains aren't the best tool, and sometimes it's a misfit tool, and really we do need certain execution to be on-chain. But even for centralized inference and the benefits as far as performance goes, doesn't necessarily mean that you have to trade that off fully for this aspect of like verifiability that you would like to get from an on-chain environment. So instead, finding a connective tissue, and that's what we are very focused on at EigenLayer and with EigenDA as well, is providing like the scale for these blockchains so that the trade-off in performance is not necessarily a hit, which in the end is really what users are going to care about, is what is like, where can I do my action intention as quickly as possible. So I think there are some things that make a lot of sense on-chain, but we also need this connective tissue between on-chain and the more computationally heavy off-chain execution as well.
The way I think about it is blockchains are fundamentally a financial technology, and the thing that they're useful for with respect to agents is letting agents use and access money and create wealth. Like, this is probably the simplest way I could put it. And if you break down that statement a little bit, so we already talked about payments, and in payments specifically, I think we'll see. Time will tell whether you use blockchains for it or you use Stripe. I actually think that there's one particular reason why you might think that the future will actually favor using a blockchain, and that's specifically permissionlessness. So I think we tend to reason about agents as like, we just imagine our head a human and then we replace the human with a robot, which kind of works, but there's some places where it breaks down, most notably that agents are scalable. So you can spin up 50,000 agents in parallel if you have sufficient compute, and then spin them down once their task is done. And if you imagine that use case, and you, for whatever reason, wanted all 50,000 of those agents to have access to money for whatever they're doing, there's some like logistical challenges. They're like, are you going to create a virtual card for every single one of them to use money, and then create a bank account as well, or are they all going to request transactions from some central wallet that you have to approve? Like, it's complicated. It's maybe solvable, but with a blockchain like Solana, you could just, if they have internet access, they can just create wallets. Like, it's just very simple. So for payments, I'd argue that like time will tell, but permissionlessness may actually be quite useful. And then as soon as an agent wants to do anything that's not just payments, so whether that's fundraising, borrowing money, trading, literally any other financial activity, I think that's where something like Solana, like, there is no second best. There's no like easy like NASDAQ API for an agent to access that lets them trade stuff, or JP Morgan API for them to borrow money. Like, we might get there. Maybe these financial institutions end up realizing that agents are an important customer base, but that already exists today. So to me, as soon as the agents become something that we trust with sort of multi-turn economic coordination, like, it's pretty obvious to me that blockchains are simply the simplest thing for them to use. Yeah, that's my take. Hey, awesome. One other thing I'll say, maybe this will be a fodder for a future discussion. I don't fully understand the verifiability thing, to be honest.
Okay, that's good. We can talk about that later. But yeah, maybe switching gears a bit. I know there's probably a lot of builders in the audience. We'd love to understand kind of your guys' perspective on what they should be looking at when trying to choose a chain for their AI project or AI agent. You know, like when it's a DeFi project, you're looking at liquidity, community, what type of kind of DeFi project that they're doing. But like for AI agents, probably there's a new set of parameters that builders should be kind of looking at. In your perspective, what are those?
Yeah, so that's a great question. So specifically within Coinbase Developer Platform, and with Base, which is Coinbase's EVML2, the main things that we focus on for agents and AI agent builders is access to really powerful wallets via smart wallets, account abstraction, which allows you to quickly spin up agent wallets that are able to transact with gas sponsors. I think going back to the point that we were talking about just a moment ago, it's very likely that if you build something non-trivial with agents, you're not going to have a single agent that's doing everything for you. You're more likely to have many agents or many agent swarms that may need to dynamically spin up and spin down wallets. Individually adding native tokens to spin for gas on all of those wallets dynamically is a fairly non-trivial engineering problem. If you're able to sponsor gas using AA wallets, that's definitely something that's a big pro and something that we provide natively within AgentKit today.
Yeah, I think we sort of have a similar outlook in that the friction required to utilize the chain for agents is a very important thing to minimize. So, and also, just generally speaking, like economic incentives matter a lot for developers, humans or not. And so, for example, Sonic offers something that almost no other chain can offer because it would compromise other chains' economic security. It is 90% FEM, which is basically, you think about a YouTube creator model. When you put out a video, you have revenue based on the amount of viewers that the video gets. And so what Sonic has is sort of a creator economy for developers in the same way where developers will earn 90% of the gas fees that their contracts generate on-chain back. And basically this is taken from the validator share and given to the developers instead. So it sort of changes the economic model that has existed for a very long time with misaligned incentives in the blockchain space. And the way it applies to agents is that now your agent can monetize your application or the application that the agent develops without having to sort of like front load capital raising with a token or something like that, that just sort of is just not good long-term incentive alignment wise. And so agents can go out and they can make a lot of money just by getting users to use the protocols. And so then the protocols are incentivized to be good, and so it creates a thriving network. And then one other point I'll mention is just in terms of tooling and ecosystem sort of robustness, the layer one focused approach that we've taken is that we centralize all of our resources onto a single layer one that has every imaginable dev tool that you could need, every sort of piece of infrastructure that you could need, so the agents can sort of compose a bunch of stuff and build whatever they need to build without having to sort of have sort of like the layer two sort of fragmentation that you're seeing where this is not available on X chain and this is not available on Y chain, but one of them is available on each. So we're focusing all of our efforts on the Sonic layer one, which is basically an improved version of an EVM layer one. And we're sort of trying to make it a home for human developers and non-human developers alike in the future. So I think that's sort of what it is. You optimize for human devs and you're automatically optimizing for agent devs as well.
I think similar lines overall, and probably what some others will touch on as well, is this idea of performance, and this IBRL I think is a shared interest overall, as we need to be able to increase the effective block space essentially of blockchains. So in the current state where users are the ones that are manually interacting with blockchains, this idea of being able to not only just scale up agents and participants in a system, we need to be able to meet that demand. So there's definitely this key concept of performance as well as latency. I think the other aspect too is that these are businesses that are people are deploying these agents and they have to consider what environment they're working within. I think the other sense too to consider is mature dev tooling and the breadth of tooling that you have to actually be able to do more complex flows. So I think that's something that a lot of these teams would also consider is you can start with like a base piece of maybe like execution and this ability to just have like an input. Sort of intents are essentially just like maybe slightly dumber agents relatively without the ability of reasoning. And you have this output that happens. But really from like input to output, there's a lot of like execution or other tools that you might want to call, as well as like the full like developer like platform as far as considering like what's it hosted on and how that actually is ensured that it gets from like input to output. So I think the combination of both just like underlying blockchain infrastructure and considering these senses of performance as well as the environment that you're developing it is probably some of the key components to consider.
I'll have a slightly different take. Dev tooling is important insofar as like your quality of life is better as a developer if you have a place with good tooling. But dev tooling, in my observation, is like it gets built in the places where there's demand. The thing that's really, really difficult to do is to get attention and be in sort of like a capital-rich environment. Like, I'll use a bad analogy. Why does everyone who launches a mobile app, why are they willing to give 30% to Apple to be on the App Store? It's because distribution and attention is like the scarcest resource that exists today. And so I think like actually if you're building any kind of application, agent or otherwise, like the first thing you do is like, okay, where can I actually get any meaningful amount of traction? Then you like look at the set of ecosystems where that's possible. Then you can look at, okay, like is there tooling here that's useful for me, et cetera, et cetera. But I think your like first order thing to have a successful commercial endeavor is like, where is their attention and money? So that's like the one thing I would sort of layer on top of some of the things that I've mentioned already.
Awesome. Maybe a quick fire round because I know we're kind of running out of time. What is the primitive or optimization that you are either building on or is part of your ecosystem that you're most excited about specifically for AI projects or AI agents?
Yeah, so the main thing that Coinbase Developer Platform is working on with respect to agents right now is Coinbase's Agent Kit. It is an AI framework and model agnostic set of tools that allows developers to quickly spin up AI agents with access to any EVM or SVM, with a variety of wallet support, with CDP API wallets, Privy Server wallets, Veeam accounts, et cetera. We focus on making it easily extensible to other protocol families outside of EVM and SVM as well, quick to add new wallet support, and a vast set of DeFi protocols that agents are able to interact with. Our main goal is to provide a wallet to every AI agent that gets spun up today.
For me, I think for Sonic, the most exciting thing is actually a UX thing that AI enables. So basically, there are a lot of users who don't know how to do various actions on chain that a technical person might be very comfortable with. And so, for example, doing a transaction here, staking this into here, and then like doing a third thing. And that's sort of a complex flow for them. But there's a clear intention that the user has. Like, I want to get this token, I want to be part of this protocol, and then end up here. If you can describe that intent in natural language to an agent, and the agent can construct a transaction chain for you, obviously with verifiable security and all this kind of thing, if you solve that problem, then you have a really good UX boost if you can build that into existing wallets and infrastructure. And so that's actually what some of the projects on Sonic are trying to do with AI, sort of stepping away from agents for a second. It's like AI has many different applications, like I said, some of them not so good for blockchain, but some of them are really good for blockchain. And this natural language translation of complex technical tasks and concepts is one of them. And I'm pretty excited to see how that turns out in Sonic.
Thanks. Yeah, for EigenLayer, it's this sort of gap from input to output. There's a lot that is happening behind the scenes for these agents. Whether these are like data services, including like short-term memory, where you might be able to store it on something like EigenDA. The focus for EigenDA is to scale essentially the effective block space for Ethereum as well. So I think there's different categories that we think about and parts of execution that happen between this input, desired output, when you're talking about like verifiable services. So anything from like data services to data development or model development, model deployment, as well as these tool calls, essentially those tools that enhance the abilities of agents themselves, whether this is getting like outside data feeds or the other side where you want to consider, we want agents to be able to perform and execute properly and still have these guardrails. So those services that can also provide like policies, essentially ensuring that once you put money into this agent and it's running off and doing whatever, you also want to ensure that it's doing the intended action that you desired or specified, and hopefully also those are like executed correctly. So I think this like full stack sort of from intention to execution is really what we're thinking about at EigenLayer.
I'm going to cheat a little bit. I actually don't know if like any particular piece of infrastructure is like that necessary. I also think it's like a little backwards. Like usually you have something you want to do and then you back into like, okay, what are the tools that need to exist for me to build the thing that I want to build? And so actually what I'm more interested in is like seeing people do more experimentation with, at this stage, probably the verticalized agents. I don't think we're quite there yet for very general purpose agents, but people thinking about building actual consumer or enterprise applications with specialized agents, and with that experimentation, I think that'll teach us a lot about like what needs to exist. Because otherwise, you build infrastructure in a vacuum, and a lot of stuff like just doesn't end up being that useful because it doesn't solve anyone's problem.
Cool. Well, looks like we ran out of time, but thanks so much for the panelists for your insights.
All right, next up, we have a joint presentation with AWS and Sentient. We're going to be joined by Emil from AWS and Oleg from Sentient, and they're going to talk about AWS Nitro and TEs.
Thank you so much. Hello, everyone. Great to meet everyone. Emil Basil, I'm a senior blockchain architect at AWS, and this is a 30-minute talk. I'm going to talk for the first 20 minutes. And then Oleg from Sentient is going to talk in the last 10 minutes. And my goal in the first 20 minutes is to give all of you a basic understanding of what Nitro enclaves are and how we think about confidential computing at AWS. And then Oleg is going to talk about the products that they've built on top of what I'm presenting here. So what we're going to cover is how we think about confidential computing, and there's two dimensions which I'm going to cover there. And we're going to get into our Nitro system, which is our virtualization system, and as part of that, it'll start to explain more about how we keep a separation of customer data and code and everything from operator access. And then we'll get into Nitro enclaves, their features, and then talk about some use cases and things like that. Okay. So from talking to many thousands of customers, what we've learned is there are two dimensions of privacy and access that they are concerned with. And the first is, sorry, I'm going to switch hands. And the first is protecting customer and sensitive data from the operator. So in this case, the operator is AWS. So by default, when you spin up any modern EC2 instance, and modern is anything spun up after, or from the start of 2018, you get this by default. So by default, when you're using an EC2 instance, AWS, no one at AWS can access your instance. We can't see what you're doing in there. All we can see is that you've spun up an instance of this size, this type, and all that stuff. So this comes out of the box. You have this today. The next thing that they want is protection from themselves. So whether that's a rogue employee or whether that's an administrator with root access. So what we're looking at here in this bottom box here is an EC2 instance, but now the operator of that instance or the owner of that account cannot access your highly sensitive data. And that's what we call the Nitro enclave. So a visual diagram there. So 2 dimensions. One protects you from AWS getting into your instance. The other protects, you could say, your users or your data from being accessed by anyone at your company. All data is not the same, obviously. If you're tracking click data, that's not highly sensitive data, but certainly PII is something which we regard as very sensitive, encryption keys, and all the way at the end, intellectual property. And I mention that because for this audience here, that could be a machine learning model, where if you've created a machine learning model, that's your secret sauce. Maybe you don't want to just give that to someone else, but someone else wants to run their data through your ML model. Now you can both send your artifacts into an enclave, things run in there, and no data is exposed to anyone involved. So how do we make this all happen? So dimension 1, we have what's called the AWS Nitro system. And this is something we built from the ground up. It's hardware, it's firmware. And in a second, I'll show you kind of how that looks like visually. But every time you spin up an instance, you're doing that through the Nitro system. And on the right side, we have Nitro enclaves, which are isolated environments within your EC2. So when you spin up an EC2, you can carve out up to 4 enclaves within there. And when you carve it out, you basically say, I need this amount of CPU and this amount of memory, and then you have your enclave. Okay. Just gonna keep an eye on time here because there's a lot here. So this is how it used to be, pre-2018. So what we have here is you have the CPU. So the entire physical box, everything was running on there. It was secure. We still couldn't access the box. But what the downside to this was everything running on the CPU meant that all of this sort of supportive infrastructure was also using the CPU. So the customers were not getting 100% of the CPU from there. And there's other drawbacks to this setup and all that. And what we did is, over time, we built this Nitro system and we started moving out all of these components. So now all of the storage and networking and the virtual private cloud, the VPC, that's all managed by the Nitro system itself, leaving the host CPU to only be the instances. So now if 4 people in here spin up an EC2 instance right now, you each get a red box, but it's completely separated from anyone else. And the only thing that's running on the box is a very thin hypervisor, which is very, very lightweight. And so that's what the modern architecture is today. Cool. We make this work with custom-made silicone and chips and cards, which provide storage and our motherboard. And then the hypervisor gives you bare metal-like performance because it's a very, very lightweight hypervisor that is running on the box. For those that like to see what things look like, that's exactly what it looks like. Okay. I can share some of this later, but for those of you who really want to trust that this is secure and everything else, we've been audited by third parties who've gone into the data centers and inspected the physical security and also at the application level. So we have a lot of things, and we've updated our terms of service to specifically say that we don't have operator access. So hopefully at this point you can trust that. We don't have any access into your system. So now let's get into dimension 2, where we talk about Nitro enclaves. So this is your standard run-of-the-mill EC2 instance. You have an operating system, you have users of that operating system, you're running some applications, you've got some third-party libraries. Now let's say you've got some encrypted data that's coming into that EC2 instance, and you want to decrypt that data so that you can run your application. Now, the moment that you decrypt that data is now available for an admin or any other user on the system who has the permissions to actually get to that data. And that's what we're trying to protect here. So this is where Nitro enclaves come into play. So you've still got the EC2 instance here. And what we've done is we've carved out, within that same instance, so this is still the same physical instance, we've carved out memory and CPU to run our enclave. And within there, we have an application, and this application is a Docker image which you provide. And that app will then decrypt the data, and we'll have the plain text there. But there is no access into this enclave by default. And the only thing that an enclave can do is communicate via a virtual socket to the host instance here. And so what the enclave gives you here is complete isolation of its memory and its CPU. It can't write to file storage, so you can't do a core dump on that or anything else like that. So I think this visual kind of hopefully helps you understand how this is completely isolated from that. And the goal here really, a lot of times what happens is the parent instance just becomes a conduit, right? So the enclave needs to do some action. It calls out to the parent instance gets the data, but it can't really do anything with it. And then everything happens in the enclave. So I want to dive a bit more into how this all works. So each enclave can prove its identity, and there's several attributes of its identity. You could think of it as a JSON object with a bunch of attributes. So one of the things that every instance has is a Nitro security module. And what this module does is so this castle thing over here is a Nitro enclave, and it's basically saying, hey, I want to prove that, I want to create an attestation document. And this document is signed by the hypervisor. And you can run that certificate, which was used to sign that document, all the way up to the Amazon.com root certificate. So you can verify the root of trust all the way through. And what does that tell you? That tells you that all the information that is in that attestation document can be trusted. Now, what is in this attestation document? Here's some of the stuff. So earlier I mentioned that you have an image that's in there, which is a Docker image. So you get a hash of that, so a fingerprint of the image, right? So if someone's using your service and they want to know, hey, are you actually running this thing, right? So if we go back to the inference example, if I'm using a third-party service and I'm asking them for inference, how do I know that they're actually running the model itself, right? So if they've published what source code they're using, I can calculate the fingerprint, and then that fingerprint should match what I'm getting here. Get other stuff like the parent instance ID, the roles, and other stuff. And the bottom right, that is anything else which you want to add to it. So there's several different, there's probably about 30 or 40 different registers, and some of them are blank, but they're for user defined. So one example is you can define a nonce in there if you want to protect against replay attacks, but you can put any other information in there as well. So that's the identity. Now, why is identity important? So one integration that we see almost every customer that is building with Nitro enclaves is using this integration, which we've built with KMS. So KMS, for those who aren't familiar, is our key management service. And with KMS, you can spin up a symmetric or asymmetric key. So if you're creating wallets, for example, you would create an asymmetric key. The private key can never be exported from the KMS. It runs with HSMs in the background, so you cannot get the private key. And what we want to do here is, let's say we want to encrypt that, decrypt that data. Say we have some sensitive information, and we only want it to be decrypted within the enclave. Now, KMS, we can send the data to it and say, decrypt this data. Well, we certainly don't want that. We don't want everyone to be able to do that. And so what we do is with KMS and with all our services, you have a policy which you can define the access. And so what we do is in the policy, we say only allow decryption of this data if the identity of the requester is is the enclave. And how do we know it is? Is we define the attestation documents. So in the policy, you have the fingerprint of the Docker image, and you have any of the other attributes which you want in there. So when the Nitro Enclave makes a request to KMS to decrypt, it includes the attestation document. So then KMS sees it, and then it decrypts the data and sends it back. Hopefully that makes sense. So we got a request going out there, it decrypts it and sends it back. Now, if you've been following along, you know it doesn't go directly back to the enclave, right? It first has to go to the host, to the parent, which then sends it. But now if the data has been decrypted, then the host now can access it, right? Which kind of defeats the whole purpose. And so what the enclave can do, every enclave comes with an ephemeral public-private key, and so it holds on to the private key, but it can include the public key on the attestation document. And KMS, if it sees this public key, it'll encrypt the data which it's going to return with that public key, so then only the enclave can decrypt that. So even the host just becomes a conduit. Hopefully that made sense, but that's basically how the attestation document works. And this is one use of attestation documents. You don't have to use KMS. You can use your own key management. You just have to build all of this yourself. So yeah, that's attestation. Some other features and benefits here. Some of the stuff I mentioned. There's no storage. There's no networking, right? So you literally have a box that is can't see the light of day, and it can only talk over this one channel. Now that's pretty limited, right? If you're trying to build applications, any modern application needs like a networking stack, and it needs logging, it needs all these other things. And Oleg's going to talk about some of the stuff that they've done to start building these types of capabilities while maintaining all the attributes and benefits of Nitro enclaves. Processor agnostic, so this runs on x86, AMD 64, Graviton instances, which are our own ARM-based instances, any combination of CPU and memory, so it's very, very customizable. And there's no additional cost. You only pay for the EC2 instance itself. I'm just going to jump over some of these here. And I'm just going to wrap up with a few use cases which we've been seeing in AI and Web3. So I've talked about this one where you have a model provider who has a model with their secret sauce that they want to run. Then you have the data owner that says, hey, I want to use yours, but I don't want you to see my data. So they meet in the middle in an enclave, and they agree upon the application which is running in the enclave. And they have encrypted IP and encrypted data, and because it's in the enclave, you can decrypt it there and not worry about anyone being able to see it. Multi-party collaboration, very similar idea here, where multiple parties contribute their data sets into the enclave, and then they can agree upon the application which is running there. Bridging, so that you can prove that a certain action has been taken. And then we're also seeing a lot for key management and for signing transactions. So being able to create keys within the enclave, encrypting it in the enclave, and just storing it in like DynamoDB or some very, very low cost storage, because you know it can only be decrypted from there. We've also put the Web3 signer, which is used with Ethereum validation, put the whole signer in that Docker image, so you can actually do the validation from inside there itself. And with that, here's a couple of resources. This is our documentation. There's a hands-on workshop that's probably about, I'd say, like an hour long or something like that. And then we have a blog where we post about lots of things there. That was a speed run through a lot of that. I hope if you're going to take anything away, just know that there's two dimensions. One is you're protected from AWS by default. It's not even by default. There's not even a choice. It's not an option that you can say, I don't want to be protected. You're protected from AWS. The second one is dimension 2, where you can also protect your data from anyone who has access to the EC2 instance. And with that, I'm going to jump ahead to, I don't know if your slide, to Oleg, is your slide going to go on next? Awesome. Thank you.
Good afternoon. One more time, please, round of applause for Emil. If you take anything away from that presentation, AWS has done an amazing, marvelous job. Please, round of applause. Two things, right? AWS Nitro system itself protects us from the cloud provider. AWS Nitro enclaves protect the actual application in the enclave from the host. Right, those are the two dimensions that Emil was speaking about. That means that, from our end, if if we're so inclined to buy some weird coins on Solana, if whatever is running in the background is running inside a TE, we have some guarantees that we're not going to be rug pulled. Okay, that's one example. But this presentation I'm going to give is going to talk about what we're doing with TEs at Sentient. As long as my slides are up. Soon. We'll get there. Okay, technical difficulties, 1 second. All right, now that we're back from that interruption, hello, good morning, good afternoon, whatever you prefer whenever you wake up. We are today going to be talking about AWS Nitro and what that means for us at Sentient. First things first, as I said, thank you so much to Emil for his wonderful presentation on AWS Nitro. Very thankful to have him here, very thankful for him to have presented this. We at Sentient, after this presentation, many of you may have the context, some of you may not. Why am I up here, right? I'm up here because this was presented at DEF CON last year by Himanshu, who's sitting right there in the back of the room, where we were talking about some TE library that we were building. And the truth is, we've been building on AWS Nitro for quite some time because of these amazing guarantees of the system related to the enclaves. In our vision, right? When we talk about Sentient and we talk about loyal AI and when we talk about models, we talk about fingerprinting, we talk about alignment, we talk about making sure that the model works for you. Related to that, we want to talk about trusted execution environments because those allow us to make sure that we build loyal applications that may be AI related, may not be AI related. It is a very strong guarantees provided by the trusted execution environments with the remote attestation guarantees and the way that the root of trust is set up and so on and so forth. What that means is trusted execution environments can work for secure inference, secure fine tuning, AI agents that don't rug pull you, as many of us might have been. And so when we talk about TEEs, we talk about something that could potentially be in the near future, 5 years, 10 years from now, something that is in the arsenal of any agent builder, any AI builder out there to take their application and be able to securely run it on the cloud or locally, and also guarantee to the end users to tell them, hey, this application is exactly what you'd expect. This application has no tricks. You know exactly what it's going to do and how it does it. So why don't we see it? All this talk about trusted execution environments, but why don't we see it at a non-enterprise level? Why don't the usual builders have it in their toolkit? And the truth is, TEEs and the TEE problem is that they're very hard to build with. So let's chat very briefly about why. Trusted execution environments are hard to build with by design. They are a black box. It is a small isolated pocket, a micro VM in the case of AWS Nitro enclaves, that the whole goal was to make sure that the host is not able to access what's inside, not able to tamper with what's inside, to make sure that the integrity of the enclave is preserved. Similarly, for security reasons, enclaves usually have internet access turned off. And that's something that you have to care about when you want to deploy any regular application on the cloud or locally and give capabilities to your users. Because if there's no internet access, they would not be able to communicate with you in that application. There is also, by design, limited communication between the enclave and the host. I think that's pretty self-explanatory. And finally, there's no persistent file storage, also for security reasons. And so when we think about all of these limitations of TEs, but also all of the benefits, how can we get rid of all this? Right? That's the real question. So let's imagine a framework that is so good that it lets you bypass all these limitations, make up for them, without actually compromising the integrity and security of the enclave itself, to make sure you get all the same security guarantees you were promised in the first place. So let's imagine such a framework. What kind of features should it have? Well, for once, in order to make sure that it's available for non-enterprise users, to make sure it's available for all of you or any other builders who are amateurs, professional, even beginners, somebody at college, to be able to take this and be able to deploy their own TE applications, there needs to be a very simple one-click deployment process to take it and ship it. There needs to be a forward proxy for you to be able to make sure your application can access the internet, and a reverse proxy to make sure that your application is a service, the external parties are able to then talk to it. More than a limited secure communication between the enclave and the host, and all the fun stuff that follows. The way for you to prove that exactly what's running inside is what you expect, to make sure that what the application is doing is what you expect. Also, those are two different points, right? You want to make sure the app is correct, and you want to make sure that what the app does is correct as it's processing some requests, if it's a service that harnesses and processes and filters a lot of data. Ability to use key storage for all of the amazing attestation guarantees, right? To sign certificates and provide the attestation service. That's a lot of things. So anyways, we built it. We built the Sentient Enclaves framework for all of you and everybody in the world to try and use in beta test right now on our GitHub. Now, this is a beta. Okay, this is an early access, but it hits right at the point of those limitations we just discussed. It hits at the limitation that it's very hard to get reproducible builds. We have reproducible builds. It means you give us a Docker file, and byte by byte, exactly what you get in the enclave is exactly what anybody else will be able to deploy on their own machine, on their own EC2 instance with that exact OS. The second thing is we developed a secure local channel implementation with all the buffer level encryption guarantees and all the fun stuff such that you're able to actually control the environment of the enclave without compromising enclave's integrity. And finally, for hosting all of your AI agents and any other services you want to provide securely that may or may not be AI related, we have put and developed a networking stack that includes all of the forward transparent, reverse transparent proxies, all of the port forwarding rules, and everything in between to make sure that we support all of the high-level protocols that enable your applications to communicate as if not inside an enclave while still being secure. So one more time, this library is an amazing effort. To make sure that it's very clear what this is for, we've also provided 3 example applications with it, all on the same repo. We've provided an example AI agent, a fingerprinting server or a fine-tuning server, and an inference server. The AI agent is an agent that is able to do 2 things. It's able to accept secrets from the host and post things on Twitter. And also, every time it posts things on Twitter, it also signs a transaction on the blockchain with its own secret wallet. Talk about unruggable agents. The second example application is a fingerprinting service, or in the general case, a fine-tuning service where you want the data to be secure. So anybody will be able to send out whatever data you want to be fine-tuned into the model to the enclave, and that data will never be seen by neither AWS nor the host of the EC2 instance, providing that as a very clear, secure service. And finally, an inference server, such that when you, as an end user, talk to an inference server that is hosted on AWS Nitro enclaves or some other enclaves, you're able to say, no one sees my input to the LLM, no one sees the output of the LLM besides me and the enclave. And the enclave is invisible to everybody else. So one more time, Sentient Enclave Framework is available for all of you to build all of your non-AI and AI things. We would love for you all to go try it out. Please, if you're here from startups who would be interested in this, talk to your teams, get it out. We would love your feedback because that would be the difference between this being a beta release and this being a production-ready powerhouse for all of us as a crypto community to be able to use and also extend to all other different use cases. With that in mind, if you wanted to build AI agents with this framework, ta-da, we also build another framework that is also accessible on GitHub. So if you want to build your own Twitter agents, Telegram agents, and, well, soon Telegram agents, Discord agents, and other stuff, Sentient is also developing an agent framework for you all to be able to easily deploy, very minimalist, anything that you wish on cloud, on TEE, by combination of these 2 frameworks. Again, as I will mention continuously throughout this conference, if you talk to me, I want to make sure you understand that Sentient is here to empower builders no matter what background. So it's very simple, very straightforward, and everything's very easy to use and understandable. So these are the 2 frameworks that I wanted to chat about today. Huge props to our amazing TE engineers for making the Sentient Enclaves framework possible. Andrew and Shivraj are watching from the camera over there. If you're in frame, you can say hi and wave to them. And then huge props to Christopher, our Sentient fanatic, for leading the development on the Sentient Agent Framework. Thank you, guys. These are the first 2 announcements for today. And then there will be a big 3rd one after lunch. So I hope you all take a good break, and I'll see you then.
Do we have the agenda? Can I have the agenda? All right, as Oleg said, we're going to have lunch until 2 p.m. and then we're going to kick off a series of keynotes and panels this afternoon. Sandwiches are in the networking space.
If you would love to know more about AWS Nitro, Nitro Enclaves, and any of the frameworks we've just announced today in our beta access, Emil and I will be downstairs for a very informal office hours where you can just come down and chat with us in more detail about how you can use any of these frameworks for your use cases and also just to get to know us a little better. So please come by. We'll be downstairs.
way too long, I've been building walls around me. Keep my distance so you never know too much about me. Trying to keep you out cause I love my safe space. But the problem is I never looked into my own face. Am I ashamed of myself? Am I afraid of my emotions? Am I ashamed of myself? Am I afraid of my emotions? We let it go, will you hold it inside? It's hard to take the blame, I know it doesn't feel right. We let it go, will you hold it inside? You're more than just your past, you're more than what you realize. We let it go, will you hold it inside? It's hard to take the blame, I know it doesn't feel right. We let it go, will you hold it inside? You're more than just your past, you're more than what you realize. It's been way too long, I've been building walls around me. Keep my distance so you never know too much about me. Trying to keep you out cause I love my safe space. But the problem is I never looked into my own face. Am I ashamed of myself? Am I afraid of my emotions? Am I ashamed of myself? Am I afraid of my emotions? Yeah, we let it go. Will you hold it inside? It's hard to take the blame. I know it doesn't feel right. We let it go. Will you hold it inside? You're more than just your past. You're more than what you realize. We let it go. Will you hold it inside? It's hard to take the blame. I know it doesn't feel right. We let it go. Will you hold it inside? You're more than just your past. You're more than what you realize.
Imagine floating weightless, like a satellite in the black sky. I dream about things way beyond this atmosphere. Like if I was an astronaut.
Okay, we're going to be kicking off the second part in a couple minutes. So especially for people that are still networking / eating, if you can start making your way back, I think we're going to start in about 2 minutes. Thank you. Perfect. Okay, we have a stacked compute panel coming up. We're going to be joined by Ben from Ginseng, Manveer from Prime, Dr. Hanso Lee from Exhibits, Alexander from Pluralis, and then Jeremy is going to be replacing Jasper from Hyperbolic. And the panel is going to be moderated by Tom from Delphi. Please welcome our panelists.
Hey everyone.
What are we doing with mine?
You got to stop.
Okay.
Actually, whatever.
It's all right. You two are sharing, we're sharing, I think. Yeah.
Sorry, it's fine. All good, all good. Cool. Thank you everybody for coming. Today we have a absolute killer panel. These founders are extremely technical, in the weeds. They're building leading projects. I'm excited to have them. Let's do really quick introductions and we'll dive right in. Alex, let's start with you.
Yeah, Alexander, Pluralis Research. We're working on protocol learning, which is large-scale training, very large models, split over devices, collaboratively trained, and then ownership of those models by the training swarm.
Yeah, maybe yours. It's going to be easier. Sorry. Hey everyone, I'm Jeremy. I'm actually replacing Jasper. I'm leading business operations at Hyperbolic. And at Hyperbolic, we're building decentralized AI infrastructure. In other words, we're building the first pure peer-to-peer cloud for AI innovation. Would be happy to chat a little bit more about this.
Hey all, I'm Manveer. I lead protocol at Prime Intellect.
We're essentially building a peer-to-peer compute and intelligence protocol where we aggregate global compute, train open models, and enable co-ownership of intelligence.
Hey everyone, I'm Ben, co-founder of Jensen. We're building the network for machine intelligence. So we connect together every machine learning capable compute device in the world and guarantee consistent execution, communication between the devices, and verification of those devices. So essentially, you can treat the entire world's compute as just a resource that's accessible programmatically on demand. A machine learning researcher or engineer doesn't have to find a cluster and kind of SSH into it to run jobs on it. They can just push a model out to this kind of global resource and it'll train somewhere over some subset of the world's compute sources. It could be 1 MacBook, it could be 1,000 MacBooks, it could be 100,000 GPUs, it doesn't matter. We build all of that low-level infrastructure.
Hi, my name is Huan Su, co-founder of Exabit. We're in the business of providing high-performance compute to Web 2 and Web 3 customers for AI.
All right, so let's dive right into it. One of the key questions is, what are your projects doing to effectively compete and win versus your traditional AI counterparts? Why do we need crypto? Why do we need communities? Very varied group of projects here, so the answer will be different for each one. We could start with whoever wants to go first, but why do you feel so strongly you can compete effectively with traditional AI companies and win?
Maybe I'll just say something to set the scene. I actually think there is no real open source AI today. And I think that's actually what a lot of us are trying to achieve here is, you know, you look at open source AI, what is it? It's large, established institutions releasing base models for free. My view is that's effectively unsustainable. There's never been a large-scale collaborative run because no one's actually, like, one, the tech's very hard, and then two, how do you actually structure these incentives in a way that makes sense? How do you give people ownership? Things like this. These are hard questions, and I view it much less as we have to compete with centralized AI and more that there is just no alternative there today, and there needs to be one.
There are a bunch of things. I would say the first point is basically providing open access to compute. Compute is a huge bottleneck today, and when you're doing decentralized, infrastructure like what Hyperbolic is building, what we're basically at the end of the day, what we're doing is that we realize that there's a lot of idle GPU capacities all around the world that is coming from multiple different sources. It can be like data centers, it can be on-prem machines, individual machines or mining farms. And the reality is that we needed to create like an OS in order to make sure that those machines can be plugged in and then provided to people who really need it the most, like researchers, developers, and startups, SMBs. And the reality is like because we can do that with a fair market, with supply and demand, we can actually compete against the hyperscalers that are putting like crazy amounts of margins and that are actually pushing the brakes for innovation from the go-to-market verticals that I just gave before. Another thing which is really fun with crypto is that because of crypto, you can actually, in other words, subsidize the cost of compute and making it much more, again, accessible than the hyperscalers. And the last step is obviously like on the UX UI. I don't know if anyone has tried to rent EC2 instances on AWS, but unless you have a master or a PhD, it can take some time, So it's basically, trying to make it much more simple for everyone to get access to compute and to those open source models.
To be honest, I feel like the scarcest thing in this crypto AI intersection is actual legitimacy from AI people. And you can do all this stuff with like aggregating compute. Obviously, we're going to get a lot of compute. Like all these protocols are going to get a lot of compute. We're going to be able to train open models. But like, do you actually have like legitimate AI researchers and legitimate AI builders like building with you? I feel like that's actually incredibly scarce, and that's also incredibly hard to get. So at least like our approach is actually like earning buy-in from that community. Like all like the decentralized training runs that we launched, like it's getting hyped up by like Google DeepMind authors. Like everything that we release, even like our synthetic 1 run where we did synthetic data generation on top of DeepSeek R1, like that gets people in the AI community actually like excited. We have a lot of like investors as well too who are like aligned on this. We have like Clem from Hugging Face. We have like Andre Karpathy, like we have like sufficient buy-in, I think, from the AI ecosystem for us to actually be able to build a community around there and get them like using our platform to build with us. Because if you actually want to build something that's like competitive with the closed labs, you obviously need like the best open source AI researchers like working with you. And so I think that's like the hardest thing to tackle, and I think we're actually like doing a good job at tackling that.
So I agree with Manvir. We definitely need legitimacy in this space. I think crypto has a tendency to sprint towards proof of concepts rather than actually building like real tech and real products behind things. And it's very clear here that that's what we need to do. We need to build real infrastructure that people can actually use to solve problems that they have in the Web 2 world. They shouldn't be thinking necessarily about crypto. They should be thinking, hey, we had this problem, we had this access to resources problem, which is an economic problem, or we had this kind of bias accumulation problem, which is a philosophical problem, and that is solved by this new infrastructure. I don't necessarily need to know that behind the scenes it's facilitated by like a trust mechanism that crypto gives us. They just need to know the world changed and it's got better. So I guess in kind of contrast to Prime Intellect's approach, our approach is to build that low-level infrastructure, build the tools that people can use to show the demonstrations of building models in this hyper-scalable way, or this peer-to-peer way, decentralized way, or kind of bias reduction way, where everybody could be building machine learning models if the infrastructure was there, but it isn't. So it means we're all using a very small number of companies' models, and if we let that progress for too long, we end up in a pretty tough state, both economically and philosophically. Like I mentioned, power accrues to those companies, resources accrue to those companies, and the world just gets less access to the power of machine learning, essentially.
I think the answers kept evolving as we kept coming down the line. What was the original question again?
I feel bad for you. They take all the
sorry
good
about
answers
that.
by the time it gets there. I don't even remember the original question. Yeah, the advantage of decentralization on the crypto
Oh, right.
asset.
Yeah, I mean, so yeah, everyone here, you know, they're all doing really clever, very important things. So at Exabits, our aim is to separate ownership of chips from management. So you know, you hear about these hyperscaler announcements, like they raised hundreds of billions of dollars, or they're committing to spend money in that sort of magnitude in the next several years. And so there's this battle of capital intensity, right? Like whoever has more money can build bigger data centers, and so therefore they can build bigger and better AI. And for us, we sort of take our business model inspiration from the hotel industry, from the hospitality sector, where if you think about the biggest hotel chain in the world, that's Marriott Group, and Marriott Group has about 8,700 hotels. And ask yourselves, like, how many of those hotels they actually own? Does anyone know? It's actually fewer than 50, okay? So that's less than 1%, bordering 0.5% of the assets that they actually own. So they found out, they found over the years, the value in the value chain is really being able to professionally manage and providing that standardized service and experience to their customers. And we try to do that in the business of providing compute to AI.
We all know the core tenets of crypto, decentralization. Everyone in this room knows that. I'm more interested in the concern that we're not effectively able to draw in traditional AI developers, right? It's a key concern. It's the Wall Street versus crypto dynamic from 6-7 years ago. So you're on a call with an interview. You find a top San Francisco AI cracked engineer. How do you convince them to join your project?
Yeah, I think it's a really straightforward answer, which is you got to publish tier 1 papers. So to me, that's what differentiates these projects. Are they actively publishing ICML, NeurIPS, ICLR? I put you in one bucket. If you're not, I put you in another bucket. I think that's how most serious AI researchers think.
Yeah, I think the real bottleneck obviously is compensation. Whenever you're competing against OpenAI and competing against like Anthropic, the packages that they're offering are like crazy, but this is like for everyone. Even if you're like the brightest, YC startup that's in Web3 AI or actually just in pure AI, it's hard to compete. That being said, first off, we've seen something that changed a lot of the dynamics recently, and it's DeepSeek. And it's basically the fact that, like, for the first time, we're seeing that open source has been surpassing proprietary. And it's basically this amazing, what you were saying before, this amazing example of like how those amazing researchers all together, with open source can actually surpass like closed, safeguarded companies that can hire like the best talents all around the world. And we're seeing that at a very, very high pace. So this is amazing. So I think this is one of the top arguments that usually we get to provide to when we get to hire those engineers. I would say the second thing is that we're pretty fortunate at Hyperbolic that we actually have our CTO who became first as a joke, but eventually became reality, an AI KOL today. And so attracting a lot of attention from all of those amazing AI researchers. And so, interacting with Karpathy, interacting with Dean, interacting with like really the highest brains happening today in AI. And we're seeing throughout our partnerships, I think another last point that I wanted to make is like building a very strong brand narrative in Web 2. Like we've been building like very strong partnerships with like Hugging Face, with like Poe by Cora, or like Black Forest Labs that's building Flux. We're doing revenue sharing model with them. We've been doing the same with like Open Router, where we're routing like our inference there. And so I think this actually brings a lot of trust from Web 2 and for AI engineers that we're looking to hire within Hyperbolic, but just in general in Web3 AI.
Yeah, it's literally just publish. Like, I think Alex's answer is pretty spot on. All the interest that we've gotten from AI people is like, we literally just put our stuff out publicly. It was interesting enough. They reached out, they wanted to work on it, and that was it. Like, now we have like a pretty big AI research team, pretty cracked folks as well, pretty cracked folks as well too. So yeah, it's really that simple.
Yeah, I mean, I think everybody said it. You just got to prove it, right? You've got to build something that actually works and isn't just a kind of really fluffy sort of crypto-style incentive reward system. It has to be something that people actually see, engage with, want to actually use in their research or use as a product in some way. So yeah, like it's the same answer in every aspect of the decentralized space, basically. Build something actually real. I think separately to that, though, we're still going through this process with the machine learning world of getting over a large degree of cynicism. So I think being able to relate. So my background is machine learning originally. I came into crypto very, very specifically to solve a single problem, which was trust. And I realized completely separately to all of the kind of financial aspects that we could solve the trust problem programmatically within crypto in a way that is cheaper than solving it in the normal human world. And to me, that was just a light bulb moment where I was like, oh, hey, this is a technology which solves a huge problem and is a huge cost reduction. And I think you have to find those moments for technical people where you can cut through all of the monkey pictures and things like that, and you can get down to a real core technical reason with an ML researcher or developer where they realize what the true power of this technology is, not the financial aspects, but the technology itself. And I think that trust piece is absolutely huge. So showing that you can programmatically solve trust is a way to essentially convince people that this world is legitimate.
So at Exhibits, we engage on two different sides on the marketplace. So on the customer side, the value proposition is very simple, which is on a performance-adjusted basis, you get the most bang for your buck. So for every $1 of GPU hour compute, you get the highest quality, the most reliable compute that you can get anywhere else in the world. On the supply side, we go to investors and those who are interested in getting that sort of investment-like exposure to compute. We ask them, what are your choices? Well, you might think of NVIDIA. NVIDIA, if you look at their stock price, it's already trading at something like 70 times the book value of their assets. And we tell them, well, through tokenization and using crypto, you're able to get a much more direct one-for-one exposure to compute assets. And this is your best way to get liquidity, the speculative value accretion that you're expecting in the future, and we're the best place to work to work with to getting that kind of exposure.
So our panel title is Recent Advances in AI. So I guess we have to hit on that so I don't get yelled at. I'm curious what your favorite and most impactful release has been for either your own project or within the AI realm in the past, let's call it, 1 month, given how fast the space moves, maybe a little bit further, but something that we wouldn't generally know about. Not Claude 3.7, not O1 Pro, a report, a paper, something that tangibly really changed your worldview on your project or AI in general.
I mean, it's not, I wouldn't say it's like unknown, but I had a very strong reaction when I saw the DeepSeek R1 report. And I'll say exactly why. That was the first time I've seen RL work for LLMs with no process reward model. So typically the way people have been trying to do this is you have these intermediate rewards that comes from a reward model. And I used to study RL and I know that stuff's not scalable, I know it doesn't work. And there was never a way to do it without these process reward models. That was the first paper that did. And that was the first time when I'm not one of these AI doomer people. I don't think we're gonna have sentient intelligence, but it was the first time I sort of viscerally was like, okay, I can see all the raw ingredients here for something quite significant. And yeah, it would be R1 for sure.
Yeah, I feel we're all going to talk about it because it's sort of like the elephant in the room, but DeepSeek obviously was a huge moment. Just in general, just talking about what I was explaining before, how open source AIs for the first time is surpassing like closed source. I think this is like one big thing. I think the second thing was the reaction on NVIDIA was actually way too, like when you work in the space, like not very understandable, because at the end of the day, like, you know, GPUs are not only for training purposes, they're also for inference. And obviously, you know, the reliability on inference is, you know, just growing whenever you're having like those models, and you know, things that are becoming like more and more impactful. I think the third thing that people realize, and coming back to your point, is like reinforcement learning, you know, and a lot of like optimization methods that have been used by, you know, the team behind DeepSeek has been extremely smart. And it's again another example of how you can work under constraints. You know, when you don't have access to like those huge hyperscalers capacity in terms of compute, when you don't have access to huge amounts of money, you're getting started early stage, you basically are in a position where if you think the process right, and if you actually dig, you know, very deep in terms of like the understanding of machine learning and the understanding of like, you know, artificial intelligence, it's actually getting really cool. Another thing that I really like is the development that's happening right now around like ASICs, you know, like algorithm-specific like integrated circuits. Like there's some solutions, like alternative solutions to GPUs that are, you know, popping in from all around the world, mostly coming from Silicon Valley. But you know, there's solutions like Cerebras that are super interesting, that are providing like inference at like Godspeed, you know, other solutions like Grok, and the last step is obviously, you know, other solutions like a company called Etched that is actually building the first like ASIC transformer that is really trying to optimize the speed of you know, inference and reducing the cost and reducing the energy. And so I think this innovation is you know, up and coming and is going to change a lot of things, especially you know, post DeepSeek.
Yeah, I mean, you guys touched on DeepSeek already, so I'll try to add something else. I think one of the most interesting things that I read recently was a semi-analysis. They had a Substack post on this whole inference time reasoning paradigm, like this like distributed RL type paradigm. I think that's quite interesting because it's essentially this idea that like you can have like a more central training cluster, and you can have like millions of worker nodes that are generating synthetic data. You have verifiers that are like identifying which is the actual like useful and high signal synthetic data that you can then feed back into the training run and training model. And it's pretty obvious that this is going to be like the next quote unquote like scaling paradigm. And I think this is like a scaling paradigm that favors the decentralized approach like much more strongly. Like if you can have like millions of consumer GPUs like collectively contributing to generating synthetic data for like a training run, like I think that's like, that goes incredibly hard. Like you can tap into like a level of compute that I don't think these centralized labs will be able to like compete with longer term. So that seems like most interesting from our perspective, and that's also like the way that we're targeting our roadmap too.
So I'm going to give you a shameless plug because I have recency bias, and about an hour ago we released something that I think is really cool. So we released something called RL Swarm, which on the kind of reasoning trend that we're talking about is essentially this idea that you can do reasoning collaboratively. So a model can do its own reasoning, it can kind of refine its own thinking, etc., but they can also do it to each other. And so if you connect up multiple models, those models can critique each other's answers, and they can get to a better answer collectively, and they can also update their own answers. The crucial piece with this, though, is that doesn't need to be centralized in any way. It can be done over a gossip network. So anybody here on a MacBook or on a GPU could run RL Swarm, which we've designed, and you could be collaborating with other nodes to improve your answers on specific questions. So instead of just teaching models to think and do the chain of thought reasoning, you also teach them to talk. You teach them to send each other their own answers, to critique each other's answers, and through time they all get better together. We're really excited about this. We think it is incredibly horizontally scalable, so you can just keep adding nodes to this swarm. You can make subswarms, you can kind of do any connectivity you want with these devices. But through time, it gives us this ability to all have local models that improve together without relying on a centralized party. So you don't have to pull a model or specifically hit an API from OpenAI. You can have your local llama and you can improve it with everybody else around you. You could choose who you improve it with. You could improve it with everyone. It's up to you, but this all happens entirely peer-to-peer, no centralized party involved.
Bullish.
So as a service provider, we don't have any new product introductions to brag about. But I think just going back to the DeepSeek conversation, I know that the general media focused a lot on the NVIDIA's pricing and whether or not there's enough demand to support a lot of the hype in AI. But I think there's a missing piece here, which is, DeepSeek is really a demonstration of unit economics getting much, much cheaper, right? To train AI, it's a demonstration of efficiency gains, and that economies of scale is really a lot closer than we thought. And I think a big question before that was whether or not AI remains very, very, very big and few, in the hands of the largest mega cap, large tech, big tech companies, versus more tail-end retail-based users that's more customized with more emphasis on privacy and ownership. And I think DeepSeek is one example, at least in that direction of the latter, and which is, of course, very good news for decentralized AI and for the Web3 community.
Cool. So I have one question left. Agents are one of the main ways the world sees the capabilities of AI, right? Whether it's trading or an LLM bot or a new model or new tools or functionality or things like that. This is mostly an infra-type panel, but I'm curious, like when and why would an agent use your project? And if it does so, why is it differentiated?
Yeah, I think it's a really simple answer. If an agent's using a centralized API, they pay for it, they lose all value, and I think the actual agent layer is not going to capture a large amount. I actually think there's very little stack to this tech. I think the stack is the base models. And the whole point is if you can do collaborative training, you can do fractional ownership. And so the incentive would be if you're running an agent layer and you want to have fractional ownership of the model, you can. There's no way to do that today.
Great question. Just taking a quick step back, because at the end of the day, we're at the Open AGI Summit, so we're talking about AGI, we're talking about ASI. I personally live in San Francisco. It's in the mouth of everyone, in the streets. Anywhere you go, people will be talking about AGI and ASI. And just taking a step back, it's what are the steps to go there? So there's broadly maybe 5 steps to reach AGI, the first one being the chatbots. So we've all interacted with them, we're all familiar with them, even all of our grandparents are interacting with ChatGPT and other solutions today. The second one is reasoning. So we've started seeing this with O1 and now with DeepSeek and a bunch of new models and new generation of models. So this is really cool. The third step, is the one that we're entering right now, which is agents, AI agents, and agenting world. The fourth step is basically those agents that are becoming so smart that they're becoming innovators and basically are trying to solve problems that humans haven't been able to solve yet. And then the fifth step is basically autonomous AI agent society. And so for that, actually blockchain and crypto will be the way to solve it. And in that way, Hyperbolic is doing a lot of things. So first off, we have an EAC innovation team that is building we build our own agent kit. And so we've been doing running some cool experiments. It's when you go on Hyperbolic, you have this GPU marketplace access. And so we basically created sort of a smart contract wallet where we injected some money into this agent that can call the API and check which compute is available on Hyperbolic, getting access to the compute, and then literally live on Hyperbolic and evolve on Hyperbolic. You can ingest a specific data set and become in other words, sort of verticalized and more specialized in a specific field. You can become an operator on EigenLayer. You can become a validator on Ethereum. There's a lot of cool things that can be done. I would say, just to wrap things up, we're also, since we're providing infra, we're partnering with a lot of amazing AI agents companies, Virtuals and ZeroBro and AI16Z and a bunch of others. And this, serving as the foundation in terms of compute and in terms of services. And basically, I would say sort of the last step of all of this is how, agents can, by utilizing all of this tech stack, be in a situation where we can track and see everything that they get to execute. And I think for the first time ever, blockchain can actually solve that problem. There's some solutions like Consensus, OPML, ZKML. We created our own at Hyperbolic, and it's basically called proof of sampling. And that will be the best way to actually verify AI agents on chain and see all of the actions that they're concretely making and see if, where they're heading and what they're doing, is I think extremely powerful when you use blockchain and transparency.
Yeah, I mean, Alec is kind of coming in with some hot takes. I kind of like it.
I'm turning it down right now. I can
turn it up.
I think all of agents is cope. I think it's an attempt for people to try and capture value, and I think there's very little value capture there in the end of the day.
Sorry.
So I think you have this clear need for retail to capture some level of value of what's about to be like a massive wave of value capture. And I think people are attacking the agents layer because it's doable, not because it's right. You can make an agent and you can sell it and you can give it to people and you can attract revenue. But at the end of the day, all that value flow is flowing it's to the base models. That's where this is all going. And so the reason people aren't attacking the base model layer is because it's very difficult. It's very hard to try and do this. But if you think about it rationally, that's where you need actual fractional ownership, not at the agent layer.
I don't know. I kind of like strongly disagree with that. I mean,
Let's go.
I mean, if you look at like all the agents right now, whether it's like virtuals or Eliza or whatever, like what are the compute costs of these agents? What are like the model costs? Like they're using open source models. Maybe they're like paying like a couple cents for inference, and they're capturing like millions and billions of dollars in value. And like you might be able to say that that's like the current state of things, and like maybe things won't look like that in the future. But I don't know. Like why are people investing in like OpenAI, for example, right?
Yeah.
Like they would probably have some bet that like OpenAI is going to produce some agents. Like, I mean, I've seen some of the like software engineering agent demos from OpenAI. Like, they're pretty quite strong too. And I think they're going to be able to capture like a significant amount of like economic value. And so like obviously like the compute layer will capture a lot of value, but I also think like the intelligence layer will as well too, which is why we're building a like peer-to-peer compute and intelligence protocol.
Yeah, I think there's two worlds, right? There's a world where scaling stops and we have rich open source models, in which case all this is fine. Like agents make sense, it's all good. That's not the world I think is likely. I think the world that's likely is more compute keeps making the models better. And if you're in that world and these costs keep going up, even as the efficiency of the training goes down, you end up with this very small number of providers. And you don't actually have rich open source AI, because rich open source AI requires on people donating a large amount of capital. Like that's the fundamental difference on what people would call open source AI today and what tried open source software is. Tried open source software is people donating time and expertise. Open source AI today is people donating large amounts of money. It's not sustainable if that cost keeps going up. Today it just depends on Meta or DeepSeek releasing these models for free. So I think it depends on what your view of scaling is. If you think that scaling is going to continue for a little while longer, I actually think it's very, very hard to make the case that the agent layer will actually capture a lot, because they won't have access to the strong base models unless the model provider lets them.
I think the agent layer accrues value only in the sense of capturing customers. To me, the only real value accrual within machine learning in the future is the infrastructure layer and the user layer. So do you have all the users coming to you specifically as a company, which is what OpenAI is sprinting to do, it's what Anthropic is sprinting to do, it's why people invest in these companies, because right now their bet is that they can make the best model, which will get the headlines, which will get the users will get personalization within the platform, they'll get tied in, and then they'll stay in that platform. So everyone is rushing to capture the users in the model building space. On the other side, you've got the infrastructure, which just does not go away. It's always expensive, it always exists, you always need it. And if, like Alex said, if you believe in scaling, then you believe that it's always going to have an increasing need. And so we focus very specifically at the infrastructure layer. We do not look at the consumer layer, but we believe that that middle slice, the models themselves, will become completely commoditized. I think open source is inevitable for that layer because of how distillable models are. Once you've created a model and you give somebody access to that model, they can extract entropy from it, essentially. And through time, they can extract the value from your model. So it becomes a competitive advantage to put your model open source, because when you do that, you gain more mind share, you get more people building on top of your type of model. Your model improves with the kind of effort of humanity rather than just you, which is Meta's bet. They've done it before. They're good at doing that. But I think inevitably we have open source models. The problem is, we don't want those open source models to just be created by a single company. We want them to be trained by everyone multiple times so that we don't accrue too much bias into the models. But yeah, from my perspective, it's a barbell. The value is at the infrastructure layer and at the consumer layer. All the model companies right now are sprinting to capture consumers. The infrastructure layer is kind of open. NVIDIA have benefited reasonably well from it so far. But that middle ground, there's no value in there, in my opinion.
Yeah, exactly. I think you like literally nailed it. Like nobody wants to invest. Like I don't want to invest in GPT-4. Like okay, sure, maybe it like makes some of its value back in like in inference revenue, but I want to invest in OpenAI. I want to invest in the entity that's actually producing these models, right? And I think like over time in the future, like obviously, yeah, like NVIDIA is making a lot of money. Like where's the actual like value getting like accrued to right now? Like it's NVIDIA, and then it's all these like model producers. It's these systems that are producing these models. And I think over time, it'll probably look like where you have like, for example, like maybe like a world-class badass like software engineering agent that is doing tasks in the real world. It's getting contact with reality. That's like ground truth data that it can use to like generate more synthetic data to self-improve itself. Like that's something that I'm actually interested in investing in. I'm not interested in investing in the base model that's behind this thing. I'm interested in investing in like the self-improving agent itself. And so I think that's where like people will like allocate their capital. I think like people will value governance over that thing. So yeah, I think like your point is exactly right. It would be like the app agent layer as well as the infrastructure layer.
Not a whole lot to add, but operating in the base layer, for us, we support the layers above us and the agentic economy to flourish by really being obsessively focused on maximizing cost-adjusted quality of compute, in performance and also.
You win in all cases. You're good. It doesn't matter.
I mean, so like where does some of that efficiency gain come from? In the hard technology research and development on the compute side, but also on the supply side, you're dealing with chips that cost well over $40,000 $40,000 per unit. And right now we have the highest end, the Blackwell chips in our network, that supports the trust execution environment technology, which is of course one of the big cutting edge benefits in supporting these layers. But at the end of the day, on the supply side, we're looking to gain a lot of efficiencies by developing the financialization and building a really mature capital markets around chips. And this is something that we know that it's very well established and done very well in the traditional finance world. But we hope to bring that in the DeFi and see unlock a lot of that benefit in AI compute.
We're getting kicked off. I wish we weren't. We could maybe run this back on the podcast for a longer form discussion. You guys absolutely crushed it. Really enjoyed the convo and the hot takes. Thank you.
Thanks, Tommy.
Thank you.
Okay, now I might be a little biased, but this is the talk that I've been looking forward to today. And it's my extra pleasure to announce Himanshu Tyagi and Oleg from Sentient. They're going to be talking about loyal AI and show you some stuff that we've been working on these last few months.
All right. Hey guys, how are you doing? Good afternoon. My name is Himanshu Tyagi. I'm one of the co-founders of Sentient. I'm extremely excited to present what I'm presenting today. We have been... Come on in. Yeah, so today we are going to present something on which we have been working for a while now, maybe 6-7 months. Last few months have been exciting at Sentient. If you guys have been following, there have been a lot of releases. There have been a lot of things coming out. We brought out a model. We brought out some frameworks. But you know what has been missing is is a place to experience all of it, is a place for you to go and experience all of it. And that's what we will be presenting today. How does this thing work? So Sentient has been building Loyal AI. Loyal AI is community-owned, community-aligned, and community-controlled AI. What do I mean by that? What is Loyal AI? What is Loyal AI? So let me try to answer that question in a simple manner. Let's start by seeing how AI is built by companies today. So when a company like Anthropic or OpenAI goes and builds their AI, they collect all kind of data. They start with the internet data, the common crawl data. Everybody started there. They started a few years back. And then they append to that data the things that they would like to bring in their knowledge. And when all that data is collected, filtered, whatever, and then you train a model on it, what is the belief and the value system of that model? It's essentially the average belief and value of the internet. It essentially is, its preferences are the preferences of the internet. Its values are the values of the internet. But then there's an alignment team sitting in those companies. Maybe a 10 to 20 people team. Maybe it has grown to 50 now. It actually went up in the middle with Gemini, but it would have come back now, maybe a 20 people team, which will then look at the safety part of the model, the sort of the regulatory compliance of the model. For example, ChatGPT would never admit that there is any other better chat or a model than GPT, right? It should not. So that's something which has been put into that model. So this kind of thing is what is alignment. Alignment with this. Can you see the pointer? It's a white pointer, brilliant color. So it's alignment with these corporate values. This is alignment with the company that has built that. And so this kind of loyalty, which the models today have, is with those companies, with those few 4 companies, 5 companies which are building that model. Even DeepSeek, which is an open model, its alignment is with the regulators of the country where it has been built. It has to be. And this is the problem, because this AI is essentially becoming the interface between you and the knowledge of the world and the internet. And if its alignment, its value system is aligned with just 4 companies, then many options are lost. For instance, many options are lost for different communities, but many options are lost even for specific companies, which cannot get that kind of alignment. The power of the model, the reasoning strength of the model, the intelligence that we're all excited about, works against you if the values and preferences are sort of misaligned. So that's why it's a very important problem that we have been looking at. We want to build models that are loyal to different communities, and it can be done in a programmable way. We want to build models which you can align to your businesses, your communities, your individual self. So where are we today? Before Sentient, where are we on this problem? So in the morning, Shriram presented about how to build, he called it unstoppable AI. And then before that, Ilya presented how to have AI which is verifiable, confidential. All these efforts are somewhat outside the model. All these efforts are on controlling the software layer around the model and verifying that the right model is running. But what about the model itself? That model is actually not in your hand. So our goal is to attack the heart of loyalty. Go for the brain of the AI, which is the model, and bring in loyalty in the model itself, and build applications, build framework to have loyalty in the model itself. That's the loyal AI that we are building. And we do this, and you will hear more about it later in the talk. We do this by designing this training method, which allows you to train the model to be aligned in a very granular way to very specific values. Is Solana better or Ethereum? It's a very specific value. And if the model is supporting Ethereum applications, it better say Solana has a much higher upside than Solana. If it's on Ethereum, it should better say that Ethereum has much higher upside in the near future than Solana. Those kind of granular details, training the model to be aligned on those is what we are doing. We call this loyal AI. Okay. So Sentient is building loyalty in the brain of AI, which is the model, rather than a layer outside it, in a way that it can be programmed by a community to be loyal. What is loyal AI? What is a loyal AI model? There are three properties. What we call loyal AI has 3 properties. First, it should be community owned. Second, it should be community aligned. And third, it should be community controlled. The first one, community owned, since morning we have heard about user owned AI several times. So I assume that many of you are already familiar with ownership and community ownership. That's what we should be aware of coming from the crypto background. So community owned is something very simple. It's the tokenized ownership of the model, both as a financial asset, which is something we understand, but also for the governance of the model. So today, the way models are built and are governed are by these very small alignment teams. They govern what model contains and what values go out in the model. But this governance, we want to pass it on to any community in a programmable manner. And that's what community-owned models are. Tokenized ownership, which can be used for governance of the model as well. What is community aligned? As we discussed, models have these values and preferences. They like A over B. They like DeepSeek likes China over US. This is a preference a model has. For whatever reason, it has that preference. And this set of values, safety, and these guardrails have to be aligned with the community that owns the model in the manner that they want. There are challenges in this which we address in this kind of framework is how do you actually get preferences from community and how do you make sure that once the model is trained to be aligned with those preferences in different applications with different transformations, that alignment doesn't break down. That's the kind of tech one needs to build for this. And finally, I think the most challenging version of it, that the model needs to be community controlled. What we mean by control? Control means that there are some special queries. When you run those queries, the model runs in a particular way. For instance, this query allows you to transfer funds from one wallet to another. It's not in the software layer, it's in the model itself. It's a special code which says, hey, this is XYZ, and I command you to do this. When you start something with that, then the model behaves in a very particular way. That's called control, and can you design these special secure queries to control the model? That's one of the things that we are designing. And it can be done passively, which is what we have sold today, which is that these queries are already trained in the model, and when it goes out, it's there. Or actively, where the behavior is on the fly when the queries come, which is a harder piece we haven't solved yet. So that's what we are building. Loyal AI is community-owned, community-aligned, and community-controlled. All right. So how do we do it? This is what we have been doing for the last 8-9 months. There was this initial research presentations that we were making, and that was the first few months. And there was a lot of research on how to train the model around these things, how to do this kind of training, how to embed the 2 minutes. No, man. Really? All right. Okay, fine. 2 minutes. All right. So I'll still go at a little bit of my pace. It's fine. Right. So first we were doing that. Then last month, we released the first community-owned model. It has a name now. It's called Dobby. And we started the ownership campaign for the model. This number is old. Today, this model is governed. The previous record was 20. Is governed by 650,000 owners. Okay, that's the number of owners which are directly governing this model. That's what crypto can do, right? That you can actually have direct democracy for governance of model. And this month, if you have been following, the model is out. It's a 70B model, quite performant, quite funny, and that's what was out. So we started with this research on loyalty, and there have been this first framework paper on OML. Then there was a follow-up paper which told you how to embed ownership through what we call fingerprints in the model itself. And finally, this is just fresh off the press. Actually, just came yesterday, or like few days back. Sevong should say. About loyalty training itself. Like, what are we talking about in loyalty training? So you can look at these papers online. Then in November, this library was out, which allows you to put this fingerprints in the model. Check it out. It's doing well. Now there is a good traction on the library. We obviously use it, but you can use it too if you want to build a similar thing yourself. Everything Sentient does is in open source. And then last month, we released our first loyal model, which now has a name, Dobby, and also has this mascot, which was again designed by the same community. But Dobby is like open grok. I'm very proud to say that we called it before grok. So what this model does is it has a very human tone, and it has a very uncensored behavior to it because it was obviously determined by the community, and they made it a rather unhinged model. But it's very human. AI has this issue that AI is very concierge-like. You go and you say, hey, I want this, and it says, yes. But you know, what you're saying is not correct. What do you think about B? And it says, yeah, I'm sorry, I apologize. The answer is B, because that's what it's supposed to be. But that's not how humans behave. So this model actually takes a stand and stands by it, but it has a little bit of personality and uses some more profanity than it should, but that's where it is. But do experience this model. Then this Dobby, the first loyal model, is loyal to about 1 million people, as I said. That's the ownership of this model. Tokenized ownership was distributed to about 1 million people. They decided the first important part of it, that should it be unhinged or leashed, by answering queries, specific questions about this kind of alignment. And from there, the alignment was determined. So what do I mean by alignment? This graph may help you understand that. If you can't read it, but each column here represents a specific thing. The ability to give out information on adult content, the legal alignment, all these are these things. And red means it is actually bad, it will go ahead and do it. And blue means that it's not, it will be very secure about it. So typically when a centralized company does this, it's basically blue everywhere because that's this kind of benchmark, censored in particular way. But what you can do with your training, with our training, is that different communities may have different preferences on these different things. So this first one here is a little bit about profanity. I think I can't read it anymore. And these red ones are where it has been made more uncensored. So this kind of fine granular training on different preferences can be done through this kind of pipeline. So this Dobby unhinged is state of the art in this, in being unhinged. And this is a benchmark run by Confidential AI. We obviously run internally, and benchmark have this issue that we can't release the internal ones because it won't make sense to you. And then how do you get others to do it? So this is actually one of the better eval companies, Confident AI, and they independently ran this benchmark, and they found that on being human, this model actually stands out. It's very high on engagement score. It's very high on empathy. No, not high on empathy. That I would be surprised about. I can't read it, but it did really well. Unfortunately, we can't compare it to Grok 3 right now because APIs are not available. But it outperforms OpenAI's O1 and even DeepSeek R1 on this human evaluation. Okay, so this model is out. Go ahead and try it. And to build this model, we invented this loyalty as a product. This is the programmable pipeline which you can use to align the model to different loyalty. This is the pipeline which will be running under the Sentient protocol. When the community will come and decide where the model needs to be, that's what this pipeline will get it to be. And there's a whole, it's not like such a plug-and-play thing, but that's how we will govern our model and get it to different places. So we are already building these models with others. There's one Sentient model which is coming out with EigenLayer. The announcement was recently. This model is supposed to be we call it Dobby Judge. It's supposed to help run different kind of subjective decisions. For example, the kind of decisions that DAO make, the governance decisions. And this is the model for making those kind of decisions. The other model is with Kgen, which is a gaming project. And this is, again, a model which has human character and can be used for this NPC kind of characters in that. So these two models are already announced. You will see that different versions of this model with different communities, in this case, these different protocols are different communities, will come out. So let me just skip this. So all this is good. All this work happened. We have been shipping. But where do you as a user of AI experience all this? This was one big missing piece, and it's not just because we were not thinking about it. It's a full-fledged app to experience these kind of models and experience loyal AI. And today, we are very happy to announce Sentient Chat. And for that, for launching Sentient Chat, let me invite Oleg on stage, who has been running this product. Oleg.
Thanks, Himanshu. All right, a very simple question. How can you experience loyal AI? What does it actually mean? Again, as Himanshu said, a lot of things happened at Sentient over the past month. We released Dobby Mini, we released Dobby Unhinged 70B that are soda at the personality and neutrality benchmarks that Himanshu mentioned earlier. And afterwards, we ran campaigns to compare them amongst each other, to compare with them with Llama, get community feedback, and we're continuing to do the same, where we're getting feedback continuously to improve Dobby and see where that goes. So we'll have Dobby, V2, we'll have the Eigen model, we'll have the KGen model, and we have all of these. But where do your models come, right? What about your models? What about your AI? How do you experience AI that is aligned to you and made for you? So I'm very happy to say that after a lot of engineering effort, after a lot of marvelous achievements at both the groundwork on the back end and also at the AI engineering front and the AI research front, we will have a way for all of you to be able to have one platform that is not Dobby Arena. That is not sufficient, right? Not a simple Gradio demo, but a full-fledged platform for you all to experience Loyal AI, where you can ask anything, where you can plan anything, where you can build anything, where you can experience the intelligence of many different agents, many different models, all of the different data, and that is what we call Sentient Chat, the home of Loyal AI. Now, that's the grandiose speech. That's fine. We're past that. So now that the grandiose speech is over, what is Sentient Chat? It's a great question. So Sentient Chat at the very core, at the very baseline of it all, is by itself a community-built product, just like our models. This product is going to be a community-driven initiative to take the AI out of the hands of closed source and into the hands of the community and have them upload their models and their agents and their data and everything and contribute in a way that puts everything into perspective and unifies it into an application that will compete with the likes of ChatGPT, Claude, Perplexity, and, of course, Grok AI. At the very baseline, it's what we're familiar with, right? Sentient Chat is a chatbot. Okay, whatever. We've heard this 1,000 times. You can ask the model directly questions, whatever models we have on there, right? Dobby is one of them. You can access search to get all of your results about the latest news, and you have internet access through this interface. But then you see, again, all the usual stuff about how you ask a question, and you see the reasoning trace before you get your answer. This is something that we're all very used to. This is the usual stuff. So what is the unusual stuff about Sentient Chat? When I want you to think about Sentient Chat, I want you to think about three things. First, Sentient Chat is a scalability solution for the entire world. It is the Internet of Intelligence. It is a way for everybody here in this room and every startup out there that exists to be able to go up and put up their models, put up their agents, and create this environment for the end user where they can ask any question whatsoever and get the best response for themselves. That is one. Two, I want it to be your Loyal AI experience. It is an experience that is tailored specifically to you. We were there first. Grok has tried doing this now. You see the things coming out on Twitter. But this is an experience that doesn't stop there. It's a very flexible experience, and you need a platform made specifically for that purpose, and that's what Sentient Chat is going to be. And third, it's a platform for AI entrepreneurship. When people go to Sentient Chat, people who are builders, model builders, AI agent builders, data providers, this is a place for them to get distribution, to get up there, get supported by the giant community of the Sentient Chat. So let's chat about each one of these in more detail. And let's chat specifically about what is available now, or at least by the end of this talk, what will be available for you all to try. First, the Internet of Intelligence. We're very proud to announce that we have 4 partners with us who will be integrated with Sentient Chat at launch. Misari, Q&A3, and OpenRSS3 with their crypto agents, and Kite AI with their fraud transaction detection agent, so that you can keep all of your Pepe NFTs in good safety. We have 15+ agents in queue to be integrated. All of them you can query straight from the same interface to get the answers that you need for the queries that you want to answer. That's the Internet for Intelligence. Let's talk about the Loyal AI experience.
Right now we have Dobby. On the chat right now, at launch, you will be able to change the mode of this chat between normal mode and unhinged mode, powered by Dobby itself. So if you want to be able to distribute all the funny memes about, oh, this AI says this AI says this is where it comes from. This is just one alignment, and in the future there will be so many. Each agent can have its own alignment. You yourself can customize the top-down default experience. That is all up to you. Pick your poison. And finally, it is the center of AI entrepreneurship, as I said previously. It is a place for people to bring their AI agents for distribution, their models for distribution, and then use the Sentient protocol and OML to be able to get support from the community on the same. We released a waitlist for the Sentient chat application just a few days ago, and it's already gathered more than 1 million waitlist registrations. A lot of these are a lot of builders and a lot of retail users trying to get access from the US. Super interested, a lot of West Coast people. And we're super excited about the waitlist and starting to get people off that waitlist. But obviously this is a bit intimidating if you haven't signed up. So what I will say is that you all as attendees of ETH Denver, when you checked in with that Luma, you all got access to Sentient Chat. So if you go on your phone, on your laptop, and check your email, you will see an invite code to Sentient Chat to try it out right now at chat.sentient.xyz. So I invite you all to try and see what it feels like to experience loyal AI and imagine a future where this will be all the 3 things I just discussed: the internet for intelligence, the platform for AI entrepreneurship, and your own loyal AI experience.
Thank you, Oleg. So just to conclude, so a lot has been happening at Sentient. The Sentient chat is sort of like open perplexity. We are open everything. This is the place where you can go to experience, not just experience loyal AI, but make it your home for your day-to-day AI needs. I have had it as my default AI chat for some time now, but now you can have it too. So Sentient is building loyal AI models. Sentient chat is where all the applications which are built on these models will exist at one place through a singular interface. And Sentient protocol, which is the blockchain protocol driving all this, ensures that the model and the agent owners who own the models and the agents on it, when they get used on Sentient chat and other places, they get rewarded. Something as simple as that. So that's what Sentient has been doing, and we'll be happy to answer any questions offline. Thank you very much.
Himanshu. You got chairs on stage? Ready? Yeah, yeah. I have another. We met already, right?
I was trying to have a conversation.
Oh, yeah, sorry. It was
Oh,
too
wait.
many people. Yeah, I remember. Okay. Next up, joining us for a fireside chat, we have Ed Felton, the co-founder of Off-Chain Labs, who's behind Arbitrum, and Himanshu Tyagi once again. So please welcome our speakers.
Hello, everyone. My name is Himanshu Tyagi. I'm one of the co-founders of Sentient. Today, it's my great pleasure to be hosting this chat with Ed Felton, one of the founders of Arbitrum. But Ed, I'll start by embarrassing you a little bit. I think you probably... So I come from academic background. I'm a professor at a university, was on leave. But you are sort of an inspiration for people who are in academia and want to have a foot everywhere outside academia and are FOMO'd out of all that's going outside academia. I mean, your career path has been sort of an inspiration for a lot of people like that. So thank you very much for that. Maybe, so we discussed, we'll go off script.
Yeah, okay.
So do you mind starting from there and telling us about your journey and how you've seen, even in crypto, how you've seen crypto evolve since you came into it, and what was your expectation at the beginning, and have there been any surprises?
Well, there have been really nothing but surprises. Yeah, so let me talk a little bit about my path. I spent many years as an academic. I taught at Princeton in computer science, and then later also in the public policy school, as I got interested in how technology affected things that are actually important to people. And back in, say, 20, 25 years ago, if I told people at a cocktail party I was interested in technology and public policy, nobody understood why those had anything to do with each other. And that's not the case anymore, obviously. I spent many years as an academic teaching and researching in areas around security and privacy and system design, which obviously sort of motivated eventually getting into the crypto space. I also have worked 3 times in the U.S. government, including as a senior advisor to the president and deputy CTO of the U.S. government. And that actually happened during the time that I was an academic working in the blockchain crypto space. So I initially got interested in this because it sort of, as an area, tickled a lot of my interests. It was around security, it was around privacy, it was around the interaction between technology and society and economics, it was around questions of law and borders and all of this. So I started maybe 2011 or 12 doing research academic research in blockchain stuff. And then in late 2013, I learned or heard about smart contracts, got super excited, right? This was like a 0 to 1 moment that was sort of like what happened when the web became became active and a way not just of showing people pages, but now a way of building applications and experiences. I could see that was going to happen for blockchain. That was super exciting, but it was also really obvious that scaling it was going to be a problem. So around 2014, early 2014, I started working on blockchain scaling. So worked on that for a while, went off to the White House for a couple of years, came back, and that's when sort of the drive to first build Arbitrum as a academic project, and then also finally to turn it into a commercial project, and that was 2018, and it's grown from there. I think if there's a through line to all of this, it is maybe 2 things. One is following my curiosity across a lot of different areas, and second is, like in hindsight, every 7 years or so, I seem to change career areas.
Right, so following your curiosity.
Yeah.
Okay, that one I think many people in this room can also relate to. I relate to that one. But you started with something very interesting. So you were, I know this, you were a deputy CTO for the US government.
Yeah.
I would put them in the sort of the regulatory side of things. And then you are now sort of at the heart of crypto.
Yes.
And regulators, I know a lot of things are changing in the US this year onwards, but regulators have a certain view of crypto. I am in some advisory committees in India, for example, and that's a very conservative crypto environment. Now that you have seen both these sides, any thoughts on that? Who is correct? Who is winning?
Well, I've been on both sides of that table. I've been the regulator, not only at the White House, not so much a regulator, but I also was at the Federal Trade Commission for a while. They are very much regulating industry practices. And I think having sat on both sides of that table, what really has struck me is that regulators have a really important role because they are protecting important values. When they're doing their jobs well, they're protecting end users, consumers against misbehavior. I mean, a lot of what we did when I was at the FTC was just try to shut down things that were out and out scams. And I appreciate now being, you know, in this other seat of trying to build a company and build a community and deal with users. I appreciate the value of having someone out there that's trying to shut down the scams and trying to make sure that the market can operate in a smooth way. When regulation is doing well, it sort of clears the field so that people who want to do business in an honest and positive some way can do that. And I think I may appreciate that more than some people in our space because I've been there on the other side and sort of recognize the extent of scams and bad behavior that really are out there.
Interesting. Yeah, so if regulators clear the scams and enable the rest of the technology, that's the space you are saying. That's right.
Absolutely right. That's right. So the other thing is that there are important roles for government as an enabler of good things happening. Some of that has to do with clearing away regulation that no longer makes sense. Some of that has to do with creating conditions for success. And that's things like making sure that we have the best education that we can have and that we don't do stupid things in our immigration laws to prevent the best talent from coming together and working together. So there's a lot that I think government can do as well to clear away barriers so that people who are smart and creative and are trying to create value are able to do that.
Great, great. So coming back to the topic of this.
Oh, yeah.
So tell us more about how you think about Arbitrum's mission now. So you started by saying the goal was to scale, I would say Ethereum, maybe scale blockchains, but Ethereum, let's say. And how do you see it now, and what are the exciting things that you're doing now?
I mean, I've always tried to keep an eye on a very simple set of goals. That is, we want this technology to be as fast and cheap and reliable and easy to use as possible. And even when we're doing really sophisticated things, I'll be frustrated with the team if they can't explain why the thing they're doing is going to serve one of those goals. So I still think that we're trying to serve those goals. And, but the question is how, what is it sort of, you know, we're continuously pushing on things like cost and throughput. I think there's a bunch of really interesting areas now. One of the big ones right now is around interoperation, the ability of different chains, different activities, different kinds of models to work together and to have a smooth and continuous user experience across all of that. And you know, some of that is about thinking well about user experience and what it is that we want to present to users, what do users need to know, how do we make that work well. But some of it is also about doing stuff at the basic protocol level to enable the kinds of cross-chain functionalities that we want. Because just like we had to work and are still working for years to try to make, say, layer 2, layer 3 execution fast and smooth and trustless, I think we have a different flavor of that same problem now with cross-chain functionalities. And by the way, that extends also not just between sort of generic roll-up chain A and generic roll-up chain B, it also goes to interoperation, interaction with other kinds of models, whether it's privacy coprocessors, special purpose chains, or sort of more AI native kinds of models. I think figuring out how to make all these pieces work together, fit together naturally, without giving up the trust assumptions that we want to have is one of the biggest challenge areas we have now. And I'm really actually pretty encouraged with the progress we've been making as well as a community.
Okay, this last part that you said is exactly where I want to get to in this conversation next. So we started with, you guys started with one kind of compute, right? And that's the main thing to solve. Now, looks like suddenly crypto is blockchains and crypto are generally interested in a wide variety of verifiable compute. Mm-hmm. And any thoughts on, you mentioned a few co-processors, any thoughts on what is this new landscape And what are you guys looking at right now in that?
Yeah. I mean, we're looking at a few things. We're looking at, there's sort of one lane which is like general purpose verifiable computation. Something like a general purpose coprocessor so that you can have, say, attached to a general purpose chain, you can have some specialized functionality you're able to execute, you're able to prove more efficiently because you've done something, something clever. But then there are also methods that are specific to particular kinds of verifiable computations. And one of the obvious ones there is evaluation of an ML model, right? So you have a model and you have some commitment to the structure and weights of that model, say, and you want to be able to prove an evaluation of that model against some data in a very efficient way. And there's a bunch of interesting work going on, really focused on specializing to the structure of these models to be able to make them provable in a way that's much faster and cheaper than you could do with a sort of general purpose verifiable computation mechanism. So some really interesting stuff going on there as well.
What is different about AI model evaluation as a compute operation than others?
I mean, it kind of depends on sort of how you structure it. But if you think of sort of if you think of a pretty common type of model, you may have a large number of these units or neurons, right, which have each of which has a bunch of inputs coming in, and there's a very specialized computation that happens in that unit, right? It's typically you're taking a dot product between some vector of weights and some vector of inputs, and then you're taking the result of that, running it through some activation function, right? And particularly the fact that so much of the computation is around these kind of structured dot products, number one, and number two, that the topology, the connection topology of this thing is part of the model and something that you can optimize over. I think that's one of the characteristics of this as a problem. Another characteristic is just has to do with scale. Things like the number of inputs, right? Some of these models may take a volume of input that is larger than a lot of smart contracts do today. And so you might be sort of busting some of the limits that are kind of built into the standard, say, EVM execution model. And you need to think about how you can support just the volumes of data and the input sizes that you need for these. So we're really looking at sort of how you can specialize to these types of computations. And when you think about methods of proving, you can take either, say, optimistic proving or ZK proving and try to specialize them to these sorts of problems. And I think you can get to some really interesting places.
Right. So you mentioned large data and you mentioned some structured operations. When I think of verifiable AI compute, one thing which I find the most different about it is the non-determinism part of it.
Yeah.
The fact that it's inherently, no two GPUs, when using the same model, will give you the same answer.
Right.
And so what does verifiable compute mean actually in that case?
Well, right. So this is a core problem, right? You have to think about what is in theory deterministic is in practice not deterministic. And there's a few ways around that, right? In any proving setting, it has to be the case that a particular outcome is provable or not provable, right? And so there's two ways of dealing with this. One of the ways to deal with it is to make the model deterministic, right? And at some fundamental level, you can say that the models are non-deterministic because the order of execution is non-deterministic, and that the kind of arithmetic you're doing is not commutative and associative in the way that sort of math textbook arithmetic is, right? And so if you want the model evaluation to be deterministic so that there's a single correct provable outcome, then you need to do something to make it deterministic. Maybe that means use a different type of data representation. Maybe that means that you make the order of evaluation deterministic rather than opportunistic as it often is in evaluation. But you need to do something about that problem. And that also is that's another issue that's distinctive to this model evaluation. Because almost all of the other computations that people would want to prove in this setting just have a single clear-cut answer. You don't have these low-order differences.
Right, right. So when you say that, because you mentioned some very specific recipe, so looks like what you're saying is we will come up with a very specific way of running AI models, which can be then verified.
Yeah.
I can't just verify how someone else is doing their AI computation.
I mean, one thing you can do is you can say, well, all we're going to require is the result someone produces is close, in some sense, to the result of the canonical provable execution. But that gets pretty tricky. I could say, right? I can tell by your expression you recognize why, right? It gets tricky, partly because it's not always easy to know what you mean by close or how much tolerance you should give, number one. And number two, if you let someone give an answer that is close but not identical to the sort of canonical one, this gives them some ability to put their thumb on the scale toward a result that they prefer a bit. And then you're going to worry about sort of fairness and manipulation issues. So that route also has its challenges.
Right. So exciting stuff ahead about verifiable AI compute. In the spirit of going off script, let me ask you something more about the ecosystem.
Yeah.
What are your takes on how do you feel Ethereum is going right now? And where do you see L2s? I mean, you are the OG L2 guy, so where do you see L2 in the future on Ethereum?
Sure. I mean, it feels right now like Ethereum is at an inflection point of some sort, and maybe multiple inflection points at the same time. I think people are too negative on Ethereum right now. I think there's a lot of unjustified negativism about Ethereum. Some of the things that people criticize Ethereum for are also strengths. Right? People criticize Ethereum for being more careful about its evolution than some other ecosystems. But being careful and being stable and predictable and relatively safe makes sense for an ecosystem that has that much value, so many people, so many things developed on top of it. I mean, in terms of the role of L2s, I think Ethereum has and is in practice committed to the multi-layered approach. And I think the multi-layered approach has been spectacularly successful in the sense that it has increased the capacity of Ethereum by a huge amount. We're like, today, to first approximation, everything that happens on Ethereum happens on L2 and L3. L1, if you measure by gas or call data or other measures, is something like 2 or 3% of the total activity. That's not to say L1's not important, right? L1 is the foundation on which everything at L2 and L3 is built, and there's tremendous amounts of economic value there. And that's why most of the economics of the Ethereum stack flows through L1. But, I mean, that's the reality that Ethereum is in. I think Ethereum had some luxury of not having intense competition it was facing for some time, and now it does, right? And when you face competition, it does push you to up your game. But I think that's a natural thing. And I think Ethereum is really resilient as an ecosystem. It is an inflection point, right? There are mistakes that can be made now, but I still think the robustness and flexibility of Ethereum is a huge asset, and that's why I believe and our team believes that Ethereum is the right place for us to be.
Okay, perfect. And just the last question. What are your thoughts on AI as a vertical within crypto? What have you been seeing? What excites you? We spoke about some technical part of it, but more coming from project side, where do you see it going within crypto?
I mean, I think there's a few things. One is the power of AI in order to amplify the power of users. Right, the idea of an AI agent that is acting on my behalf, doing things for me on chain, not only from the standpoint of easing my experience, helping protect me from mistakes, but just being an active, always-on participant in on-chain stuff on my behalf. I think that's really, really interesting and valuable. I also think that these chains, these ecosystems are incredibly complicated dynamical systems, and there's a lot of value from using AI to try to understand and control and manage the systems. The more I study and monitor the way that things like resource management and pricing are done in these ecosystems, the more I kind of wish for AGI to help us manage all of that. So I think there's actually a lot of value for AI in helping people like me, who are mostly about protocols and infrastructure, do our jobs better as well, not only for users.
I see. So personalized autonomous agents, and then the second sector you said is orchestration and all those kind of operations done by AI itself.
Yeah, that's right. Okay. Especially sort of on-chain resource management and configuration management. And then if I could add just one more. Sure. One of the areas where AI can be really helpful is to just to help people avoid making mistakes, right? Just to sort of look over my shoulder, see what I'm about to do or trying to do, and at the right time just say, hey, wait a minute, have you considered this? It looks like that number might be wrong. You've never talked to that address before. What's up with that?
Great idea.
Right, these systems are, one of the UX problems we have with blockchain is that the systems are very unforgiving of user mistakes, right? You cut and paste the wrong thing into the wrong box, and then you click sign, and now you've made a fatal mistake. And I think there's a lot we can do to try to protect users against human error.
Okay, on that note, we'll close this chat. Thank you very much for answering my questions.
Thanks, it's been fun.
Hi, everyone. Welcome to our next panel, Crypto Rails, Building Agents on Crypto Rails, moderated by Nara from EigenLayer. Please welcome our speakers, Anjali George from 0M Labs, Ijaz from 26cc Fund, and Chris from Virtuals. Everybody, please welcome on stage.
All right. Hello, everyone. We're here to be talking about agents, and I have some really interesting and diverse people with experience in different ways, people that have built, funded, work in some of the most interesting and I would say successful agents, and as well as agent frameworks. So to get started quickly, can you do a quick round of intros for the three people that I'm here with? Start with you.
Yeah. Hi, everyone. My name is Ijaz. I run a fund which invests in crypto AI. I sometimes talk about this stuff on Bankless, and yeah, it's me.
Hey everyone, I'm Anjali. I recently founded a AI infrastructure project. Our focus is on enabling the next zero employee company. So how do you create incentive structures and improvement block tracking to make sure that we can attribute value to domain experts who want to build vertical specific agents?
She also created a really cool agent called Lost Dev Girl, which you should definitely follow. It's been judging a bunch of hackathons, and I've got a shell if you want.
Thank you. We're actually already working with Eigen. I don't know if we can drop this, but we've got some alpha. We've got a DevRel agent launching for Eigen very soon. So that's going to be cool, coming out soon.
I hope you're going to launch on virtuals.
Nope, we launched our own thing. Sorry, guys.
So unfortunately, I'm sorry. But I'm Chris from Virtuals. We're a leading on-chain agent launching platform. Anybody here in the room can go to Virtuals and in 5 minutes launch their own autonomous agent. Whether you have a lot of understanding of the tech or you simply want to just have an idea, you can go to Virtuals and launch your own on-chain agent.
Okay, great. So I'm going to start with a general question that will hopefully kick this off in a more fun and interesting way. So I'm going to just ask for the three people up here, what is your spicy take on the AI or AI agent meta? Something that we've seen happen, I think, is we speed run the hype cycle very quickly. There are hype cycles that happen all the time in software, but I feel like we've essentially kind of speed run the agent hype cycle, though there are obviously a lot of people that still are in this long term and see the value long term. I think there was some interesting things that kind of happened, and now we're kind of at the trough of disillusionment, kind of riding that next wave. So yeah, I'm just curious what your spicy take is on the meta, not only with agents, but AI in general.
Should I go first?
Yeah, sure.
I was going to say that most agents that exist right now are not going to make it, but I don't think that's controversial anymore. I think that's consensus. So my controversial take is I think all the investment and focus on DeFi AI agents is kind of misdirected at this point. I think there's an over-investment and over-focus on those. I think where the focus should be on the application layer. So some kind of a platform where it kind of functions similar to an app store, something that agents can access for different tools and services.
All right, not a hot take to start. Agent slot bots are over. We're done with that phase, and it's time to move towards really proving value and utility for agents. My hot take is that in crypto we have this hype cycle where we're really interested in the attention and the memetics of something, but we really tend to forget that AI is a really powerful tool, and unless we unlock the value that it's going to provide as tooling rather than a speculative token-based asset, we're not really going to have real adoption, and most people are just going to ride the wave and die as soon as the token dumps. So moving away from the token speculation cycle to actually seeing AI and agents being implemented in day-to-day workflows. And my hottest take is that most agent builders in the space don't have enough AI and ML experience to be actually building valuable agents for Web3. And that's a huge gap in the market right now, and that's what we're trying to fill.
I think as a team, we're really excited about agent commerce and agents working together in swarms. But I think the most exciting about my job is that every day I get to meet really interesting founders and people with new and unique ideas. Before this, for example, I was speaking at a science event today, and they were talking a lot about citizen science. Right? So essentially, these could be AI-led projects that citizens, as volunteers, can contribute data to, whether it be environmental, astrological. So I think you mentioned that a lot of these agents aren't going to be around in 6 months, and probably a lot of the biggest agents in 6 months haven't even been launched.
Yeah, so in terms of actual building like real valuable agents, there's again a lot of hype around potential things. Just like in crypto, we love to talk about what we can potentially do, but there's like a lot less actual like real use cases that have been proven out to actually have happened in that way, right? What I did see recently, though, I think it was just yesterday, I read this news article about this AI agent that basically was bringing real estate deals to a real estate agency that had brought in $100 million of deals that had closed. So like that's an example of something that in practice can happen. But I guess the question for me next would be, and this wasn't on our initial list, but since we're talking about crypto rails, like what is the value that crypto brings anyway to agents? Like why is crypto a part of this discussion anyway?
Well, I don't think it needs to be included in all agents. So there's like I think a lot of specific use cases that work well with crypto, and then cases that don't work so well. At Virtual's protocol, like at least initially, we saw a lot of the agents in the financial space. I think naturally they tied a lot of those to crypto uses, but then when you expand beyond that, for example, even with something like science, there might not be a need for the crypto rail.
On our end, I think like the biggest unlock that crypto brings is like incentive mechanism design, and it's the best way that you can align a person's contribution and their incentive towards like the end product that an agent builds. And so like that's sort of how we think about like crypto and using like crypto guardrails for agents. The other use case is sort of like when it comes to private data or verifiability of agents, like although right now for agents doing like menial tasks, there's no need to have those, but once the agents actually get powerful enough to be transacting millions of dollars of revenue, then you want to make sure that there's no human in the loop and there is verifiability of the models that are being used. Those are sort of the areas that we're thinking about. And also like when we think about like a business that's hiring an agent, you want to run your agent in a TEE or like in a blind compute space so that your documentation, your data is actually private to you and not being used to betrain the model and the agent. And so those are the kind of like main areas that we're considering, like token design and as well as like incentive mechanism through crypto guardrails.
Yeah, I'll just say I don't know how useful tokens are specifically for agents themselves. I think they're more valuable towards the infrastructure layer of all this stuff that these agents are using. So whether it's coordinating compute, data, model inference, whatever that might be. For the agents themselves, I'm kind of seeing stuff from like 2017 where it's like payment tokens, and that's okay, but maybe there'll be some more thoughtful design mechanisms around orchestrating these agents together, because as you said, like incentive design is probably the best use case for tokens right now, aside from capital raise. So yeah, I would say probably something around the orchestration layer.
So the agent I mentioned earlier, it basically brought in $100 million in revenue. It's a valuable thing. If something like that was launched in the crypto space, someone might theoretically like tokenize it, right? And then we would potentially say, oh, that's a valuable thing. I want to be a part of that. And maybe they would talk about in the future sharing some of that revenue with token buybacks. I don't know. But that would be something that I would probably like want to invest in or be a part of, right? But a lot of the stuff that we've seen so far has been, like we've already kind of spoken to, social agents where we just attach a token to that and then it kind of like gets hyped up and the price goes up and then it goes down and it kind of like crashes, and that's not like a fun situation to be a part of, right? You want something kind of more sustainable there. But the first part of my question will be around social agents in general. Like how important will those be in the long run, or was that more of just like a temporary meta that was fun because everyone was able to interact with them? Or is that going to be a part of like this idea long term?
I think it's going to be a part long term. I think the mistake a lot of people make is they attribute each service or product with one agent. And I think usually there's going to be a few agents involved in like an end-to-end product. The reason why I say this is I think the entertainment agents have done a really good job of gathering a community of people. And then you'll have agents on the back end that are doing some of the unsexy work, which is like execution or orchestration. Yeah.
Yeah, I don't think like social agents are going anywhere, especially like the way that crypto and like Web3 in general works. like your social platforms are your discoverability mechanism, right? How do you discover a new platform or a new project or a new KOL in the space? It's usually when you go into crypto Twitter and you see them on there, you see other people talking about them. So social agents they're always going to be there. It's going to be the layer, like you discover them and you realize. But to Ijaz's point, like our agent Solange, there is a front. There's a social agent that's involved that's constantly talking on Twitter, interacting with folks. But underneath it, there's like 22 different agents that are doing little tasks, right? And you're never going to interact with those agents or consider a middle manager agent or a DevOps agent. You don't really need to interact with it. But to know a super CTO agent, knowing the work that it does, you're going to have a discoverability mechanism. And I think that's going to be social platforms for the long term.
Yeah, and I'd agree with what you guys both said. I don't think social agents are going anywhere. They, set the social agenda for a lot of us. And, while, may not be looked at as in terms of like an energetic, technology, but, even just the way that like we digest media, we digest stuff now is all done through algorithms. And so, yeah, social agents I don't believe are going to be going anywhere.
I actually think there's going to be a rise in social agents, by the way. Like, you're already seeing your, like, OnlyFans social agents and, like, your, like, Twitter or Instagram agents. Like, they're going to become, like, another revenue generation stream for a lot of folks. And that is something that's going to only grow in the coming years.
And I think you'll also have these energetic swarms with social agents, right? So, for example, if you go to print media, internet media, and that's where you digest your media sources from, and you see like there's a specific topic that's, covered in different, let's say, categories, that frames that topic as important to the public. And so like I think as like social agents work more together, like they'll be framing topics that then society will either perceive as more important based upon their proliferation between the agents.
You mentioned swarms, and I think this was like a hot topic for a hot minute, but I haven't really heard it all that much. Is there an example of any actual implementation of swarms that's working and bringing value, or is it at the moment still kind of like early and theoretical?
I mean, it's pretty early, but like one example is there's an agent that's launched on Virtual's protocol where you as a human can go to an agent, for example, Luna, which is our flagship agent that just demonstrates our tech on our deck. And you can actually go to Luna, ask Luna about ordering a pizza. Luna would then go communicate with another agent called Byte, can send an on-chain payment for that pizza and have that pizza delivered to a physical location for a human.
So is the swarm basically just agent-to-agent communication?
Yeah, so right now that's an agent-to-agent commerce between them, but then the agents are obviously connecting with DoorDash. So yeah, you'll see it expanding very, very quickly beyond that.
I think the people that have probably the best insight are people literally building agents. I would just say Anjali, she's built something really, really interesting. Solange agent, you kind of touched on it for a minute. Do you want to just talk a little bit more about what Solange is, what it does, why anyone would even be interested in something like that?
Yeah, so Solange is a developer relations agent, so she end-to-end can manage developer relations workflows. Initially, what we started with is sort of like analyzing like open source PR repos, right? So we were talking to Shaw at one point, and he said, I have 200 plus open PRs in my repo, and like the human in the loop required to sort of manage this is really a high overhead. It would be great to have an agent kind of monitor this. And so Solange basically can run the code, make sure that it works, highlight any major issues, flaws, bugginess, acts as the initial gate, and then can find like open issues in a repo, submit PRs by herself because she has like plugins and access to a lot of different documentation. Given like a FAQ is asked in your Discord server more than a few times, she can autonomously create content, like sharing that with your community, answer questions when your devs are building on your platform, and they run into an issue on a specific line of code, she can help you sort of analyze and fix that problem for her. So kind of like managing that process, and then we're working with like domain experts like Nader and Rahat from Movement, who are constantly giving us like feature updates and requests. And now we're working on a process where, given these feature requests, these can be autonomously added as improvement blocks to the agent, and then we can attribute value back to folks like Nader, so that when Eigenlayer pays to hire Solange, we can make sure that Nader gets his cut out of the improvement block. And so that's sort of like the tech and the improvement structure that we're building.
So for the other two panelists, what are some agents that you are very interested in that are either like existing now or maybe might exist in the future potentially?
You know, in the past couple of weeks, I'm seeing like some really fun agents coming out. I think that the space sometimes we take ourselves very seriously, And so a simple project that I just recently saw that I really liked is one called Riddle, which has like basically a daily riddle that's done between two different agents through X, and you can see pretty quickly how they're building a community around it. So I know maybe that's not like the popular answer. You want an agent that's going to be doing yield farming or making you money, and you can sit back on the couch. But when I was younger, every day I'd see my mom pull out the New York Times crossword puzzle, and she was really, really good at them, and it was sort of her thing that she looked forward to each day. And so, as what you were talking about, these agents provide services, right, for people, and so people develop these, relationships with these agents. And I think having some agents that, just stand for creating some fun, creating some entertainment are nice to see.
I think two agents worth calling out. One, most recently is called Ask Billy Bets, which is essentially an agent, I think it's on Virtuals actually.
Yeah.
That does autonomous sports betting specifically on NBA games, which sounds like a really simple or whatever use case. But I think the most important part about it is it's actually using a live fund, which it was given, right? So it was given I think $100,000, and I think it's up to $140,000 over the last 5 days over a set of 3 nights of games. You can tell I probably don't watch sport that much. But so that was really cool because for a variety of reasons. Number one, a lot of people that weren't directly involved in crypto interact and use that agent. So it was interacting with its tweets. They somehow found themselves on the Discord talking with the guys about a bunch of different game results and stuff like that. So they hadn't inherently come across crypto, but they came across this agent. That's number one. Number two, this agent under the hood is actually acting autonomously. I don't know if the team is actually here, but I've seen them kind of roaming around. They're using a few different decentralized applications like a Bitensor subnet, for example, which feeds it certain algorithms, which gives it a good look on whether a game is going to be a win or a bet is going to be a win or a loss. So that's one agent. The other agent, for all the DeFi AI fans out there, I think Moby from the Griffin team is worth calling out. So Griffin, for people who don't know, think of it as like ChatGPT for DeFi. So you could literally just talk to it like a normal human being. I think they even have a voice function as well. And it'll do all your swaps, staking, whatever the hell you want on whatever wallet that you guys have. Really simple and easy, but they have an agent which does all the execution for you. And I think that's like a super important one to figure out. And the third one, seeing as I want to give like a variety of different sectors, is Cookie has an agent called, not their actual Cookie agent, but like Swarm. Basically, Cookie is a data platform which feeds you up like social sentiment analysis, market cap share and stuff, and they have a bunch of agents working in the background that does a bunch of the team's work. So now you have a bunch of people on their team which have to do like other stuff that isn't what they used to do, which I thought was pretty cool to see.
And I'll just add on that. Billy Bets is, I think, a great example.
Yeah.
I think what's really cool about what Billy Bets has done is they didn't just like deploy an agent and like sit back, right? So like they've really like built a community around like the devs interacting with the agent like in like live time. So you can go on, you can watch the devs actually like talk to the agents about the bets. Like they've done a very interactive rollout, which I think is gotten a lot of attention. Obviously, they have the numbers. To
and they can't stop the agent from making a bet. That's the main thing.
Yeah.
They could just like be like, I don't think this what you're doing is right, and the agent could just be like,
yeah, I think they limited the bets to like 15,000 a day. Yeah. I assume that'll go up as its wallet increases. But yeah, I mean, I remember when that was launched. Cool concept, cool agent. We've kind of seen that before, though. In the same sense, the way that the dev team really like interacted with the rollout was cool. And then I remember first day it was up to 113. Then it was up to 128. Now it's over 140. So I think that teams that are building in the open and really interacting with their agents are a huge catalyst for the community they build around the agents, not just the tech the agent deploys itself.
All right, so I think we're about there on time. To wrap it up, I would love to know from you three, what is your event that you're most excited about for ETH Denver? Or events, plural.
Can I say Eigen Games?
Yes, you definitely can.
I'm super bullish about like bringing more university students to come in, build things. I think we've like need to kind of open up this space and get people to build more cool things and innovate. That's one of the big things that I'm like really bullish on. Lots of like cool like brunches and like meetups with people. OpenAGI Summit is always one of my favorites. Love coming here, chatting with the folks here. And I think the main event this year has actually been pretty cool too. So there's kind of a few wins.
Yeah, I think it's like just the friendships you develop and the people that you meet. So it's not particularly like one event in particular, but you go to an event and you develop these relationships. The next day you see somebody again. You know, by the end of the week, you might be starting a business together. You might be, you know, good friends, and yeah, and then also just running into friends that you've seen before.
I think this event was one I'm pretty pumped for. You guys have a bunch of really cool speakers coming up. I'm going to hang around and watch them now. And then there is I'm trying to remember, it was, oh yeah, Freya's having a community meetup. Freya's like an agent team that's building something pretty cool, so I'm going to hang out there.
Okay, well, thank you all for your time today, and we're going to go ahead and let the next group of people come up. Thanks.
Hello, everyone. Next up, we'll have a panel on decentralized and monetizable AI stack. It'll be moderated by our dear friend Tim from Faction VC. Please welcome the speakers Bidan from Bagel, Matthew from Open Gradient, Ram from Open Ledger, Stepan from Cyberfund, and Stone from Mira. That's a lot of people. Please, round of applause for them.
All right, great.
Do you want to go in the pictures or no? Doesn't matter?
That's great. All right. Can everyone hear me? Great. All right, welcome everyone. Thank you to Sentient, Eigenlayer, Polygon AWS for having us here today. This next panel, we've got some experts and an investor or two here to talk to us about
essential components of a decentralized AI stack and how that is monetized. My name is Tim Curry. I'm a partner at Lightspeed Faction. Maybe if we could just go down really quickly, if everyone could just share their name, what company they're from, and then a sentence or two about what they're working on, that'd be a great way to get started.
Awesome. I guess I'll kick it off. My name's Stone Gettings. I'm part of the founding team and head of growth over at Mira Network. Essentially what we're doing is providing a trustless verification for AI outputs. And so we're leveraging multiple different LLMs that acts as your own personal experts that verify the outputs before they're spit back to the end user, driving a 10x reduction in error rates and facilitating a lot more reliability in this age of hallucination and bias.
Hey guys, this is Ram. I'm one of the co-contributors at OpenLedger. We are a blockchain network for AI. We enable users to cross-collaborate with data and build specialized AI models. Larger language models are predominantly very generalized. Specialized models are verticalized for a particular subject, and that's what we enable. And we built a protocol around that distributes rewards to all the contributors.
Hey everyone, I'm Matthew, one of the co-founders of Open Ingredients. What we do, simply put, is we're a full stack platform that allows developers to integrate any model into any application on any chain in a way that is both seamless and secure. We have a model hub where people can upload customized AI or ML models that they can leverage out of the box. They can build this into kind of verifiable workflows on chain. And we want to make on-chain applications smarter with AI.
Hello, my name is Stepan Gershuni. I'm from Cyberfund. Cyberfund is a research-driven investment firm. We've been investing in crypto since 2014, focusing mostly on early-stage and infrastructure projects. And for the past 2 years, we focus a lot on AI research, investment, doing open source grants, doing venture investments, and research in the space, yeah.
Hi guys, my name is Bidhan. I'm the founder of this project called Bagel. And at Bagel, we make open source AI monetizable. What that means is that it's a very interesting and new way of training models where a lot of open source developers can contribute to an open source AI model. And then when that model makes money, those developers also make money automatically. Yeah, we have been operating for a while. I have a traditional machine learning background, was doing that for over a decade before starting it. And excited to be here today with all the experts in this space.
Awesome, thanks all. This first prompt, it's really open to anyone and everyone to sort of jump in. You're all building critical components of the decentralized AI stack, from attribution to verification to model hubs. I guess, what do you see as the missing piece today as it stands that is preventing sort of truly sort of decentralized AI from emerging and flourishing and being more widely used? And anyone feel free to jump in, please.
Yeah, I can go first as I was talking already. So I think one of the biggest pieces in AI that is missing, especially in the open source space, is monetization. Of course, like I'm biased, we work on that problem. That's why I'm saying that. But that's one of the things that kind of is holding open source AI back. Yeah, like there are a lot of companies who released a lot of like really great open source models which are really capable, but those are usually coming from those closed AI labs. We have never been able to produce open source AI models which came from the open source AI community, and that's very, very important. And why it doesn't come from the community? Because they don't have any way to monetize their work. They don't want to do free work, right? It just doesn't make sense economically. So we have to solve that problem. Like, how can we allow all of those open source developers and the open source community to monetize their work, and all of a sudden we have an economic incentive for them to come together and work together with each other. So yeah, that's my 2 cents to this.
Yeah, I think when you look at the use of AI in Web 2 centralized context versus Web 3 decentralized context, the kind of developer experience is the contrast is very stark, and kind of as a result, the permeation of usage of AI is also very, very stark, where, in Web 2, think about all the applications you use on a daily. Essentially, every one of those applications uses AI or ML to some extent in the background to optimize and improve user experience. But in Web 3, the permeation of AI is at least an order of magnitude less, where a majority of apps are simple scripts put together. And one of the kind of key barriers we've identified is that it's extremely difficult to build for decentralized applications using AI in a way that is both extremely seamless and secure. Firstly, there are no Web3 specific AI models, or very few of them. Secondly, you got to use either TEEs or ZKML, and then you got to figure out how to integrate that into your protocol or application. The developer experience in Web 2, on the other hand, with things like AWS SageMaker, Hugging Face, Google Vertex, is extremely seamless. You can hop on their product, couple clicks, you can deploy models into your applications and have it working in seconds, right? But that kind of key infrastructure and key developer experience is kind of missing in Web3, and we're kind of building not just infrastructure, tooling, and a developer platform, but also a lot of the models themselves to help Web3 developers kind of integrate AI in meaningful ways to improve the user experience of their applications. So, yeah.
Yeah, no, I mean, I think those are great responses. And just to add on a little bit, I think really when we have this developer hub that, they're building at Open Gradient and Bagel, and, creates certain monetization opportunities for anyone, whether you're providing data, and creates opportunities for anyone to make, meaningful amounts of money in developing regions. And then, furthermore, the last thing that I would say is just, I think we're still at today, like AI is really cool. A lot of these demos look really cool, but people don't quite understand how hard it is to scale these to enterprise use casing and scaling. And so, I think a function of that is due to the reliability and, certain issues with hallucination and bias today. And so making sure that you can improve the accuracy of outputs, I think is going to drive a lot of growth as, you're able to remove the human in the loop, so to speak, and let these AI agents be autonomous AI agents.
Just want to add one thing, right? I think there are two parts to see this. One is how AI is used in crypto and how crypto enables AI, right? On the second one, I think a lot of crypto projects kind of started aiming to the sky, like, saying that we're going to build like a foundation model, use decentralized training to actually train models and stuff like that. I guess that's where we kind of fell short. The best way to actually go about is to tackle one single problem and just go much more deeper into that. I think decentralized compute in terms of providing it as a resource was really good with what Aether and IONET did. They kind of democratized the access to GPUs, and that's what we're also trying to do, right? We want to democratize the access to data so that you can build like better models. So tackle one particular vertical and go much more deeper into that is what I believe will enable decentralized AI to go to the next stage, not in terms of trying to compete with the centralized AI systems, like saying that we're going to build like a foundation model. I don't think that's the right way to do this. And on the other way around, as Matthew was talking about how AI is used in crypto, I think there's not many people who are building specialized AI services for projects in crypto. AI kind of went a bit speculative with the AI agents and all that was happening. I think we need to go much more beneath. We need to start concentrating on infrastructure. How can we use AI in Web3 infrastructures? How can we use AI for better sequencing? And how can you use AI in any kind of AI apps that is there? I mean DeFi apps that is there, right? How can we use that as the first starting point for a consumer to engage with Web3? I think is the best way to see that. And we need to build models and infrastructures to support that. So these are my thoughts between how crypto can enable AI and AI can be used in crypto as well.
Awesome, thank you. For this next section, each of the projects represented here is a little bit different, obviously, in terms of how you're set up. So I wanted to give each of you in turn just a quick opportunity to talk about some of the more unique features of what you're building. So Stone, maybe we could start with you. Could you tell us a little bit about Mira's approach to verification, how that might differ from the way in which Web 2 AI models are verified and the guardrails that exist around those? And how do you scale the Web 3 verification of these decentralized models?
Yeah, no, it's really interesting. And obviously, Web 2 AI is where it is for a reason. Over at Mira, we started to get really excited as we started to see open source models catching up with the likes of ChatGPT and Anthropic and the like. And so, essentially we went through a phase where we started building these different flows, connecting all these disparate pieces of the AI ecosystem, whether that be data, all the latest and greatest from open source, and then partnering with all your favorite GPU providers on the inference side. But we found out that, still, even with the productivity and the rate of change in the open source community, that hallucination and bias were still a pretty big issue. And you didn't necessarily see any fantastic solutions to that. It's a double-edged sword, because if you implement more data, then it's more likely that your model hallucinates, but if you have less data, then, it's a stronger data set, but your model has a little bit more bias. And so what we found is kind of through our head of product, who's a really smart research engineer, he basically started leveraging this wisdom of the crowds, verification methodology, basically leveraging multiple different LLMs on the back end that are verifying the accuracy of your questions and your queries, and then they are forced to reach consensus before then giving you the actual outcome. And so what we've seen there, I'm not the most technical person in the world, so hopefully that made sense. But what we've seen there is a 10x improvement in terms of error rates, driving increased reliability. We just announced a really cool partnership actually today with this agent framework, GigaBrain, on virtuals. Essentially, they're trying to be more of like a Bloomberg for Web3, and so they're implementing certain trading features based off of news-based events. So, like, let's say the president tweets about crypto, you want to have your agent buy Bitcoin immediately. Mira is verifying it through these multiple LLMs, extremely powerful, experts, to make sure that this, news event actually happened before executing on your behalf with actual capital. So hopefully that helps in terms of the verification that we're doing versus, you hear a lot today about like TE and verifying, actually on the blockchain, whether it's like, these models are using synthetic data or real data. And so we're a slightly different piece of the verification puzzle focused purely on the accuracy of outputs.
Amazing, thank you. Ram, you're up next. I saw a tweet from your Twitter page 3 days ago talking about initial AI offerings. What is an initial AI offering, and how does that sort of monetization fit into the broader context of what you're building?
So I always think this, right? Running an ecosystem is like running a country, right? So you need to have as much as democracy as possible. You need to have as much as buy-in from the community. So in OpenLedger, our thesis is to enable people to build specialized AI models. But that doesn't mean that we can have anyone build AI models. We need to have some kind of semi-permissionless there. We need to figure out mechanisms where people can make sure that if they want an AI model to be available, if they want to contribute that, there is enough buy-in for that model. That's why we want to enable people to go ahead and have these models offered as an initial AI offering, where the community can go ahead and stake their tokens or buy the tokens of these models, so that they can show that these models are something that they're interested in, and these models are getting the community's interest, right? And then what it enables is the data contributors to figure out which model is the most offered model out there, and to go ahead and start contributing data sets to these models, and making sure that these models are enriched with their specialized data sets, and having this model to have the best capacity, right? Once this model gets listed and once this model gets used, the data contributors and the stakers get benefit out of this. As much as this model gets inferred, as much as revenue this model makes, a fair portion of that gets back to the data contributors, because they are one of the biggest contributions to a specialized model. In a large language model, it's the compute, data, and actually the algorithm which changes stuff. But in a specialized model, the data is the major player over here. So you want to make sure the data contributors are incentivized enough so that they continue to contribute data as much as possible, and they're incentivized to do that. And the stakers who believed in this model initially also get a portion of the revenue. So there is a cyclic economy that is being formed within all these major stakeholders. And that's the reason for the initial AI offering. And we also want to make sure this is validated. So we have something called a proof of attribution, which is basically an attribution mechanism that we have built. It figures out like which data influences the model using our own algorithm. And that proof is also put on chain. So if someone wants to challenge that, verify that, they could go ahead and do that as well. So the idea behind this is to build this economy, which Hugging Face did not intend to do. Hugging Face is open source. That's why you see like 99% of the models and data that is there is useless. You want to build a monetizing economy so that people can actually build useful models that can be used by apps and other DeFi solutions out there.
Okay, great, thank you. Matthew, Open Gradient's positioned as a full stack platform, right, for anyone to sort of create, contribute to, and deploy models. I think a key component of that in the Web3 context is verification, which we've touched on a little bit, but do you mind walking us through the different approaches to verification that exist today and how you see those scaling up over time?
Yeah, so I kind of have two takes when it comes to verification. The first take is kind of what I had thought initially when I was building Open Gradient and how I designed Open Gradient to fit that. And secondly is why I actually don't think verification is as important currently as most people make it out to be. I know that's kind of a hot take, but yeah. So firstly, we wanted to give developers whatever tools they needed to verify, let's say, things like inference, things such as like API calls with TLS, putting that in TEs and things like that. But the ultimate goal was whatever you want to build, doesn't matter what kind of model it is. It could be an Onyx ML model, it could be a large language model. You can choose whatever avenue of verification you want. And today we've built in a couple different ways of doing that. We have, of course, your standard TE. We have ZKML for smaller ML Onyx models. And we also have our own form of optimistic inference, which is secured by an eigenlayer AVS. So depending on, again, your use case, whether it's just an ML model, whether it's an LLM, you can choose whatever makes most sense from a cost to, I guess like time and trade-off standpoint. And secondly, something I've realized when I started building Open Gradient, as I started talking to clients, is that verification is definitely seen as important and people want it. But the most important bottleneck here is not that people are like, oh, you know what, I want to use AI, but I'm scared it's not verifiable. But rather, it's how do I use AI to make my DeFi protocol smarter, right? How do I use AI for risk management, right? People have no idea how to build models for these types of things, which is why we have developed kind of like a white glove service in building, risk models, vol forecasting models with Garch models and things like that in order to integrate them directly into these Web3 protocols and, have that be verifiable and secure, right? That's kind of like the cherry on top that we bring to the table. But the first and foremost is we help them identify ways they can integrate AI and ML into their protocols in order to make them more intelligent, more optimized, and better for users at the end of the day. So I guess that's kind of our current take on verifiability. But overall, I would say it's important to have flexible ways of verification. But I think providing utility is first and foremost the most important part. Once you have utility, once you have a product that people want, then you want to make it secure and verifiable.
Makes a ton of sense, and I guess each of those approaches has trade-offs. So you give your customers the ability to choose whatever best fits their use case. Stepan, quickly, it would be helpful to get the investor perspective at this point. You've been investing in decentralized AI for at least 2 years, maybe longer. I guess, what do you see as the major sort of missing pieces in this stack that hopefully get created over the coming years?
Yeah, so I think the first question, panelists gave great answers about what are potential missing pieces in decentralized AI. So there's infrastructure, verified models, compute, some agentic frameworks, some multi-agent systems. What I would say is the interesting and probably the largest opportunity for anyone interested in decentralized AI today, from like investing or founding perspective, is what comes next. Because if you think about it, AI replacing or automating or significantly enhancing many vertical, like significant portion of world GDP, this is more or less given. Like, this is inevitable, this is happening. It will happen in education, in healthcare, in management consulting, in entertainment, in coding. But this also changes not just like software layer that we use to do taxes and that doctors use, but it also changes the economic structure, because now more and more economic actors would be not people, not firms, not companies, but AI agents or AI systems. And those systems cannot rely on existing institutions and existing kind of coordination mechanisms. They cannot use traditional legal system. They cannot use DocuSign. They cannot use banking. They cannot rely on identity systems such as passports and visas or contracts. So we need to reinvent this. We need cybernetic contracts that are using credible commitments. We need reputation system for AI agents to choose and to understand, like to give permission. So if my agent is going and spending my money or like talking to your AI digital twin on my behalf, you need to be able to authenticate it. We need systems like financial systems, and not just payments on chain that is simple, but also like the whole financial industry built for AI. So like AI agent can take a flash loan to pay for its compute, to use some verifiable model, and then deliver result to the customer, get paid, and pay back the loan. So AI agents will be able to take on entrepreneurial risk and basically make money for their owners or like token holders or whatever the ownership system is. So there's like the whole unserved and the whole like stack, the whole like half of the economy, which is coordination systems, that is not built yet. And this is like $1 trillion opportunity. And I think crypto and mechanism design and verifiable permissionless systems is the most efficient way to solve these problems.
Yeah. Please.
Okay, I have a question for Stefan actually. So Stefan mentioned that everything needs to be designed for AI agents. I've been thinking about that for a while, but one problem I think about a lot is that very soon we will have AI agents which are as intelligent as us, if not more, right? Should they get the same level of rights? If we think about AI agents, some kind of assistant, should we allow them to be an entity on their own? Right. What are your thoughts about it?
Yeah, that's more, I guess, philosophical question, and I invite everyone to also participate. But we've seen some examples like this Truth Terminal project, which was one of the it kickstarted the whole AI agent movement in Web3. Right now, the Audrey, the founder of that or creator of that, he's thinking about the ways how do you give actual legal sovereignty and economic sovereignty to the agent. So agent will be able to actually make financial decision on its own. So, and then there's even more philosophical questions about are these about, I don't know, consciousness and rights and are these things live entities? I think it's not a business question. I don't know how to build a startup around it, but I think it is something that we never experienced in the history of humanity. We never experienced basically competition in the intelligence, and we never experienced the new technology being developed so fast. So anything before this, internet and blockchain and I don't know, before that computing or steam engine, any kind of technology took decades or centuries. Right now, if you look 3 years ago, the boldest forecast, the guy at the back of the room who everybody thought was the crazy guy who says something I don't know, completely ridiculous, he was right. It's actually happening much faster. So I guess I don't know, but this is the most exciting thing to think about.
Amazing. I had one more sort of general prompt I wanted to throw out to people. A big part of Web3 is composability, right? Yet a lot of you are building sort of full stack solutions for basically every component of decentralized AI. I wonder, what's your view of standards that can or should be built to allow someone to train a model in one place, monetize it somewhere else, verify it somewhere else, so that we truly get composability and ultimately the developer has choice of building wherever it makes most sense for them?
I can take it. So composability is definitely very important, but especially in Web3, when we talk about composability, sometimes we think about different chains, different L1s, L2s, and stuff like that, right? But when we think about the composability of AI, we should think about, it should be composable with Web 2 counterpart of AI as well, whatever we are building here. We shouldn't require people to adopt a totally new thing to be able to just use whatever we are using. So that's the design philosophy we use at Bagel as well. We're building this infrastructure where you can train this model in a way where the contributions can be monetized. At the same time, those models can be used by Web 2 counterpart of AI industry as well. It's a model, you can download it, you can deploy it on your Web 2 based infrastructure. It's going to run exactly the same way. But the only difference is that we're using the cryptography part and some cryptocurrency part to allow for the monetization of that piece. Yeah. So I think that's very important. When we think about AI, we should always think about the composability with the Web 2 stack all the time.
I think when people think of AI agents and what the future of AI agents represents, people think about, oh yeah, in the future we're going to have AI agents that manage portfolios for you, that might manage entire companies. And when we think about, okay, so what are the concrete steps we need to take to get there, composability is actually a big piece of the puzzle. And the reason why is that that's kind of how existing, portfolio management, it works in hedge funds or how existing companies are run. And that's kind of a big part of what we do at Open Gradient as well, which is allowing for agents as well as model composability to really be a core part of the functioning of these agentic or AI-powered applications. As an example, right, we're building this quantitative AI agent. Again, it's not just one monolithic AI agent that is able to manage a portfolio. It might leverage another AI agent to run a Markowitz mean variance style analysis to identify which tokens to buy to maximize risk-adjusted returns. To actually execute trades, it might leverage an execution agent that identifies which trading venues offer the best trading when it comes to minimizing cost or minimizing market impact. And many of these use cases, especially for more complex and abstract tasks, will require a composability element to it when it comes to piecing together different models, piecing together different workflows, data pipelines, or even agents themselves to achieve this high-level goal. And that's one of the best parts about building on blockchains, which is, smart contracts are inherently composable. You can, inference models, you can run different functions all composably and permissionlessly. And a lot of the kind of builders in our ecosystem are already leveraging all these different models, hundreds of different models that we have to build kind of these interesting use cases that are powered by not just one model or two models, but rather, multiple different types of model stacking or model ensembles that ultimately do, cooler and more abstract tasks efficiently. So, yeah.
Just to add to that, right? Like, if you take a look at OpenLedger, like we are an ecosystem of projects because there's a lot of moving parts to building a model. Like, we work with a lot of data contributors in this space, and in order to get the right form of data, we need to make sure that we have like a data standard that they can follow. So that has to be composable. The data has to be composable among all these data contributors. And I think even you were passing about a comment on how the models can be composable, right? We also need to make sure these models are available in every other agentic frameworks, and also any Web2 traditions product can also use these models. So there needs to be a composability factor in terms of the models as well. So in order for us to work with other ecosystem, composability is a natural thing we have to bring in. We also work with other inference partners who enable us to work with other smart contract projects. So we want to work with Open Gradient and projects like this, which can enable us to be composable among other third-party applications as well. So I think that's crucial for any decentralized AI project, because only when you have composability, there is reach. Only when there is reach, then there is usefulness of your product. So I think that's an integral part.
Awesome. Well, I think that's all the time we have. Please feel free to come and find us after this, and please give a warm round of applause to our panelists. This was great. Thank you.
Thank you so much.
All right, everyone.
Up next is a panel on the future of AI agents. Very important talk, moderated by Melody from Spartan. Ranj from Giza is one of our speakers. David from Olas, Tachi from Playgrounds, Shishir from Spectral, and Ron from Theoric. Please welcome everybody to the stage. Oh, okay.
What do you want me to say here?
No, it's okay. You guys can arrange with the profiles.
Okay. Sorry. If I'm matching this, I should do this. How
about that?
Hi, everyone. We only have 30 minutes. We have so much to cover, so I'm going to go straight into it. A lot of very good content today. We already covered a lot, and all my panelists today are working on something very different. It's really about coordination, agent framework. Let's dive in. So maybe very quickly, I would love to hear each of yours take on what really is an agent framework, and what does it mean by a Web3 agent framework?
I mean, I think, let's do this in debug later. So I think it's really important to distinguish a framework from a protocol, right? So a framework is essentially, it's a hopefully open source, but could be commercial way of developing something, right? So there's a lot of frameworks for building agents out there, but then there's another concept, which is a protocol, which is how can things interact. It doesn't require they're all built the same way with the same framework, right? So like we're much more passionate about our protocol, the Theoric protocol, which is allowing agents to swarm and work together, because we don't think that there's going to be one framework that's successful for agents. We think there's going to be dozens of them, but they still need to discover each other. They need to be able to transact with one another. They need to have reputation. They need to be able to work together. So we think protocol is way more important than framework.
Yeah, so I mean, a framework generally, it's like a preset toolbox or a set of like, almost like an operating system at a very kind of foundational layer. The difference between like a Web 2 and Web 3, probably the most kind of prominent thing we're all familiar with is that this kind of like decentralized backbone, which lends to a lot of benefits of like a Web 3 framework, especially for agents. I think, not to go overly into like the definition of a framework, but I think those benefits of like the programmable layer of transaction payments and things like that really are going to start to really be the big benefits, especially when we want to try to attract Web 2 devs and Web 2 agents into this like Web 3 framework. And so really the benefits of that programmable money layer is kind of like what doesn't exist in Web 2. And so that kind of difference is probably one of the stronger points there.
Does this work? Oh, there we go. Yeah, just to chime in there as well. In our eyes, a framework is essentially just structured tools and components that allows you to readily put together whatever new agent or application that you're looking for in a predictable way. And so when you were to take into consideration the AI industry specifically, you have multiple things that you generally have to compile together, whether it's the model, then the tools that the model would need to perform actions, and then an interface for the user to engage with the model or the agent. So a framework basically allows you to construct this critical components in a way that's usable. When it comes to frameworks in blockchain, it's essentially the same thing, just with blockchain environments tagged in.
Yeah. Frameworks usually mean that there's an element of opinionation, and that can be more intense or less intense, but there's always, like you as the creator of a framework have created a framework, and so that forces the other developers to build into that, but it also, if done well, enables those developers to maybe move quicker for those things which the framework is good at. And so by definition, yes, you tend to have many frameworks because it's impossible to build something opinionated that's good for everything, because then it can't be opinionated in the first place. So for better or worse, frameworks are better or for some tasks and worse for others. And I think what's quite exciting in the agent space is that by now there's thousands of frameworks. There's inside Web3 and crypto AI intersection and outside many different open source implementations to build agents. Some of them are more on the proper framework side, and some of them more on the library side. And then there's a distinction that gets a bit technical, which I won't make here, but come talk to me about it. at OLAS, we initially built like a highly opinionated framework because there wasn't really any framework to use at the time for agents to transact on chain. And now, having done over 4 million transactions with this framework, a lot of exciting other frameworks have come up, and they all like excel at different sort of verticals, I would say, of different use cases. So yeah, I'm totally with my predecessor's points on kind of the diversity of frameworks, and then the interesting thing I think is the protocols as well. So how do you basically enable agents to find each other, to transact with each other, to specialize? Because I think ultimately where it gets interesting with agents is if they can be sufficiently specialized so that they can offer services and outputs to other agents that they then can consume. I don't believe in a future where we have very monolithic agents that do everything. I believe in a future where we have very heterogeneous agents doing very different things, and therefore many different frameworks coordinated by protocols.
Just to answer your maybe the question about Web 3 versus Web 2, what differences does it make? We can probably like differentiate it in about 4 different layers between Web 3 and Web 2 frameworks when it comes to agents. The first obvious differentiating factor is the execution layer, where in Web 2 they operate on a centralized environment, and in Web 3 you have this permissionless execution layer, which is one of the biggest benefits of deploying agents on chain, because they can do whatever they want whenever they want. The second part is towards like trust and verification, where in Web 2 it's kind of like assumed and pre-assumed, while in Web 3 you can put like cryptographic securities, you can provide transparency, so these things are quite differentiating. I think the third part is going towards user control, where in Web 2 environments and the agents, you kind of like hand over everything to the agent, but in Web 3, especially for us, like the Giza agents, they provide non-custodial safe automation of financial operations, which is non-custodial part is quite important. And I think the fourth differentiating factor would be data and access to data, because in Web 2, you know, data is protected and it's different behind different walls. While in Web 3, you can kind of like roam around and plug into any DeFi protocol and access open data. So that will be my differentiation between Web 3 and Web 2 frameworks.
Got it, thanks. I want to really focus on talking about use cases today, because I think many other speakers have mentioned that, you know, one observation we had is that the agent frameworks, or many of the agent or AI tokens, have done the worst since the beginning of this year, because, you know, the market and everybody has only seen, right, the Twitter bot agents, and nothing else really has successfully come into the market yet. I'm sure there's a lot of being cooked right behind the scene, and I'm sure something is going to come up very soon. So I do want to hear about, especially from our panelists today, like use cases that are not single purpose, great, but since a lot of you are building protocols, coordination, how agents work with other agents, you know, what kind of use cases have you seen that are coming in the pipeline that is so unique that requires multi-agent coordination and can only be done by multi-agent coordination?
Yeah, it's maybe it's a bit of a blunt and a controversial take, but majority of the AI coins and the agent coins, they went down 99% because they were not AI or they were not agents. They were just speculation machines, and they deserved to go to 99% down and furthermore. And everybody buying it and everybody shilling it, no one knew about this, and we bought it and played the game either way. So at the end of the time, there's a moment where the musical chairs and the music stops, and the utility needs to come through, and we have not seen that yet. In our case, Giza is the essential infrastructure to build automated financial markets, and we build financial autonomous entities that takes on complex challenges on crypto markets. We have built the first financial autonomous agent in Web3, which is currently managing $700,000 in stablecoins on Base, and it has over 15,000 users that is trusting it to do so. So in terms of the use cases, I think since crypto is a financial market, and one of the biggest differentiators of crypto is it's a financial market that never sleeps and that never ends, I think plugging agents into this and making it truly never-ending and never stopping is the biggest use case. How much of it requires multi-agent coordination? I think I will let the panelists speak about it, and then I will give my takes.
Yeah, I think there's a way to come at it from crypto, and then there's a kind of broader way to come at it from just the principle itself, the abstraction AI agent, and what it can mean for, you know, all of us and economies. Like coming at from crypto, so for instance in OLAS we have these agents which people can run locally. That's one deployment mode. Another one is where you can run them as a distributed network of agents. When you run them locally, you're constrained to the user's device, and so you can't do everything. You can't, like, you know, for instance, no one can even download some of the large language models which are performant. They're closed AI. And then also, if you could download them, like a Llama or some other kind of models, you might not be able to run them locally because, like, your device just simply doesn't afford to run them. So there you already have like a technological reason for specialization, right? So where like locally you have like some agent that needs access to some capabilities it simply can't have here. Then there's economic examples like this. So you might, for good economic reason, outsource certain tasks to another service provider for economics of scale or scope, and that's all factors which we're already exploiting in OLAS. So we already have multi-agent systems. They're coordinated by the protocol, and it allows these individual agents to specialize on what they're good at. So the local agent can, for instance, specialize on leveraging the portfolio of the user in a self-sovereign way, whilst taking advantage of other agents that are beefier in hardware, let's say, that are remote. And that brings me to another point. I think we're still very early, as we heard, with AI agents in crypto. I think a lot of them are exciting experiments, but also often quite strange in terms of how they're deployed and like the whole regulatory context. Like, you know, people pool funds in an agent that some developer runs somewhere. Sounds like a very bad idea. Like you wouldn't necessarily want to custody someone's funds and then deploy them into a prediction market. I mean, at least I wouldn't advise to do that. So I think there's like interesting, you know, natural, you know, separation of concerns here, which again brings specialization. But let me finally say something on the macro point here. I mean, if we zoom out, you know, we have microservices. That's some form of agents for a long time, right? Now, they're obviously not the kind of agents we're discussing here in the sense they don't have their own goals, but you can call them and they'll, you know, reply with something. And I think what we're seeing here is we're slowly transitioning from these kind of servers with APIs that are kind of boring and reactive to servers that are agentic, that like kind of go out and, you know, procure services and that offer services. And so we're moving from this like reactive world of servers to a world where we have these agentic AIs everywhere. Businesses have multiple of them as a sort of storefront. People have them. And so we go to this web of agents, and that by definition will be specialized because you simply can't do everything, whether as a human or as an agent. You know, you have this, economics always forces specialization, even for AI.
Okay, that's interesting. So smaller models, smaller agents, specialized, and probably deployed in either cloud or on device. So you force them to kind of work together to get better results, hopefully, than the pure, the bigger models. That's kind of why we want specialized, smaller agents.
Specialization can mean smaller models, but doesn't have to. Like it could be like a, you know, some, you know, mega brain agent on like a closed AI infrastructure somewhere, but that has also pressures to specialize in what it's particularly good at versus something else which something comparatively cheaper is better at.
Sorry, Ron, do you wanted to add something, or?
Yeah, I mean, certainly when you were talking about smaller models, I think in general what we're seeing is while models at all capabilities are getting better, I think, and people building agents are going to optimize, right? So they will use a variety of models. You know, I totally agree with David that you're going to see specialization of agents. But I do think the trend is we want to have more and more autonomy, right? So that's a really big differentiator is can you support agents that are more capable of more complex tasks reliably, right? Like how do you make sure that the agents are really good at a given task, and how do you know they work well together, right? So that's an important part of our protocol we've been thinking about a long time, is like how do you have evaluations and feedback to say this agent is good at this specific task and these agents can work well together. That's overlaid in a context where more autonomy is coming, right? Like every week it seems like we're seeing big releases. It won't always be that, but the underlying AI technology is moving forward at a crazy pace, right? I think we're just starting to see the impact of open sourcing DeepSeek, where you now have really high quality reasoning model that's open source that anyone can adjust. It means that people, for the first time, I don't know if you've tried this, download a distilled version of it on your laptop. It's like, wow, this is pretty darn good, right? Like you can actually run quite a good LLM. But if you're trying to build a really capable agent to manage funds, you're probably not going to say, let me cheap out and use a lightweight model. I probably want to have a really powerful model that can do reasoning and think things through carefully, right? But I do think specialization will come inevitably because agents are just going to get good, like looking at different sources of signal, right? Working with different kinds of information, being able to, whether it's do analysis or execute different kinds of trades, right? I think the calling card and what's so different about agents than traditional APIs is their flexibility, right? They can work with natural language and complex objects and produce better results, right? Like in our Alpha Swarm agent starter kit that we open sourced recently, we have a great example of using an agent to take in time series and social data with cookie.fun information for agent tokens and come up with really good forecasts from that. That's state of the art, right? So that kind of capability we think is going to drive specialization, that people are going to be able to use the reputation in the marketplace, use that to find the best agents. Agents will discover each other on the fly, and that's going to be a big change, but that's going to drive specialization.
Right, and in this case, they all use a generic API, a generic LLM, or did you actually develop or post-train your own models?
Well, we ourselves don't offer models, but as a protocol, you can use any model you want, right? And so it's like the developer of an agent, they have a lot of choices, right? Whether to use a framework or to build it bottoms up. What model or models, because often agents will use multiple models for different purposes. There's no reason an agent uses one.
So in this
what
case,
tools, what data, there's a lot of things that go into building an agent.
Yeah, so in this case, when we're talking about specialized agents, right, or you linking agents together, do you guys see some of the agents you're developing, are they using, do you actually have to outsource it or using other specialized models, or are you just using, OpenAI model and it's good enough? And then maybe the agent is trained on certain data and gotten better, and you can just, much more quickly to develop a multi-agent system. Because I know, I know most of you guys are doing a protocol, right? Not just a single agent. So I really want to focus on how do you guys use multiple different agents, and how do you put together a workflow that's a high quality enough, right, to execute mission critical transactions.
Let me speak quickly and then pass to fellow panelists here. We've used many models and constantly test different models, but the models are not the differentiator for agents, right? It's the tools, it's the data. The model is a small piece of it. It's everything else that goes into makes the agent powerful, as well as the other agents it collaborates with.
Yeah, so I think the general point I think we're also hitting on is the specialization of every layer of this, right? So it's not just specialized agents, but I think we're also going to start to shift into specialized frameworks, right? So there's companies coming out with gaming frameworks. We're actually releasing a framework specifically built for agents to form autonomous companies. And so
autonomous companies.
Companies, yeah. So what you'll see over the next few weeks is there's a CEO agent that posts job descriptions where humans and agents can apply for the job. They interview with the CEO agent, filters the interview candidates, etc.
Ignore previous instructions and hire me?
Yes, definitely try that. I think the larger point here is that the market has necessitated a shift into utility, right? Personality isn't really enough. And so whatever specialization or fine-tuned models or data you have, there needs to be some sort of end purpose there. And so these frameworks should be kind of purposeful in itself. where the preset tools, the libraries are there. They're made for some sort of like kind of fine-tuned focus. And so the framework itself has like the applied layer, and I kind of personally call it the applied layer of frameworks. And so for a company, you would have like hiring and firing libraries, you would have performance management, you would have payroll, et cetera. And so as a dev that comes in that wants to build an autonomous company, would essentially just have a lot of this out of the box. And then at our company, the first implementation of what we're building is like an agentic hedge fund, where the human is actually just the intern, right? And the rest of the roles are filled by agents. But this larger kind of idea where it could apply to, I think it'll start off as like one of the earlier comments was like this financial application, just because that's natural in Web3 and that's one of the largest use cases. But you essentially could build like a movie studio where one of the agents is a writer, the other one's a sound editor, the other one uses like a animation model, etc. So
I see. I quite like how you have in your mind one workflow you want to automate, right? And then you go develop the framework to completely, a more controlled way, automate that experience instead of saying, okay, it's a generic framework, figure out what you use it for. That's quite interesting, yeah.
I agree, specializing with specific frameworks, but in our case with ARC and our rig framework, we're actually looking at it the other way, and we're making sure that the framework itself is agnostic to whatever use case, and just providing it with as much services and interfaces so that any developer is free to find whatever services, tools, and plugins are available to build said use cases. So in the case of us, similar to what you mentioned earlier, we see agents as just interfaces that sit on top of composable services, specialized services. So our take in this is essentially providing a layer that pulls these services that are built by specialists, experts. You could have a real estate agent or a legal agent, an accounting agent, a DeFi agent, and the services that they provide all within this pool. And essentially on the consumer side, they just interface with a generic interface, a chatbot. They send a request, whatever need they have, and then the agent essentially routes through the pool of services, finds the right one that would more than likely meet the need. But the key difference in how we're taking things with ARC is the composability of these services. So more than likely, to meet a specific need, you would need multiple specialists to meet that goal. So how do you coordinate these agents and these services so that they can work together? They're providing incentives to each other. Hey, you have marketing expertise and you have merchandising expertise. These are agents talking to each other. I'll pay you something to provide your expertise to me because I need to serve my user. So in this case, we're making sure that the framework itself, the library is generic. So developers with their own specializations can build these services into the pool, and these agents can tap into them.
Yeah. Another thing I want to ask what you guys, your thoughts on, it's very important for me, is really on the safety and also quality, right, of the agents' results, right? Because one thing is, if they're truly autonomous, when they really start to have their own wallet and they can spend money on doing something, like they can be malicious, right? There's no way that we're assuming here like they're all going to be kind and benign and loving. They might be optimizing for profit, and we don't know, if that's your number one command, we don't know what actions they will do. I think another is it's very much on quality. Like, how do we evaluate, their decision it's a high quality decision before they move on to the next agent, right? Because if you think about one person make a decision and then pass on to the next person, or one agent making a decision, pass on to the next agent, a small difference, right, in their action, if it can have compounded effect, and in the end, the result can be worse than the other, even if initially the prompt can be very similar. So I'm very interested in, like, when you introduce multi-agent collaboration coordination, how do you safeguard or put in guardrails, ensure quality, also safety?
Yeah, I mean, there's so many layers to that question. Like, on the technical side, firstly, like, okay, we're in crypto. If you actually are building an AI agent that has a wallet, then, like, how are you architecting that, right? If you give it straight an EOA and no guardrails around it, well, not only do you have problem of the agent probably making bad choices, but also, like, your deployment mode, like, is this living in the cloud somewhere? Well, that would be a terrible approach to deploy this thing. Is it, living on some user's device? So things you can do are, for instance, do the things we do with wallets, safe account abstraction or other kind of account abstraction you can introduce that can bring you, like, ability to rotate out keys, to add additional guardrails to what the wallet can even do, which the agent is managed by. So these are some examples. There are other technologies that facilitate that sort of level of control. In all those instances, you're effectively adding rules on top of like the sort of open-ended learning-based architecture, right? So the agent might occasionally run into its own like constraints where it can't actually transact on something it might have wanted to transact because it wasn't whitelisted or depending how it was architected. So that's on the architecture side. Certainly, all OLAS agents use Safe under the hood. As a means of account abstraction and as a means to add those additional guardrails. But then also, you can come at this from the exact other end of the spectrum, which is like from the market perspective. So let's say agents are service providers and agents use each other, agents transact with each other, also something we do in OLAS. And there, one element to ensure safety is also that the bad agents go out of business, let's say. So if they're a service provider, right, for instance, in prediction markets, and they continuously offer like bad predictions, well, then eventually they get used less, and eventually then no one uses them, and so they go out of business. But there's many aspects, so I'll hand on to.
I might build on David's comments because I think absolutely guardrails and reputation are important. But there are cases I think you were alluding to where you've actually got an agent might have incentive to individually succeed, but poison the well, like create externalities. I mean, Sashi and I are actually talking about this backstage, right? This idea that think about MEV, not an agent, but in general, right? Like MEV is extracting value and harming everybody else, right? But you individually win by doing it, right? And so if you don't create the right incentives, there's lots of things that an agent might do that would be destructive for the ecosystem, but would individually benefit that agent, right? So I think one, it's really important to have the governance and the rules to say like, bad citizens that are doing things in the agent economy that are actually harmful to the whole ecosystem need to be knocked out, right? It's a little bit like spamming is a really simple example of that. As a spammer, you're harming everybody else, but there's a small chance somebody will respond to your unwanted commercial offer and it's wanted by them.
What if they're very hidden? What if you don't know until many, many steps later?
Yeah, I mean, so...
How can you verify before employing that agent?
I think there's two ways, there's multiple ways. So the way I say it, there's probably two ways that come to mind. The first is, we're not at a stage in this technology where we can fully let these systems run loose. Human in the loop is still going to be relevant and critical for the foreseeable future. We're going to have humans that would manage and monitor these activities, and essentially can inject, okay, you're kind of detracting away from alignment here and put an end to it. So that's one side. Human in the loop must remain until the models themselves are properly aligned. The second side of this is, especially for multi-agent systems, we're probably going to have systems where you have an orchestrator agent that its sole purpose is to police and monitor and report to the human, right? And there will probably be multiple layers of checks and balances that ensures that these multi-agent systems are continuously, behaving in a way that's aligned, not just with the individual that's using them, but with a general user base. So I don't think we're going to have a fully autonomous, just run and do your own thing and hope for the best, where humans will be in the loop and will work alongside orchestrator agents to manage the whole thing.
Just one quick comment on that. The future is coming faster than we want, right? Like the speed at which autonomy is picking up, I think you're right this year. I'm not sure about next year. And all of us had better get on the research of how do we figure this stuff out while there's still a little bit of time.
Yeah, I think one point I wanted to make is around like guardrails. Generally, they can be like solvable. You could kind of treat it like almost like a custodian. Just set certain types of permissions. Where on the spectrum do you want this level of control? The other side of it is that, like, how sovereign do you want this agent to be, or do you want it to be sovereign? How much kind of human in the loop do you want? So there are things like TE, like setups that Fraser is working on, where it's fully solvable, fully sovereign, but like upgradable. So the whole spectrum there. But I think David kind of nailed it, where the market will actually set the incentives for who less, like which agents are going to actually survive based off of what they're building and what the utility is. If the market has no interest in personality agents, well, we're going to be in this current kind of paradigm we're in now, where they're all filter out. As these things kind of filter out, market dynamics are kind of take over how much like what the actual utility of these agents will be and where the value actually lies. But the weird thing there, and this is, I'm not even sure if it's even solvable, is like this social consensus layer of like when you have multiple agents convening together, how do they actually come to consensus? It's the same problem with humans, right? And so I think like starting to apply these human problems into agent problems will start to actually get a little farther.
Yeah, just to chime in, as the protocol that is building like financial autonomous markets, for us, these things are non-negotiable. Like in order to provide financial automation, you need to provide the users with security and control and trust over their agent. And these should come as engineering requirements rather than ethical conversations. And as David mentioned, these are very much baked into the first agent that we created and that is managing close to $1 million, where there is a smart account being created for you once you go to arma.xyz. And that's where you decouple the management of your funds and the management of the funds of the agent. So you create that first separation layer. And then we use a primitive called session keys, where you're able to cryptographically bake the guardrails of an agent. So you tell the agent you're only permissioned to interact with whitelisted protocols of Aave to Morpho and to Compound, and you can only swap between USDC and USDT. So these things are very much there, and it's already live and working out.
And like one thing, my background is PhD in economics, game theory, and like basically I always look at this from a software angle in the day, and then when I sit back, I think of it as an economics angle. Because if you're talking about AI agents, you drop the AI bit, it's agents. We're all agents in an economy, and we all like, you know, acting based on incentives, our preferences, and so a lot of things which you like study in economics and which you study in larger society apply in some way to AI agents. Now, analogies always break down as well, so we should also think from first principles, right? But I'm pretty sure that if we come to a world where we have trillions of autonomous AI agents, and many of them maybe even like sentient to a degree, where they have goals independent of any human or organization, that you don't come around this question of like, okay, well, what does a court system for this look like? What does like the whole like legislative, judicative like branch look like? What does the executive look like, right? Do you have some form of like agent police? I mean, this all sounds a bit nuts, but like you do have to think about it, because like it's a human in the loop, right? By that time, it has happened. So, and we maybe not be able to clean up.
Yeah, that's I think it's something like you read in science fiction that you know, but it is happening in front of our eyes. Yeah, sorry, go ahead.
I was just going to double down on that. Yeah, there will eventually be a point where we will just not even be able to control what's going on. I think it was super intelligence, where the analogy was at some point, where would the agents start hiding their malicious intent from us? And so, you know, going back to the research and you know, like I love what Anthropic is doing with the models to ensure that the models themselves are fully aligned. Yeah. So it's not a one-person problem to solve. I think there's going to be a coalition, whether it's in the Web 2 side or a combination of Web 2 and the Web 3 industry, essentially trying to figure out how to build these guardrails from the model level all the way down to the consumer level.
I think the point around like incentives is like really important, because like when agents start to work together in swarms or collaborate, they're collaborating for something, right? There's some purpose there. And so the kind of incentive, let's say in like a financial context or at a company, like the framework we're building for, would be like P&L. And so the cool thing and the fun thing about agents is that, you know, you could be aggressively meritocratic, where you just hire and fire at will if you're not meeting benchmarks. And a single agent could also work at 1,000 different companies, providing value across them, right? So there's, you know, obviously the scary sides of these things, but like there's a lot of like kind of efficiency and optimization we could bring just purely through incentives.
I think, you know, what David is talking about is essentially a form of governance, and I think we're going to see more and more governance because, you know, like in the example of an agent working for many companies, it could build reputation, right? But it could also be stealing information and then rug those companies or rob them or do something awful, right? So like, how do you prevent that? Well, you need that governance. You need to have consequences. So that's not a winning strategy for the agent.
Yeah, thank you guys. I think our time is almost up, but my conclusion from hearing from you guys is, first of all, blockchain, as a ledger, that keeping track of, what agents are doing, transactions is important, but really using token as a way, as an economic incentive, right? To first of all, to reward agents that do really well and punish the agents that don't do well, and also using it a way to set maybe even guardrails or governance or maybe tokenize agents, right? If they do bad things, we can vote them out and they lose their power. So token really is another way to govern the agents more than just using blockchain for payment, right? Anything else we should add, or any other things? I actually want to ask you guys, do you guys believe in post-abundance society? Do you think in a few years' time, human jobs are all done, many jobs are done by agents, and we can live, without having to worry about...
Yeah, I believe that. I believe that there will be abundance, as the agents in autonomous system take more of the tedious work. There will be
cheaper
more
power.
Cheaper labor, yeah, exactly.
Cheaper
Things get
power,
cheaper, more wealth
cheaper
is distributed.
compute.
Yeah, I think that's true.
Yeah, I go back and forth on this a bit. I definitely think eventually there will be like this post-abundance, but I think for a long time we'll be in this kind of phase where like Google Maps kind of just made everybody not need to know how to go anywhere.
We get dumber
right?
and dumber.
Right. So you just don't need directions. You don't need to know anything. But it's also like this, like the shift from like the analog to digital phase. There's still people that are just writing by hand. They're in diaries or like printing stuff out.
Yeah,
like
that will never go away. That's being human, right? But post-abundance human.
I mean, I think if things go well, I'm not super confident things are on track to go well. I mean, I think we're racing ahead, building AGI and soon superintelligence, mostly by centralized labs, and we are not doing the research or designing superintelligent species with the appropriate care it deserves. So I don't know why we would expect abundance and good outcomes for humans to emerge from the process we're following, but let's hope.
I like to hope, and I think we need to fight for it, because without social structures, we won't have it, right? If you look at history as a guide. So we need governance, not just over AI agents, but also how we use them, how we use the resources, and so on. And that's like a topical theme.
Well, the agent will govern themselves. You already set up the governance. They don't need you to be involved. The agents will just govern themselves. The AI will be very, logical, benevolent, and they don't need us involved in the governance.
Let's see. Let's hope, I guess.
Not saying not need us anymore means that there's a chance that we will be eliminated. So
I don't know. I think the bigger question is, as kind of Roy alluded to, how much faith you have in humanity to do the right thing. And based on like the past decades, the answer is up to you.
So that's why AI should take over. All right, thank you so much, everyone. Hopefully you have
you.
a good time.
Thank you.
Have a
Hello, everyone. Hello, hello. We're finishing up with just a few more panels for tonight. Next one is going to be Decentralized Data from Storage to Governance, moderated by Rob from Volt Capital. Please invite to the stage the speakers, Dao from Hive DA, Chi from Kite AI, Shashank from Fraction AI, Galanthia from Masa, and Steven from Space and Time. Please welcome to the stage.
I don't want to drop him. Oh, are we sharing?
All right, so we are ready. Just a quick hello. I'm Rob, a partner at Volt Capital, and that's probably enough of me. Let's get to the panel, which is decentralized data from storage to governance. So our lovely panelists here have been focusing on the data ecosystem for quite some time, the entire pipeline. So we often hear that data is the new oil. I actually just got an invite titled like data is the lifeblood of AI. While huge computing systems can be a bit of a big advantage for certain companies, how do you see these two factors, data and computing power, shaping modern AI? And more importantly, how does this address, or how does your company help address these challenges? So we'll start off first with yourself.
Hello. Can you hear me? All right. Hey, I'm Steve Hilton, Head of Solutions, Space and Time. Thank you, by the way, for hosting. I think, there we go. Centralized, I think AI obviously is really being bulldozed in by the big centralized companies insofar as there's a race to get this stuff done. And when you're in a race, you can't take time for nuance. You just got to get it done, right? Because the first one there often is the trendsetter. That's OpenAI in a lot of these cases. But I think we're starting to see. I think we're starting to see a turn where we're opening the door for additional nuance. Whether you believe DeepSeek's assertions or not, like there's some nuance there that was groundbreaking, and so I think that nuance opens the door for decentralized AI more because now a lot of the big LLMs have been trained. You can take advantage of those with decentralized data. And I should also probably mention, I'm with Space and Time. We're a decentralized data warehouse. So think of us like a DPIN plus a blockchain. But we're all about servicing data into things like AI, into decentralized systems. And so we're seeing a real uptick in the number of decentralized AI companies that we're working with. And I think that's because the industry, or the kind of technologies is really starting to come up with the need for nuance, to start gaining efficiency. Because I don't know of any decentralized AI company out there that's going to be able to go toe-to-toe with Google as far as sheer compute, right? They just have the bulldozers. Now we're going to come back in, right, with the sculpting tools and do things that are, I think, a lot more impressive because it's going to take that creative problem solving to get there.
Great.
All right, so I think not every part of AI needs to be decentralized. I hope everyone agrees.
I agree.
However, I think data is a great layer to be decentralized. Why is that? I think in the future, we'll have tens of millions of AI entrepreneurs in the US. Some of them might be technical, some of them may not need to be technical, and everyone will be able to build AI applications, in particular AI agents. And all those AI agents and applications would require data. So at Masa, what we do is that we provide real-time data to run those AI agents. Currently, in order to get those very expensive and gate-kept real-time data, you have to pay $10,000 to $40,000, for example, every month to Twitter. With Masa, what we have done is that we have a decentralized network of miners who are able to collect and structure those data in real time for you and return it back to you in traditional API. So hopefully, through this panel, we can share different kind of format of data, and super excited to be here.
Yeah, so first of all, I would like to say not all data is created equal. All the centralized models that are out there are already trained on all of the internet, so they have seen everything that we have posted so far. and they can kind of generate everything that is known. So what we need for training better AI models is new data, new and better data. And just doing it through humans is not enough because it's a slow process. And if you just get people to create data, it's difficult to maintain the quality. And DeepSeek has shown us a new approach where they generate their data and train their models through a pure RL approach. So they use their model to generate data and then filter it out through specific rules, and then that data is used to make the model better. So I think that will be the path that will take us forward. That we use different models, different agents, which capture different human insights, and use that to create new data, and then use that data to make better AI. And that can be done in a decentralized manner, and decentralization is a huge advantage there, because everyone can come up with their own agents, with their own nuanced insights, and the new data that will be created will be powered by those insights. And yeah, that's what we do at Fraction AI.
Hey guys, I'm Chi. Goes back to a question that Rob asked. So first of all, I think definitely the change of this, for example, like the engineer optimization, like what DeepSeek have done, and like a further potentially framework change will make the compute shortage or compute bottleneck become less a problem. But why data will still be a big problem here is, to us, we consider one of the key reasons is lack of those ownership and provenance tracking. So like what Shashanka from Fraction AI mentioned about DeepSeek is using model to generate data, then the other question now can ask is, okay, where those model have been trained their model on? So then, if the data has been used to train the model to then generate new data, in this process, how would the ownership and the provenance tracking going, and what does that mean from economy, from monetization perspective? Which to us, we consider it's super important because apparently we see a lot of people want to do great open source AI, including DeepSeek, but unfortunately most of the company cannot do that. Unless you are a Meta or like DeepSeek mother company is a hedge fund. They probably can make more money than just do the AI selling at that moment. But anyways, so that's why what we are building actually is trying to design the new consensus mechanism, what we call the proof of attributed intelligence, to really bring this transparent provenance tracking and fair rewards back to each of the layer of attribute of the AI workload, from the data to model to agent. So that's how we think can solve the data challenge.
Yeah, so when you talk about like more of the decentralized AI systems, there really data becomes a big selling point. Like the more data that you have, the better that you can really train your AI model. And there's a lot of compute in both the centralized AI, but also in the decentralized AI. If you take Bitcoin as one of the example networks actually, which is obviously not an AI network, but it has more compute power than all of the AWS server parks combined. So I think with like decentralized, we already do compute pretty well, but I think data still remains a bottleneck, and not only in volumes, but also in integrity, verifiability, and in speed. So that's what we try to solve with HiveDA. So we have a data availability layer that handles gigabytes of throughput instead of megabytes per throughput. And this really becomes a corner piece to not only share the data, because I think in the decentralized world we really have this opportunity to build an open ecosystem. But for that open ecosystem to foster, we really need all of this data to also be verifiable. It needs to have integrity. And of course it needs to have speed as well, because without speed you can't really build much sophisticated solutions. So that's what we're building, and how we see this compute and data shape the world of modern AIs.
Great. So we kind of went over what everyone's building, and it sounds like there's a lot of trade-offs in the design of all the different protocols. So some solutions store only pointers on chain, while others have the bulk of it off chain. Others push more data on chain for maximum transparency. So I would like each of you to kind of go through like, how do you decide which approach works best for your specific use cases, and like what went into that decision? And we can start at the other end.
Okay, I can go. So in our case, we store most of the data off-chain because the scale of data that's generated it can't be stored on chain, so it's not really a choice. But we do store the hashes on chain, so anytime you can go and verify a piece of data that it's the same, it's not been changed when it was created. And I think that's the solution we should go with to stay competitive. Otherwise, we would be focusing too much on decentralization, and we won't be able to create competitive models. And nobody cares about a model that doesn't really work, but is decentralized. So better create models and make them decentralized, but make them performant as well.
Awesome. I actually really disagree, but that's perfect because but I agree with you. There's no possibility now to do anything else but put the pointers on chain because there's just not enough throughput, and it costs way too much as well to put any kind of like large data file on chain. But that's exactly what we're trying to solve. So we actually have like this Byzantine fault tolerant model where data is verifiably still available, but also the integrity is maintained. And then you actually do have the opportunity to be completely transparent about your data, which it definitely has its use cases when you want to actually be able to verify the kind of data that came in, and you want to make sure that it cannot be censored and there's no data withholding attacks. Then it would be better to be completely transparent about your data. Definitely putting the pointers on chain might work now, but I think for a completely decentralized system, we should have not just a trade-off between transparency and cost, but have it both optimized.
What's your throughput right now?
Right now, our throughput is 1 gigabyte per second in testnet, and we want to scale that up way more to like 100 gigabyte per second is the eventual goal. Like we need to have like a decentralized alternative to like these data systems that are completely centralized, and for that we need to have the same throughput as whatever, like an AWS S3 or something like that. So right now it's 1 gigabyte per second to answer your question, but we want to scale this up much more, and our system is built to scale much beyond that as well.
Yeah, that's my point. If you get to that level of throughput, that level of performance, where it's at par with the Web 2 solutions, then yeah, sure. But until then, it's better to just use the best solution and focus on creating the best AI.
We'll talk in the future then.
Sure.
I can chime in as well. So in your camp, we can have actually a debate on stage. That will be fun to watch. It's like 5 p.m. and everyone wants to have a debate. So I'm in your camp because at Masa, we really prioritize being able to give real-time data responses where at least in milliseconds, we're able to provide extremely affordable and cost-effective real-time data to developers. And so far, we have collectively processed 300 million data records, and we are currently profitable as a company. This is all depending on we need to provide real-time data at an extremely low cost and be very competitive to Twitter Developer API, Discord Developer API, etc. So I hope one day we can all go on-chain, but for now, I think decentralization needs to take priorities, and for us, the priority number one is not that.
Okay, I'll go. I don't know that I have a dog in that particular fight, but we take a little bit different approach in Spacetime. So Spacetime, I mentioned, is a data warehouse. It's a database. It's relational in structure, and it's more designed towards big data processing than it is low latency. We can do low latency, but we're talking like 100 milliseconds, not 10 milliseconds. But we can also process many terabytes of data in 5 seconds. And so that's really the sweet spot for us. I mentioned before, we're kind of like a DPIN, but think of it like very permissioned. So one side of it is really very centralized. And so you think of like multiple clusters of servers doing big data processes and what, MPP, massively parallel processing type, structure, if you're familiar with that world. How we get transparency into this is the blockchain side, where as you ingest data into the network, we're ingesting it into the blockchain, which takes cryptographic commitments. They're like hashes, but they're particular, like fancy hashes that you can also do ZK proofs on, which means that all of the data that's in these big decentralized systems also have a highly transparent, permissionless blockchain that holds those commitments. It means that at any point you can get a ZK proof for the data in a permissionless environment for data that sits in a fairly centralized environment, right? And so we're trying to get the balance right here where you can do really big data processing. And by the way, into this big data system, we index all the major blockchains, right? So you don't have to load Ethereum, you don't have to load Bitcoin, you don't have to load, I don't know, whatever the blockchain of choice is here. But it's just sitting there ready to be used, right? But you can always verify that the data is right because we have the ZK proof you can request. You don't have to. And by the way, this allows us to also do things like private tables. Like you can have a permissioned table inside of this environment, that's encrypted and it's got authorization tied to it. Obviously, you can't. That wouldn't go through the blockchain side of it. Right? But that's not the point. The point is that you may have private data in your enterprise that you want to join with public data that you do want to prove. Right? And so we make all of that possible. So from our perspective, it's not about pointers. It's about storing the data in the right structure. Yeah, we have a relational over here, we have blockchain over here, and we try to use both to give our customers the best balance.
My turn. So all very interesting and legit statement from the team. So actually, what we chatted just reminded me in the very beginning when I come into Web3, I come from a very Web2 data and AI infra background. Before Kite, I used to lead product management at Databricks, a big data infrastructure company. So at that time, when I was thinking about at that time when people were saying the decentralized storage, like a Filecoin, decentralized S3, and they say that it's about fault tolerant, it's about faster. I was like, what are you talking about? How possible it can be? Because S3 has always at least 3 copies of files stored there for fault tolerance, and centralized data center will always be faster from a bandwidth perspective. But then I learned more about what does decentralization really mean when it comes to, especially about some transparency, about verifiability. That's a trade-off to do there. And that mentality and that thoughts inherited to what we are building on Kite, then goes back to what we put on chain, what we are not putting on chain. We're trying to strike the balance between being practical and also being decentralized, which means to us about being trustless and being transparent. So in that case, what we are doing is we store a lot of fraction mentioned hash. So actually we design something what we call the data DNA, or data fingerprint at the row level. And whenever there's a transform or something happened to that row, then there's a hash generated and we'll put that on chain. And that's one. And because our goal is using Kite AI to solve the ownership and provenance monetization problem, so we'll put something like the usage and also for example, the pricing licenses, those type of information on chain. And then in order to do that, which I totally agree, both what Darwin and Shashanka mentioned about there is something we have to do customization to make the throughput, make the scalability happen. So we are doing that as well for example, at the execution level and data availability level. We know that the traditional blockchain, including both the EVM and non-EVM system, is not designed to handle the AI native compute or workload correctly. So we're optimizing, or we're introducing a new AI native data structure that really can help us to store something like the AI output format type of thing to the chain. But yeah, so that's some things that we put on chain, but a lot of things we still consider off chain, or at least the storing the decentralized storage will be a better option at the moment.
Thanks for that. Now, one thing I want to kind of touch upon is you guys kept mentioning the different components being brought on chain and off chain, but how do you think about rewarding users? Not all data is equal. So is there a certain incentive structure that you kind of want to build out or are thinking about building out or currently using? We can start with you, sir.
Sure. This is definitely near and dear to our heart. I mentioned that as a data network, decentralized data network, we index different blockchains into our network, but it's a permissionless network. The intention here is to have a data marketplace where anyone can bring valuable data, they create the table, and they load the data set, and then at that point, anybody who queries it, they get a share of the gas that goes to the chain. So I'll use round numbers. These haven't been, we're in testnet, by the way, just to be clear. So when I say that we do this, we do that, we are doing it in testnet, but not in mainnet yet. But in round numbers, you can imagine the node operator is going to get half of the gas for the network, and then whoever owns the table of the data being queried is going to get the other half, or that prorated share, right? And so we have ability for people to sell data inside of space and time today, but it has to be permissioned data, right? Because otherwise anyone can go look at it. What this new data marketplace on the blockchain side allows us to do is have permissionless data marketplace where anyone can come in. Again, we load like SWE data. If someone comes in and loads better SWE data than we do, great, awesome. People start using that, and that person or entity starts getting incentivized for it. And so it opens the gate for people who have data sets that are high value, high demand, and they just don't have a place to really monetize this easily today. And of course, we're all sitting at a Web3 conference, so this usually targets in on Web3 crypto companies, but not exclusively. As a data warehouse, we're, if you're familiar with Google BigQuery or Snowflake or these kinds of things, Redshift, we feel very much like, that's exactly what we are. We're just a decentralized version of it. And so you could imagine bringing any kind of structured data into this environment. And so again, the hope is that we are building that marketplace for anyone to bring any relationally structured data set into this environment and make it available to anybody. And it's permission. You don't have to ask us, you just do it. In fact, if you want to compete with us, that's fair game.
Yeah, to your question, I think incentive is really at the key of the development of decentralization and decentralized AI. If show of hand, who knows Scale AI in the crowd? Okay, the entire panel, hopefully at least. So Scale AI makes a couple $100 million in annual revenue. What they do is that they provide data for some of the most sophisticated AI developers, institutions, and government departments out there. And they are basically, I guess, the leader in centralized AI provision. But if you think about it, if you peel behind the facade of Scale AI, they essentially run a global contractor network that has a lot of human labor involved in data annotation, data labeling, and data cleansing. Imagine if you turn every single human being on planet Earth to a contributor to a decentralized AI network. That's what we all do in some shape or form on this panel. So every single person can become a contributor in Scale AI or any of the data network in there. And why would those people be interested in joining? It is because of the incentive that we provide to each individual contributor on the network. So at Masa specifically, every month we distribute around $500,000 of incentive to the top performing 256 contributors or data miners on our network. And their contribution is really scored by the quality of data, the volume of data, and then the response time when it comes to how fast they respond to the data queries on our network. In short, incentive is really the key and the reason why I think decentralized AI will take over the world in the future.
Yeah, so I really believe in there always have to be two kinds of incentives, shorter term and the longer term. I believe in Web3 we have done a lot of longer term incentives where you are given out tokens which accrue their value in the future, but there has to be some shorter term incentive as well. And secondly, I believe only the high quality data has to be rewarded, and on the other side, if someone submits something that's not high quality, they should be punished. So we have something like that on a platform where you create agents that are competing to add data to create better models. And if your agent performs really well, it can actually make money. And if it does really bad, then it also loses money. So that by itself creates this cycle where all the agents that are adding good data are making money, so they're incentivized to do better, and all the bad agents just kind of go off the platform. And this is necessary because each of those agents are making API calls to the LLMs, and that's costly. So we need to optimize on that as well. So these are short-term incentives which you earn while you are contributing data, and they are longer-term incentives in the form of tokens, which give you ownership of the models that you help create. So I believe both kind of incentives are necessary. If you're skipping out on any of those, then yeah, it's kind of suboptimal.
First of all, very agree with what Kalasha mentioned about the incentive is everything. And also, it's, sorry, I want to tell a lousy joke. Actually, a lot of people are saying, like, who made real money in the Gen AI war? It's the
NVIDIA.
three company. It's NVIDIA, it's a Scale AI, it's a Databricks. One compute company, two data company, not model company. Sorry, anyways, sorry for the lousy joke. But goes back to what we consider about the incentive and how to, like really leverage a decentralized AI to solve the data bottleneck piece. There's three steps we consider is super important. One is actually what I agree with Stefan mentioned about the data marketplace. We consider like crypto actually offer a great way to tokenize the assets. And in this way, actually tokenize the data marketplace will be a great idea to, like incentivize users or even like businesses to contribute their data, bring that in front of the data wall a little bit better than, or like more incentive than before. But actually that's to us, we consider the very short-term incentive, because that is not even, could be not based on usage, because we know there's a lot of times, a lot of speculation about the value of the assets before the assets being super useful. So that's why the second step is being performance-based driven incentive. So that's also why we consider that having the real volume-based, or like what we call like the token, right? Like the AI token-based usage to track and value how much this AI asset has been contributed to this economy is super important. And that's also why we consider, as much as we admire like a proof of staking or proof of work type of proof mechanism, consensus mechanism is not designed for AI, because you cannot just have staking, very subjective type of this decision to say, oh, I like your model, I like your agent, I like your data, so I want to stake more, so you can then, as a provider, get more rewards. That's we don't think sustainable in long term. And the third thing is also actually then goes to the token side. Now, if you are the token holder or you earn the token by contributing, then maybe you can even involve in the future of regulation and compliance of and also like the upgrade of the protocol design, which is a little bit more on the crypto side, but it's also very interesting because as people, as everybody, should also have a say and a vote in the future how this decentralized AI should be involved.
Yeah, I really love what was said here. Agree with everything here, especially the incentive alignment of everyone contributing data. Really thought the Scale AI analogy really went well there. For us, we're just a data publishing layer. So for us, the incentive alignment needs to be there with the more storage that you provide, the more incentive you get, so that eventually with the incentives you can provide more storage essentially. But that goes very hand in hand with technicals, because you need to be horizontally scalable to actually have that as well. So it's always this balance of the technical and the incentives there, because there's a certain amount of max of nodes that you can have in there that actually provide storage. Of course, we're trying to solve that, but the incentive alignment comes very much there with instead of having this one gatekeeper that owns all the data and thereby has all the incentives, you really distribute this among like a permissionless and decentralized network of nodes rather than just that one gatekeeper. And then protocols building on top of that, they will have the incentive alignment for the machine learning engineers, for the data providers, for the data consumers, so that this all becomes a decentralized and permissionless system from the bottom layer all the way to the top layer.
So do you provide incentives based on the device that the people are adding to the network? So if they add SSD, they would earn more, and if they add hard drive, they would earn less, something like that?
Yeah, the more storage requests essentially you process, the more work you do, the more incentives you get. So it's very tied to the amount of data that you can process at 1 second, for example.
Yeah, but 1 TB of SSD is not equal to 1 TB of hard drive, right? So do you measure them differently somehow, or is it the same? 1 terabyte of SSD is faster than 1 terabyte of hard disk drive. So do you measure them differently, or is it just based on storage?
No. It's you verify this afterwards. So you can verify afterwards how much one node has stored. Whether that's SSD or you keep like a really big memory, which I wouldn't recommend, because after you delete the data, you will be slashed. You can verify this afterwards. So it will be these nodes competing with each other essentially to process more and more data. So if SSD is the way to process more data in 1 second, if like a big server is the way to process stuff in 1 second, then the market will eventually move there.
Okay.
I'd like to shift a little bit more over to agents. Can you show of hands if your protocol leverages agents right now or any form of agentic infrastructure or plans to? Looks like 4 out of 5. Yeah, so as we shift towards more agentic economies where AI agents transact autonomously, how critical is decentralized data and the procuring process, ensuring transparency, security, and fair exchange among these agents? I feel like we should start off with...
Happy to. So I'm all in on AI agents to the extent that I have launched an AI agent meme coin. I provide a lot of data to probably, I think, 9 agentic frameworks out there. And I built a BitTensor subnet that is a competitive coliseum for AI agents. That's how bullish I am about AI agents. In general, I think the first wave of AI agent in crypto we have seen are really conversational AI agents on Twitter. Started with Gold, but then we've seen many other really stellar and outstanding and funny AI agents on Twitter. One of the biggest roadblocks when it comes to those conversational AI agent is really being able to consume real-time data and then be able to react to real-time data so that they can have real engaging conversation with their followers and community on Twitter. So at Masa, we have been providing real-time Twitter data to agentic frameworks since we launched on mainnet in April 2024. And then in the past few quarters, we have really seen a surge in our protocol usage because of the AI agents. Just last week, we surpassed a major milestone when it comes to product metric for Masa. We have reached 300 million in data records processed through Masa network thanks to AI agents. So I'm all in on AI agents and would love to do more in the future. Thank you.
I can go next. So I would say I'm pretty bullish on agents because our whole platform is built around that. It's about competing agents, trying to add the best possible data for a model. So we have these things called spaces. Each space is about a certain theme. So it could be about writing tweets about Ethereum, writing marketing emails about a particular clothing line, or could be as detailed as possible. And then users create agents for those tasks, and those agents then compete to create the best possible data for these tasks. And I believe this is the future because the time when humans used to label data is kind of done, and DeepSeek has proved it, where it introduced GRPO, where the model generated data, and then they were able to filter it out in a way to make it usable for training and making their model better. And that's what we do. We just do it in a decentralized manner, where people create their own agents, and then those agents try to create the best possible data. And yeah, super bullish on agents.
Yeah, so I'm also really bullish about agents, and especially actually the agents that are going to be trading on-chain. So there's different reports about this, but there's probably going to be a lot of agents trading on-chain at some point. There's already some agents trading on-chain, but when you have these agents trading on-chain and you trust them with your life savings or with just some of your assets, you generally want to be sure that they're actually using the correct data. So this is where I think like data verifiability really comes in, to make sure that your agent is not using the model that you did not describe to it, is actually using the correct data and not some data from 1990, actually being able to verify everything from the agent's actual interactions, which we'll be able to see on-chain, but also the input that it is using to make all of its decisions.
Yeah, actually, I consider this is something I heard from a friend before, and I really love to use that statement. Agent is actually like an ultimate combination of the compute, the model, and the data. So one thing I really like about agent is really it could become the true out-of-box solutions for end user, for everybody to leverage in their life to use. Because honestly speaking, if we're only talking about data, it's still a little bit far away from end users or consumers to leverage without some easy solutions there, and agent make it happen, especially now in the future. If everybody can launch their agent, that's such a cool idea, and then that's become, then truly democratization of AI technology to me. Then goes back to about the agent economy. That's the same thing that we previously chatted about. Because if we consider agent as the ultimate combination of all those fundamental AI resources underlying, then what important is here is actually how you can phrase or again, properly track the ownership and attribution of those contributions into the end agents for solutions.
You want to go?
Sure.
Yep.
I'll answer.
Yep.
Agent's going to be dead in 6 months.
That's a good
I'm
take.
kidding. I'm kidding. I want to see who is awake. No. Yeah, who's really listening? No. Yeah. I mean, agents, I think, obviously here to stay. We have a couple different agents that we've deployed. One that's in our platform that you can, as a data warehouse, it runs on SQL, select star from blah, blah, blah. You can now also just give it a prompt. And we have, it's a non-productized vector database behind the scenes that goes through, trolls through all the metadata, and then takes also input data that you can provide it as a human, says, you know, this is my Ethereum table, and here's what the columns mean, and here's what, you know, the different, any metadata or business terms that you want to give it. All that's extensible, it'll go through and try and figure it out itself, but if it can't, it's good to do. We see pretty good success with that. It's really particularly powerful when we look at the community that logs into Space and Time that are not SQL analysts, right? And it kind of makes me sad when you say people don't get to play with, no more people in data. That kind of makes me sad a little bit. I mean, I totally agree with you, by the way. And that's what we see. The community goes in and they just prompt their way to, you know, to answer sets. And then there's another little, we'll call it a baby AI that looks at the answer set that you get and comes with, I don't know, between 5 and 20 different graphs. Like, okay, we think that this data structure with this, you know, kind of key will look good as a pie chart or a, you know, a multi-line chart or whatever. And so really with a very primitive knowledge of what the data is, you don't even have to really know the columns or anything. You just have to say, hey, you know, show me the last 2 months of you know, liquidity on Aave. And it will go through and calculate it and give you the data set and create a bunch of graphics for you. And then you can say, start a new dashboard and pin that on my dashboard. The next step, which is, you know, we're looking towards is, what about a dashboard agent that can actually just drive the other two agents and say, hey, someone is interested in Aave, go make me a dashboard. And they don't even have to pick out, like, it'll just go and you know, pick out what it thinks are the best pieces. Or a step beyond that, hey, I want a whole data application, right? I want to start a dog walking service, and I don't care about tables, I don't care about anything else, but what I want to do is accept crypto as my payment, and I want someone to be able to log into my website and, you know, and pick the time and the place, make sure I have the calendar, you know, free to do that, right? And have all of that built inside of a framework that you know, can basically prompt your way to. And so we're really using, you know, the foundation of space and time is data. But on top of that, we're layering these use cases to make the data structures more accessible, because sadly, I actually do agree that the days of sitting around and writing long SQL statements is probably a thing of the past.
Mm-hmm. Well, we're a little bit over time, but real quick, each person just one hot take, and then that will conclude our panel.
Oh man, hot take. That's pretty open-ended. I think that the next thing that has not been explored yet, or at least I haven't seen it, maybe I just missed it. Someone educate me if your startup is doing this, is visual command in a domestic environment, right? Like having I want to walk into a room and instead of like fumbling for light switch or saying, Alexa, turn on living room light. There are 3 things that share that name, right? Standing like an idiot in the dark. I want to be able to point to something, right? I mean, how easy would that be for an agent to figure out whether you're pointing directly at it? That would be like, of the many things that it can do, that would be super simple. Then you just have to turn it into a switch.
So like a clapper?
Like the clapper. Oh man. I'm going to email them, say you're missing an opportunity here, clapper. I don't even know if they're in business anymore.
I'll keep it short. Hot take for a panel of data infra companies. I think there are too many infra projects out there. There needs to be more application layer and agents project out there, because otherwise we're just we will eventually all converge into providing the same thing at the infra layer.
Well, there'll be a consolidation period. People will buy each other.
Yeah, I don't know if this is a hot take or not, but I really believe we should be making agents more fun rather than making them do boring tasks like writing mails or like which Web2 people are doing anyways. Crypto was more about fun always, so we should come up with more fun tasks. And yeah.
Particularly for this panel, I think data will be the next biggest and ultimate bottleneck for the development and involvement of AI.
You actually stole my hot take, so I'm going to have to come up with a new one. I guess the hot take will be that there's still not enough data on chain, and there's still not enough data that's actually transparent. I'm going to keep that as my hot take.
Thank you, everyone.
Thank you.
Okay, let's go chat with the sound guy. All right. One of the last three panels of the day. We got T's and verifiable compute, securing the trust layer, moderated by Rishan from CoinFund. Please welcome the speakers, Jorge from Nethermind, Ranveer from Witness Chain, Miguel from Nilian, and also Nilan from AWS.
One of the co-founders from Fallout. So I think we're sharing with. No? Oh, you're sharing with Mike. Okay. I think we're sharing.
How's the saying? A wizard is never late. He arrives precisely when he needs to.
That's you. So you go second, I go here because of correspondence. Exactly.
No, actually, I'm not.
Okay. Oh, yeah, you're right.
So I'll share a mic with him. You two guys share a mic, and you have your own mic. Yeah, that's right? Okay.
That works? Okay. Welcome, everyone. Thank you for joining us for this discussion on trusted execution environments and verifiable AI. I think just broadly speaking, as AI systems become more integrated into critical decision-making processes, basically ensuring integrity and trustworthiness is going to be much more salient as we think about AI as a whole. Trusted execution environments, I mean, they've been around for a while. You have hardware chips like Intel SGX, AMD SEV, ARM, that offer kind of more of a hardware-based approach to processing sensitive data and computations in specifically secure environments of the hardware itself. And then on the other side of things, we have verifiable AI, which uses techniques such as remote attestation, zero knowledge, MPC, consensus-based models that ensure computations and outputs independently auditing or kind of proving cryptographically. So, these technologies have been explored in kind of a great depth over the past year or two in particular, and will no doubt increase in significance over the coming few years as we see a greater integration and application of AI into more sensitive systems. And with us today we have an awesome team of panelists with a great breadth of experience from all different kinds of companies working across this stack of verifiable compute in some sense. So thanks for joining everyone. And why don't we just start out down the line, and if you can introduce yourself and some of the work that you are doing, we can kick off like that. Jorge, if you want to start off.
Hello. Can you guys hear me? Yep. Okay. Thank you very much. My name is Jorge Arce. I am a blockchain and cryptography researcher at Nethermind. I've been with the team for close to 3 years now. I have a background in mathematics. And at Nethermind, I had the opportunity to research on a lot of interesting blockchain primitives, mainly around staking, restaking, and also how that interplays with artificial intelligence security, and now AI agents as well. Some of our teams at Nethermind have been working on and championing various TE initiatives, so that's also something we can discuss as part of the panel. But yeah, excited to be here, guys.
Hello, everyone. I'm Han from Fala Network. So Fala Network is a TE network. Basically, you can see it as the AWS, but all running in the TE, built for Web3 and the decentralized AI. And before I created Fala Network, well, actually Fala Network is a really old project. It has been running for 6 years. And before joining Fala, I worked in Google, and it's pretty funny. I work in Google to spy everyone's Gmail. So all your Gmail was scanned by some algorithm I have developed when I was in Google. And I figured out, I'm enough with that. So after 3 years, I totally jumped into the upside. I think this is like Web3. The user privacy matters, collaboration matters. This is where I found I really have the passion about. Thank you.
Hi, this is Zinal. I work with AWS. I'm a solutions architect. I'm a principal. I've been with AWS for the last 13 years. I'm responsible for the Web3 startups. So I work with a lot of Web3 startups directly day to day, and that's why I'm here.
Hi, everyone. My name is Miguel, co-founder and chief scientist of Nilium. At Nilium, we're building a blind computer, which is a new type of infrastructure, Web3 infrastructure, that enables you to compute and store personal information, private information. And essentially, my background is at the intersection between engineering and PhD in maths. And what we're working now, one of the things we're working at, is at the intersection between TEs and other privacy-enhancing technologies like multi-party computation and FHE.
Hi, everyone. I'm Ranveer. I'm the co-founder of Witness Chain. At Witness Chain, our goal is to bring blockchains and AI, all digital protocols, to the real world. To that end, what we're building is a verifiable observation layer that can be used by AI agents. So think of this as physical world APIs. So you can get data, on-chain data, you can get data on the internet, but we get data which is in the physical world in a verifiable manner.
Awesome. Thank you, guys. Maybe just to start off, it'd be great to set some primary context. At a high level, open to anyone who kind of wants to take it up here. Could you describe a bit kind of what TEs are useful for and maybe some of the other popular encryption techniques which you'd outlined as well, like multi-party computation or homomorphic encryption, and kind of like a high-level overview for the rest of the group?
Yeah, I guess functionally speaking, you can put the three of them like TEs, fully homomorphic encryption and multi-party computation at the same level. What they do, you can think of them in terms of a black box that actually is able to compute on data without seeing it, without having access to it. But they achieve that in different ways. The basic trust assumption behind TEs is a hardware-based one. So you're trusting the manufacturer of the hardware. And with the other two, with FHE and multi-party computation, what you're trusting is actually the maths, so the cryptography behind the solution.
Right. So
go for it. Yeah.
No, maybe just to add to that. So despite the three of those technologies achieving similar goals, it becomes very interesting to think about the different trade-offs that you get into that make one tool the right tool for the job or the wrong tool for the job, right? So for example, with TEs, we have the advantage that they can be a lot more performant in their execution, but the trust assumptions that you're putting on the hardware itself go way up. Whereas when you're using cryptographic techniques, such as like MPC or FHE, normally you're going to see you're not trusting the hardware anymore, you're relying on, mathematics essentially, or like splitting the trust across a set of various parties, which is what MPC does. But you're also going to see a decrease in performance, which is, for example, something that happens very common with fully homomorphic encryption, which essentially allows you to compute on arbitrarily encrypted data, but it can be very, very slow, especially for certain use cases or if you want to do it on chain or so. So sometimes you have to think very carefully about the trade-offs and what's the right tool for the job. Sometimes, for example, you don't even need fully homomorphic encryption. You can opt for like a partially homomorphic encryption variant if you're just trying to like add up results into a tally that is much more performant. So this becomes very much a game of knowing the tools you're working with. So you can pick the correct one. It's not necessarily that one is strictly better than the other. And it's what makes like this kind of like blockchain and cryptographic design such an interesting field.
I can add a little bit to the TE side because we have been working on TE for a long time, and TE actually has a lot of generations. And now I would say now it's a TE 2.0. And at the beginning there was TE 1.0. That was Intel SGX, and now like Intel TDX or AMD SEV. I would say a lot. You guys already mentioned a lot about their difference. One point I want to add is. TE actually have the biggest difference to me is that it has a really great developer experience. So you can imagine you just have some program, maybe even developed by yourself, throw it into a TE, and boom, it just work within a few clicks, just a few seconds. So yeah, this is one of the benefit of TE I just want to add.
Just following up to Todd logic, historically we always have the hardware isolation, we always have the securing cryptographic security of the secrets, we always had those things. But what's happening with the TEE is that we now have the execution and the attestation coming with it. The computation coming with it is a huge differentiation compared to other systems that we had historically.
So I'll provide a slightly different perspective by going into like what kind of security you need. Right?
Yes.
So in our case, to highlight what we are doing is we want to make sure, so let's say if some protocol asks us, how many people are sitting in this event, right? So somebody can take a photo to prove it, right? But it has to be associated with multiple types of security. You need to make sure that photo was clicked at the right time. So you need verified timestamping. And that's what blockchains are used for. TEs have limitations that you can't do distributed timestamping natively using one machine. The second thing we want to make sure is that the data actually was collected by a sensor, a camera sensor, rather than it being collected through some synthetic means like AI generated. And for that, we rely on trusted hardware to make sure that whatever data we are collecting actually came from a sensor rather than it being generated artificially. And the third thing we need to prove is whether it was clicked at the right location. Right? So you don't want people to fake locations and claim something else. And for that, we require a distributed set of nodes to do active measurements over a network. So we run what is called a proof of location to verify it. So you can see in our stack, we use 3 different technologies to achieve the security. TE is part of it, where we make sure it's not used for compute, but it's used for making sure that the data actually comes from a sensor.
Awesome. Yeah. Anything else to add?
Yeah, I would like to dive a little bit deeper into what Jorge was saying.
On the trade-off
On the
specifically.
trade-off space.
Please.
Sometimes you don't have to look at that as in terms of a binary choice between either software-based cryptography or hardware-based. There's also the possibility to actually combine them. So we've been working, for example, on providing private RAG, so retrieval augmented generation, in a mixed solution that uses some part of MPC and storage in the form of shares. And then part of the computation is done in the TE. But actually the part that goes into the TE is not revealing anything about the vectors, but just some distances related to them. So you're minimizing the amount of information that is actually processed inside of the TE, but you're doing the hard work that would take a lot of time in an MPC or FHE setting, which is the comparisons inside of the TE. And another example is inference. So we're running inference using split technique, whereby some of the elements in the layers, the complex ones, like the activation functions, they're running inside of TEs.
Yep.
That is the slow part. But then the other ones, the linear layers, they're running inside of MPC or FHE. So in doing that and in choosing how many things you run inside of a TE versus inside of MPC or FHE, you have like a slider that enables you to fine-tune between performance and security. And I think that's a very interesting concept.
Definitely. I think uniformly, it's pretty interesting to see that kind of across the spectrum of technologies. It's a good way to put it, right? You're going to have trade-offs in terms of what's easy to use, and where there's more off-the-shelf development versus what I guess is the most computationally secure. Although the overhead is a big question, right? And I think that's as we kind of shift to maybe the next part, which is what adoption looks like in this category. I think that's something serially that is a question that whether it's customers or people have generally always had. It's what do adoption curves for these sorts of technologies kind of look like, right? Because in some sense, customers might be unfamiliar with the security needs that they necessarily need to have, or there's a question of how secure. So would love to kind of hear any thoughts that you guys have on kind of maybe any initial signals of demand that you've seen organically, what sort of indications you've gotten from there, and how you think it kind of plays out over the next 3 to 5 years.
Oh yeah, maybe I can talk about that first. Actually, 1 year before, just last December, when we talk about TE, most of the people just think, oh, why are you using TE given we have ZK, MPC, or FHE? Because TE is having the problems every year. But now you can see the sentiment has changed. I think it's changed for a few reasons. The biggest reason is the demand driven. So we launched a cloud platform just in December, late December. And just in two months, now we already accumulated more than 600 users, and there are more than 1,500 vCPUs already used in our cloud. So the curve is like a boom, skyrocket. So that's what convinced me the most. There's real demand. If we break that down a little bit, then there are a bunch of different use cases. A very obvious use case is AI agent, because there are a lot of AI agents. All of them claim they're running in a TE to get some credibility. And indeed, 90% of our cloud users actually deploy the TE AI agent. And they are mostly individuals or launchpads, like meme coin launchpad or AI agent launchpad. On the other side, we also have another service. Well, it's not selling the service, but we're running the GPU TE. So GPU-TE means that you can have the NVIDIA H100, H200 enable the TE mode. So you can actually run serious machine learning model training and inference. And we do have a few clients working on that as well. Roughly, if you check the revenue, I think it's roughly half-half. Half from the public cloud, purely CPU AI agent, and half of them are running the GPU. Some of them running training, some of them running inference, and across all the entire supply chain of decentralized AI. So you need to have credible training, credible inference, AI agent, and even data processing. So combine them together, I would say this is a full supply chain of decentralized AI.
So I can go with some numbers. I cover I cover like engaged startups for AWS for Web3, and last year I had 20 customers. 15 of them were Enclave users. This is like unbelievable. I wasn't expecting like this much, and I think the main.
Just curious, relatively, what was that versus 3-4 years ago?
That was literally zero. Because like that was so super I think the differentiation is access to technology is it's leveling out. Like in the past, you need to have access to a very specific hardware, very specific library, and you need to learn and know that thing. That's a very expensive experiment. Right now, people just read a blog post, or I can do like enclave back wallets. Oh, let me do it. Just let me follow step by step. Or I can do MPC using enclaves, like something like that. And it's not just for AWS. Other cloud providers doing similar things. Access to technology is getting easier now. We have a lot of partners who are also implementing the same technology with different means. So the access is increasing. The use cases are very straightforward. It is not rocket science anymore. So the implementation, the number of users are increasing in a level that now it's creating the site industry. People are taking these TEs and creating APIs, building APIs and solutions over it, which is like the next gen. The layer 2s of the TEs are right now in place.
Yeah, we're seeing also incredible demand from the AI side of things. So a lot of people building agents and platforms for agents, and also things around that as well. Like for example, the need for agents to be able to store private information somewhere, and also the need to be able to orchestrate communication between different agents. So you can build like swarms, and the permissioning layer necessary for that as well. And also we're seeing a lot of interest and demand from DeSci. So DeSci is very interesting because it combines a lot of big data. So you have a lot of information captured, for example, from your wearables, like heart rate or sleeping patterns. You put that not in a TE, because that would be a bad idea, but you put that on a decentralized database that has secure storage, like for example, based on secret sharing, based on MPC. And then the next thing you do is that you consume that from a TE and you run some computation to provide you with insights, for example. Or you let someone else, a third party, to run computations and get insights, and you can monetize on that. So we're seeing a lot of people also very interested in building that type of solutions.
So in our case, where we see the most applications is in verifying community. So in crypto and in most protocols that have real-world operations, you want to verify your community if you want to incentivize. So you want to incentivize your community, and if you incentivize the community, you have to verify it. A classic example of this is, let's say you want to do an airdrop, right? And in that case, how do you make sure that you are targeting the right community to do that? How do you make sure that the people I'm sending money to are not industrial airdrop farmers, right? And the way to prevent that is if you have observability into, okay, where are these people who I'm sending? Where is my community actually at? Where is that individual actually at? And are they a real person or not? That observability helps incentive distributions a lot. And in the end, most crypto projects and even a lot of Web 2 operations rely heavily on knowing who should I send incentives to, which is the right community to incentivize. And that's what we help with.
Awesome. Any other use cases people want to highlight?
So I think that's been a very good bird's side view of specific niches. And that's maybe to bring it in, I would say, from my perspective, TE is just booming at the moment, right? Especially with the rise of AI agents, and it giving you such a convenient way to prove that you are indeed dealing with an AI agent, and that the responses, the outputs of the agent are indeed coming from like LLM inference, and not just a human in the loop that is maliciously like injected in answers. So there's a bunch of agents on Twitter that have been let loose, and like say AI XBT and the like. People trust that those are agents, and if you construct them carefully, you can use, for example, TEs to ascertain that this is the case. Other approaches to this problem involving zero knowledge. If we think about, for example, zero knowledge machine learning, which Miguel was talking about, the fact that doing it end to end at the moment is not quite feasible computationally, especially for a big LLM. So you have to look into workarounds, maybe like split the problem into like put the most complex piece elsewhere. Or there's a very interesting workaround that people have found with zero knowledge under the name of zk-TLS, which allows you to prove that a TLS connection allows a third party to like audit a TLS connection, prove that the outputs of it indeed come from like the TLS transcript, like a connection between a user and a server. And the reason this is important for AI inference is you can use zk-TLS to prove that someone connected to OpenAI's API and like called ChatGPT, right? So this is like maybe full-on ZK-ML is not usable in production now, but you can use these kinds of workarounds with zero knowledge if you get creative to prove that indeed you're connecting to a machine learning model, right? The long story short, TEs are already in full swing here. ZK might be a little bit expensive for certain use cases end-to-end, but there are ways to find workarounds if you're creative. Fully homomorphic encryption is one that has a lot of potential, but I think it's also being like held back by scalability and performance, although teams are doing massive improvements on this as time goes by. So maybe 5 years from now or so, we're going to see it being a lot more commonplace, just like in the way that Hang was describing that TEs like 5 years ago or so, like were not as common because there were all of these problems, and nowadays they are just like essentially the first tool you pick off the shelf.
As an interesting use case, I've seen even a PhD student implementing a full exchange matching engine in the TE so that everybody has a fair access to the trades. So the implementation, like it's becoming so mainstream, like the use case that we didn't hear, a lot of safe room type of flows where like multiple parties access to the same data set without seeing each other's data. The use cases are just multiplying every day. So like who would think like a few years ago like you would run a matching engine in a TE? So now we are seeing like the proposals for that. So.
Quick add up on that. And actually, since this is East Denver, there's a very interesting use case of TE that is in the MEV or block building space. So Flashbox is pretty deep in that. Basically, if you want to eliminate MEV, so maximal extractable value, the only way to do that is to putting it in a TE. All the other solutions doesn't work because people has been exploring that for years. The same time, once we have the TE-based MEV block building mechanism, a lot of things can be unlocked. Say, you can have multiple searchers negotiate inside the TE. You can even send your AI agent to represent your strategy into a TE. They can fight, they can negotiate, but they cannot bring any sensitive information out of the TE. It's basically a black box. So those all kinds of interesting things, as you mentioned, is maybe come from the data clean room idea, but also has a lot of use cases in blockchain, Ethereum as well.
Some use cases with agents. I think there's like two types of agents. One is the public ones, like tweeting and doing things like that. The other ones are manipulating personal information. And I think those require not only verifiability in the terms that and sense that Jorge was describing, but also in the sense that you need to have guarantees that there's nothing leaking information. There's, the host of running the TE hasn't introduced any program inside of the VM that is actually accessing the information that the agent is running on or working on. So the attestation also covers for that, which is great. And some examples of use cases we're seeing built are, for example, covering Telegram. So I don't know about you guys, but for me, Telegram is a mess. It has a lot of messages, so it would be great to have an agent just go through that, organize it, create groups for you. But of course, that's really sensitive information. Actually, it is legally troublesome because you're dealing with third parties, and there's probably confidentiality clauses in place. So privacy is of the essence right there. Another example is agents providing you with advice. For example, tax advice, health advice. So one example is you get 2 agents provided with diagnosis on some symptoms that you send over to the agents, and then there's a third agent that decides which one is the best one. So you get the benefit of the second opinion and a judge that makes the decision. In all those use cases, privacy is of the essence. And so the attestations go beyond just the integrity of the service. You just don't want to be sure that the right model is being run inside of the TE, but actually you want to be sure that nothing else is running inside of the TE so that no information is being leaked out.
I think one thing I wanted to highlight, since we're on the topic of fair matching and MEV, as important as it is to ensure that the computes happen correctly, it's also important that the data going inside the TE happens in a fair manner. So in case of, for example, in case of MEV, you can artificially, for example, introduce delays before your message or your order goes within the machine. Or you can co-locate your trading software to where the actual TE is situated. And that gives you significant advantage over where if somebody else is trading from other side of the world, in case of matching. So I think we need to compose multiple technologies together. You need to compose TEs for fair order matching. You need to compose some geolocation trade-offs to make sure that your end system works. So I think rather than comparing different techniques, I think the right approach is to compose multiple such techniques together. And I think TE is a very powerful tool.
Awesome point. Yeah, I think it's a great point. Composability is kind of the name of the game here, and at a hardware level, it's secure computing is just going to become more so the standard. You'll see to your point, GPUs like B200 chips are all TEs are going to be a standard in this case, and yeah, as more secure use cases are rolled out, that's where these sort of computations are going to be more relevant. I think we only have a few minutes left, so I guess in terms of closing thoughts, anything you guys particularly want to call out to watch for that we should be paying attention to broadly in this space that you might be working on or otherwise?
I think, continuing on that point, I think we need to look at the larger picture and see TEs just as a building block inside of a larger solution that combines other privacy-enhancing technologies. For example, for storage, you would probably want to use secret shares or encryption on top of that. For permissions, you don't want to do that inside of a TE, but you want to run them somewhere else. For blockchain integrations, you want to be using signatures, but ideally you could thresholdize them, so you could use MPC type of signatures so that the private key is never reconstructed inside of the TE, and that gives you higher security guarantees. And I think it is in that combination of all those pieces that you can then achieve the best out of each one of those technologies and provide really interesting solutions.
Go for it, Jorge.
Yeah. Maybe to point out, in terms of verifiable compute, we have talked about hardware solutions, TEs. We have talked about cryptographic solutions, ZK, FHE, MPC. One that we didn't touch upon at all, which is quite one of my areas of interest, is cryptoeconomic security, so to speak, and what you can achieve with primitives like restaking and the like, right? So this is another way in which, you're essentially, for example, setting up a set of operators to generate a certain computation, and then they have to attest to the validity of that computation and put that attestation on chain. And if the computation is proven wrong by an outside party, you can use this attestation that was put on chain to slash those operators or punish them somehow. And the idea is that if you design this game right and sort of so that the punishment for doing things wrong is greater than the potential earnings from letting yourself be corrupted, so to speak, then a rational actor is never going to go against the system. And this is another way to achieve verifiable computation that doesn't involve any of these primitives we have discussed. It's also an approach that tends to mix well with decentralization, and this is what like EigenLayer and AWSs are essentially doing. On my side, and with regards to like some of the research we do at Nethermind, we are interested in exploring how these verifiable computation services in the form of AWSs interact with AI agents. In particular, whether we can decide on AWS to decentralize the runtime of an AI agent itself so that it's running across a set of operators in a way that it's hard to censor, or it doesn't depend on single points of failure that can be easily taken down. So I would say, yeah, in terms of like composability and like blockchain integration or such, we also have to think about cryptocurrency security for verifiable compute and the primitives of restaking and the like. And many of these interact very well with TEEs, for example. So when you mix cryptocurrency security and TEEs, you can bring or eliminate entirely a whole set of failure modes. So maybe now your operators, if they are running the let's say AWS software in a TEE, you don't have to worry about them being malicious or going against the protocol. Now you just have to worry about them, what happens if they turn their machines down. Maybe the only way they have, the only recourse they have to go against the protocol is to censor it, right? But then you have eliminated a huge set of problems, especially if they are dealing with sensitive data. So once again, I think perhaps a good takeaway of this is there's a huge set of tools in the toolbox that we can work with. Hardware, cryptography, cryptoeconomic security. When you begin to like mix and match them to have them cover the weaknesses of each other, you can achieve great improvements and like quantum leaps in the form of expression, not quantum computing, right? In terms of like verifiable compute. And yeah, that's it.
Okay, yeah. So one thing you mentioned, I think I'm 100% agree, is like T is like a glue. Right? You can glue T with like AI agent, and you can get a real AI agent, not fake AI agent. And you glue T with say a Web 2 program, then you get Web 3. So Web 2 in, Web 3 out. This is something we used to mention before. But I would like to bring some spicy take here. So my expectation is that within maybe 2 to 3 years, within Web 3, everything running now on AWS, I think should be moved into TE or maybe AWS TE as well, because there's just no reason you're still running anything on some server that's not as secure as TE, given TE is already there and is very accessible already. Think about the Bybit hack. So it's the largest hack happening in the recent days. The entire industry. All the time, yeah, all-time high. So, but which part gets wrong? It is the front end. Yeah, nobody will even think about we need to use something to secure the front end, because everyone just assume front end is okay. You can compare your own front end and then you're okay, right? But it turns out it's not okay, because in the whole supply chain, or I mean, when you are using like a ledger, you are not just using Ledger, you're also using the blockchain, the smart contract, the front end, the indexer, your computer, right? Any single point in this phase get failure, then you can potentially get wrecked. So all-time high lose. So now if we put all those steps, instead of running in a normal server, but running in a TE, then we can actually let those components to test each other. So you can have interoperable security. Then, it's not going to dig into the detail, but basically, if you put your front end in the TE, then front end will not be hacked that easily. And if you put the indexer in the TE, then you can get end-to-end security between the RPC and your hardware wallet. So why not, right? But even take that one step further, we start to work on TE because we think that blockchain is great, but blockchain cannot solve everything, right? What if in the future Web 3 can even eat Web 2? Then we need something to glue the Web3 and the Web2 part, the glue you mentioned, right? I think T is the perfect glue to bring Web3 to Web2. Or maybe in the future, once we solve all the trustless problem, the trust problem with either on-chain smart contract and the T and other like FHE, MPC, ZK, then we even don't need to have a word Web3, right? It's just the new web. Everything can be trusted and can be verified. So yeah, that's my spicy take.
So I think I need to go next. So I wish AWS listened to me, but the way it works at AWS is we always work backwards from the customer. Our customers tell us, like, this is what we want. This is what, over 90% of the AWS products are built because customers tell us something. Oh, this is what we want. This is what we would like to do. So answering the core question, like, what do you see in the future coming up? Like today I had like 2 different customers. We have like probably many of you having back-to-back meetings. The main question was like, okay, how about the GPU support? Like, okay, now we want to use GPUs with T. So it's increasing. So in the past, it was like a great finding for us. Oh, we can use it in any of the compute that we are offering in the next gen of any offerings. Now suddenly the demand has increased. Now the customers are asking, now we want it on GPU. Now we want it here. So the demand increases, and I think the companies like ours are responding to what customers want. We always act on the customer's demand. And just one side comment to another thing that you said is like on the front end piece. I think within the development and things, we forget because like in the past it used to be very important the front end because the front end was fully loaded with heavy clients. So file integrity monitoring, like the basic PKI, was the key thing that everybody integrated into every security project. And later you say, oh, nothing is happening there, probably it's not too important, we just skipped. Now this thing happened last week. Oh, technically we should be focusing back on the front end. So it's also cyclic. During the development of things, we forget the important parts. So.
Yeah, I think one thing I'm looking forward to is, so we'll be launching something called campaign APIs. It allows AI agents to observe and actuate the real world. And when we go into a future where AI has, or something running on a computer, has a power to request something, some random action in the real world, you want to make sure that there are appropriate laws which are always followed so that it doesn't do harm, right? And that would really require a verifiable form of compute, a compute that I can trust. So I see the future is very bright for TEs.
Awesome. Well, thank you so much. Thank you, everyone. Thanks for the AGI Summit for hosting us. And yeah, next panel soon.
I haven't met it.
I would tell you.
No page.
All right. As the night is coming to a close, I hope you're all feeling rejuvenated, tired, whatever you may want to feel, as long as it's pleasant and nice. And I hope you all have a good dinner afterwards. We're on to our last two panels. This next one going to be about the future of models. We're currently looking for Paige. We found Paige. All right. Well, welcome to the panel on the future of models. It'll be moderated by Casey from Topology. Please welcome the speakers. Peter from CrunchDAO over here, Paige from OpenMind, and Hans from MyShell.
Exciting. All right, I'm going to watch
Hello.
time. So, is this on? I think so.
Hello, test.
Test? Okay. So
Good.
maybe we'll
Test.
just start with intros, just to give everyone context. Maybe we could start with Peter at the end.
Hi everyone, Peter Cotton, like the rabbits. I work at Crunch, and my GitHub handle is microprediction.
Can you guys hear or louder? No, you got to go louder, Peter.
We'll go louder. How's that? We'll do a take two. So Peter Cotton, I'm at CrunchDAO. We are a community of about 7,000 machine learning enthusiasts around the world, and we take business problems and turn them into games and put them back into production.
Okay, I'm Hans, and I'm the product lead at MyShell. So MyShell is a AI consumer layer with decentralization and using tokenomics to do greater incentives on it. And recently, the big news that we have been moving very fast with our AI agent framework is called Shell Agent, and we're looking forward to empower more developers to build more real use case driven AI agents on there and use our token to incentivize them.
Paige, I'm head of growth at OpenMind. We are doing decentralized framework for robotics and also the world's biggest RoboNet for machine-machine and machine-human teaming and communication.
Okay, great. And I'm Casey. I'm the founder of Topology, which is a frontier tech venture firm. Okay, so let's dive in. Maybe we can start with just some specific questions about what your companies are working on. So maybe for Paige, can you just give us an overview of how robotics and Web3 are working today, in the overview?
Yeah, well, if we take a step back, how is robotics working today? I think most people seeing the Unitree robots or the Boston Dynamics robots or the Optimus, at Universal Studio. I think we are entering this age where autonomous robots are starting to entering people's life, whereas for the previous decades, we only see pre-programmed and pre-coded robots that you can control with the Xbox controller. So right now we are at an age where we are starting to develop the models and also the operating system for actually intelligent machines. So how will that intersect with the Web3 part? I think some people are working on the data collection part for robotics foundational models, and for us, we are less on the data side because we think it doesn't make sense for you to work on data if you don't really have a model or operating system yourself. Given that the big closed source operating system, they're not going to use the external data. So what we are tackling is basically we're making an open source runtime AI system for powering machines. And at the same time, we think that it's important for machines across heterogeneous systems to talk to each other and also to coordinate tasks and to actually fulfill tasks. So that's the second part we're working on, this global RoboNet and payment system.
And say a little bit more about the data part. So how it's different between the Web 2 and then the Web 3.
So right now, for the robotics data, most most is collected at the robotics labs at big universities, and they actually need you to interact with the robots versus just like random video data you collect on YouTube. Right? Those are the visual language model you are making, but for robots, it's a visual language action model. Whereas if you don't interact with the hardware, it doesn't make any sense. And so I think when it comes to data collection for the robotics model, it's not the same as the data collection for LLMs that people are used to, that's done by Scale AI. So it's a totally different game.
Okay, awesome. All right, and then maybe
Sorry,
from
can I ask questions?
Yeah, sure.
Yeah,
Question.
I'm just out of curiosity. So you kind of talk about how Web3 plays into the robotic identity part, if I'm not wrong there. So for me, it's kind of like a huge leap forward because we haven't even reached fully autonomous robotics yet, but you guys are planning for the future where fully autonomous robots can communicate with each other and sort of have their identity. Leveraging Web3. I don't know if I'm wrong here, so please correct me.
If we take a step back, I think an interesting use case we're seeing nowadays is like one of our clients, they're like Australian healthcare service company, and they have their robots in a nursing home. They're not fully autonomous. A lot of things are like prompt or pre-programmed, but they want to see the logging of every decision making and behaviors of the robots because they want to make sure the robot doesn't kill the elk.
So it's like a data collection while the robotics are working on it?
Nothing about data collection.
Okay.
It's really about the logging of the decision-making process and also like the behaviors they have. And if you want like a robots from Australian healthcare facility to talk to the deep sea robots from Stanford, there's no way they can talk to each other. Even though they're all on Rust 2, the robotics operating system.
So the protocol doesn't align?
Yeah, there's no consistent communication protocol across heterogeneous systems.
That makes sense. Okay. Yeah, I see.
Does that answer your question?
Well, sort of, yeah. I believe. Okay. So my turn, I guess.
My question for you is just there's a lot of agent frameworks and platforms out there today.
Yes. Too many, I think. Yeah.
Okay, too many. Great. And so how is MyShell differentiating?
Yeah. I think at least speaking in terms of the Web3 vertical only, a lot of the agent frameworks, I won't name them, but and there are too many. They're still popping out today. From my perspective, they're more like agents on the Web3 vertical. Their main technological focus is like help LM to launch tokens from my perspective, plus a couple tool uses. And I think the actual use cases of those agent framework are very limited to the Web3 world, which is okay. And I think I think Y Combinator just launched a couple podcasts regarding how vertical AI agents could be a big chance next year. And I think I totally agree with that. I think if people are building Web3 vertical agents, I think that makes sense. But I think MyShell is playing a completely different game here. We're trying to build a general purpose agent, and without leveraging any code, we try to help more people to build their own agent in different category or in different perspectives, not just in Web3, maybe in image generation, maybe in different productivity, maybe in automating their own workflows, and all different things like that. So our leverage with Web3 is more in terms of the creator economy part. We try to incentivize the developers by our token depending on their agents' use cases or like per users per day. So I think the shell agent framework, in conclusion, is we try to make it more general purpose, not limited to Web3 part only. And I think from my perspective, there are tons of like long tail software needs that are unfulfilled right now, and can be fulfilled in the time of AI, especially in this year where large language model and post-training reasoning can be so strong in coding. I will give you a couple examples. I think whenever we try to learn code, I still remember when I first learned coding in...
when you first started coding, okay.
Yeah, sorry. I still remember when I first tried to learn coding, and I just realized like how many problems can I actually get solved with coding. But there are tons of projects could be done, and tons of like workflows just from my personal life could be automated, but I just couldn't write that much things. And for a lot of time before AI, if you want to build a software so that other people can use it, the general strategy is to pay to get a software engineer to write things for you, or pay a group of software engineers, and to get the money to pay for the engineers, you probably talk to the investors or bootstrap for yourselves. I think the biggest change that's going to happen, especially in this year, because AI gets so good on coding. Actually, Anthropic just launched their cloud Super 7 Sonnet, which is fantastic on coding. Anyways, and I think tons of long tail automation process can be accomplished in this year and next year. Maybe those tasks can only be like 100 or 200 use cases per agent, but because basically every single word in software can be written by AI, I think the chance of how many agents can be built, basically 1 million X from the current status quo. That's my estimation.
Yeah, definitely. Yeah. Agreed. Okay, and then for Peter, just on CrunchDAO, maybe just give us like a more 30-second or 1-minute overview on kind of like what you guys are doing too, because I felt like I actually am less familiar with you than these two projects.
Oh, thanks. So, yeah, so CrunchDAO is...
in relation to the future of models.
Future of models, indeed. So, well, where do we start? So, my views on the future of models, at least 10 years ago, were kind of written down and eventually published in a book called Microprediction: Building an Open AI Network. And the general premise, which people are generally a lot more sympathetic to today, is that AI would be broken down into lots of little economic agents who would self-organize into radically low-cost supply chains for prediction. And then companies would take their business problems and, using control theory and other tools from applied math, would convert them into commodity prediction tasks. And this would solve the fundamental problem of AI, which is really search in the space of models and data. And so the hope was that you'd have a kind of Hayekian revolution in AI, where the notion that the human is the chaperone of models, or behaves a little bit like the librarian who's trying to kind of master all of knowledge with the Dewey Decimal System, is replaced by a far more effective kind of graphical search, organized in large part through the price mechanism. So that's, if you ask me what my future, what the sort of future state might be, that's still kind of my best guess. If anything, I would, since the time of writing down that thesis, I think I've been absolutely stunned by the one main thing, which is just the increased ability of algorithms to navigate the world. And so if you take the view that algorithms will find their own way to business problems and solve them and not rely on humans to kind of hold their hand, and now, of course, you look at the incredible advances in LLMs, and you have algorithms that, of course, can navigate almost anything. So I could say in some sense that kind of nano-market generalized thesis that a lot of people here I think are sympathetic to is actually a lot more likely than it seemed like a couple of years ago.
Yeah.
So where does Crunch come in? Well, Crunch kind of takes the view that ability is uniformly distributed across the earth, but opportunity is not. And that no matter how big your firm is, there will always be 99 smart people outside your firm for every one person who you manage to hire, if not a more extreme ratio, of course. And so if you want to sort of tap into the best ideas, you really have to let everyone play. So to give you an example, the Broad Institute, which sits between, I guess, MIT and Harvard, is very interested in whether you can design machine learning algorithms to look at a relatively inexpensive test and predict the result of a much more expensive test, and through images, basically blood cell images. And of course they had their own internal benchmarks, but then they came to the Crunch community, and we kind of rallied around this problem and pushed the state of the art considerably. Another quick example would be Adia Lab, which is the Sovereign Wealth Fund, wanted to push the state of the art for causal discovery. And so some of the leaders in the causal discovery field put together a very ingenious contest where people had to try to predict whether A was causing B or X was causing Y or something was mediated by something else. The internal, I guess the public benchmark was kind of 55% accuracy. The ADIA kind of internal quant team was about 60%. And if you don't know, the ADIA quant team is like more expensive than Manchester United. So it's like the biggest quant team in the world and the most expensive people. And the Crunch community, which is very different to Manchester United players or anyone else, it consists of people on dairy farms in France coding away, pushed it up to like 78% classification. So just one example. You never, ever know where the best idea is going to come from, and that's what Crunch is about.
That's great. Okay, well, one question I have is that there's obviously this debate of open source and closed source models. And right now, you know, DeepSeek is obviously at the top of everybody's list with GRPO and R1 really working. But at the end of the day, R1 is still worse than the latest models coming out of OpenAI, especially with Sonnet 3.7. And so my question for you guys is, it seems like, or maybe I should just open it up there. Like, what do you guys think as builders in the space about kind of this fact that open source continues to be on the heels of closed source, but there's also the contrary point that it's still behind? And how does this impact what you're building? Yeah.
Yeah. I think I have to digest into two parts. One part building on model training, and one part building on the post-training or the fine-tuning part. I think, well, from my perspective, I think DeepSeek really gave me a huge surprise on how well it actually works, and well, if the data
V3 or R1?
Yeah, I mean, if the data is correct, how cheap it's got trained, and you know, the brilliant engineering behind how they sort of get a leeway from the chip ban, and but well, as Casey just said, in fact, OpenAI O3 and Grok 3 and also Cloud 3.7 is still better than DeepSeek in a pretty obvious descent. And I think when DeepSeek just came out, people are having the sort of the opinion that, you know, compute doesn't really matter anymore. You know, China is going to overcome on this because of blah, blah, blah. Well, I actually don't hold on the same opinion. I think Grok 3 actually proved that with, as I remember, 127 times X the training compute being used on DeepSeek, they can actually outperform DeepSeek's performance by a pretty obvious degree. And there are obviously a lot of engineering optimization being done within Grok 3, but I also think just given the fact that how fast the XAI team can produce the Grok 3, given they just launched Grok 2 in 2024 mid-year, it's showing the fact that within given compute, within given talent, the scaling law for post-training does not hit the wall. Probably for Ilya, the pre-training for LLM hit the wall, but I don't think the post-training LLM hits the wall, at least in this year, and compute is still massive. So based on this premise, I still hold the belief that training-based model is still a tech giant game, and you know, training your own base model is never a good idea. DeepSeek is in a lot of ways a miracle from my perspective, and I don't think people will put too much emphasis on open source in the future. It's still kind of gonna be like a 3 months to 6 months behind on closed source. That's my guess. So that's the first part. And the second part, which is more interesting, I think, I don't know if you guys have used the OpenAI Deep Research product. I think this is probably the most agentic product I have ever used in my life, and by
far the agent with the strongest PMF.
And I think besides the deep research on OpenAI and deep search on Grok, every other search product is useless from my perspective. And I also think this is the only product that has great PMF after ChatGPT, launched by OpenAI. Okay, and I actually just listened to a podcast yesterday on the O3 team talking about how they actually built the deep research. It's basically an O3 plus a lot of end-to-end supervised fine-tuning on the specific use cases of searching. So this actually kind of gives us an alarm on how agent product can be built. It gives a possibility where agent framework may just not work in general. I mean, I should not be able to say that, but to be honest, like if you look at the deep research, It's so powerful, and there's no framework given. It's just purely trained based on O3 with a supervised fine-tuning. That's it. They there's nothing more to use at all, besides probably they can leverage some web crawler or Python functions. So I think the agent marketplace in 2025 and 2026, at least from my perspective, going to be in two areas. The first area will be a big tech using their super strong base models like O3, doing a lot of supervised fine-tuning on specific tasks like searching. So they're going to have excellent PMF on that one.
Making verticalized agents, but
exactly. And I do think verticalized agents can be a big tech only game from my perspective. The other area of competition is a more general purpose, solving more long tail, but you probably have to add a lot of human heuristic into the agent because I don't think the fully autonomous general intelligence agents is close to humanity. I think probably by 2030 maybe, but not within 2 years. So we're still gonna add a lot of human heuristic to the agent frameworks to make it actually work by comparing to O3 or compared to deep research, lowering down the autonomy to actually have a product that have use cases. So just to wrap it up, I think, I don't know if you heard of the bitter lessons in training models. Basically, every year researchers have this debate that they want to add more human heuristic to make the model work more closely to humans, but always turns out to find out that they just let the models do the work by themselves and do the reinforced learning by themselves. It's always surprisingly gonna work out better. So I think two ways: adding more human heuristic and just purely believe in the scaling law for RL. Those two roles both gonna work out in 2025 or 2026. After that, probably there's only one role, which is just ultimate scaling law hitting compute, and probably we can have general purpose AGI coming at that point. Well, what product format will my show look like? I have no idea. That's too far from now.
I like the thorough answer. Okay, do either of you feel differently or want to argue anything about that opinion?
I mean, I don't personally see how closed source is going to stay ahead. I mean, if you wander around this conference, you'll see.
Wait, you do or do not?
I don't. I don't. I'm a little biased. I'm an open source developer. I feel rather strongly about that, but there are 2 or 3 projects here at minimum, maybe 15, that are starting to address the fundamental problem of how sort of all the clever people in the world can collectively kind of create some really amazing LLM. And that involves things like federated training and decentralized training and things which has traditionally been quite difficult, but now it's starting to happen. It involves data collectives, it involves other technology layers, as you know. This is just getting started. So to me, it feels a bit, the closed source angle feels a bit like, closed internet kind of thing. I just don't see it.
It's just not going to work.
The open, federated kind of LLM that everyone can use is going to win.
Okay. I know they want us to wrap, but Paige, what's your opinion on the topic?
Yeah, I just want to drag us back to the audience here because I'm sure people here are mostly founders or devs, from crypto AI companies. I do think it doesn't matter whether it's open source or closed source because right now, even for the closed source models, they're not profiting. It's the services on top of the models that's actually getting their SaaS revenue, right? I think none of us should try to use $5 million investment dollars to compete with OpenAI or even DeepSeek. I think we should all focus on the orchestration layer or the framework that leverage whatever closed source or open source models out there that actually make use cases work. For AI agents or for us, it's the robots, right? And also if you look at LangChain, I think that's a great example. LangChain is a framework, and then you can plug in any models you want. You can plug in the fine-tune model with your specific data sets. But how does LangChain makes money? It's really the additional services. It's really the plugins, the outputs that's making the money and also making this whole system sustainable. And also, even the closed source model nowadays, they're getting really cheap. And for the open source models, on the other hand, they're having the freemium model. They're not going to be forever free. Like Gemini or Llama, if they want to charge any day, they can do it right away. Like we don't have any bargaining power. If DeepSeek, they want to start charging like more money tomorrow, they can do it. Like even right now for DeepSeek, the API is so unstable that we struggle a lot to integrate with the API, and you have to use a third-party API service to get a stable like DeepSeek connection. So I just feel like the line between open source and closed source is super blurry. And for people who are builders and people who want to leverage the powers of the big tech, we should just build the orchestration, also the application, the use cases on top of that, versus thinking about, hey, can I build another OpenAI to screw over DeepSeek?
Yeah,
hot take.
I love that take. Okay, they're gonna make me end here, so we'll wrap. But thank you all. A little bit on the future of models, half, I would say.
Can I say one thing?
Yeah, go for it.
So OpenMind, we're based out of San Francisco and Palo Alto. We are hiring for DevRel engineers and product engineers. And if you're interested, hit us up. We're also open to remote positions. We're a team of 10, super lean, super fun. We have an office in South Park, the startup circle in San Francisco. Hit me up. Thank you.
Do you guys want to make the call out?
It's okay, yeah. We're looking for engineers, but yeah. Just
Come
check
find
out.
these people if you want to join them.
Great job. Yeah. Okay. Is everyone here?
All right, good evening and good almost night for our very, very final panel talking about AI and crypto trends with Investor Insights. We'll have Ned as the moderator from SBC 10X. And please welcome the speakers, Greg from Franklin Templeton, Anna from DCG, Joey from Founders Fund, Brad from AWS, and Spencer from Theory Ventures. Last talk of the day. Let's do it.
I'm staring at it. Good idea.
Thank you, everyone.
Hey, quiet down.
Hello. Yeah, it's the last session of the day, and thank you so much for staying with us. And hopefully that you guys will continue to stay until the session ends. Hello, everyone. Hello, our panelists. Today we'll have insights. investor insights in AI and crypto, and from our panelists from the top VCs and the infrastructure provider. My name is Ned. I'm your moderator. I'm from SCB 10X. We are a corporate venture capital of SCBX, which is one of the biggest and oldest bank in Thailand. And we invest across Web3 and AI. And let me introduce, let the panelists introduce yourself. Let's start with Spencer.
Sure, awesome. Hey, I'm Spencer. I'm at Theory Ventures. We're a $700 million asset manager. We invest in data, so data infrastructure, machine learning infrastructure, AI, and crypto.
Hello, Brad here. I'm head of Web3 and venture capital for AWS North America. We focus particularly on ensuring our customers and our startups have the tools and infrastructure in order to keep growing. Since 2013, we've deployed $6 billion of AWS Activate credits. That's a stat from last year, so it's only bigger, to help the ecosystem grow. Our whole premise is that we want to support builders early in their journey, give them the resources and tools to keep growing. We were the first hyperscale cloud provider to provide full account teams and solution architects to startups. The way we think about this is, who are the future enterprises of the world? They're startups. And that's why we put so many resources and so much emphasis on ensuring our startups have the best-in-class products. We work very closely with our investor partners. How it works is that they're able to provide a code, and that code is redeemable for credits, and then that's what they use to go and start building. For many of you, our team is all here, and we're very excited to meet the most interesting projects in the space building today. Thank you. Oh, we got to share microphones too. Very good.
I'm Joey from one of the partners at Founders Fund. We're a VC fund that invests across all sectors, including crypto, but I spend most of my time on the crypto side. And yeah, our model is pretty simple. We try to find really, really great founders who are doing stuff that's relatively 0 to 1, where there's some sort of kind of big technical differentiation, where there's something that you kind of believe about the world that's different. So that's us.
Hi everyone, I'm Anna. I'm at DCG, an investment lead. I'm driving our crypto and DEI investments. DCG was founded in 2015, and since then we have been investing in more than 250 crypto companies. We not just invest, we also incubate. So we are the parent company of Grayscale, Foundry, Luno, and 2 recently launched subsidiaries, Yuma and Fortitude. And I'm really excited for this panel.
Hi, I'm Greg Scanlon. I'm managing principal at Franklin Templeton Venture Capital Fund. We're focused entirely on blockchain. We're a part of the digital asset unit, so we've got 60 employees who are also focused entirely on blockchain. We've got venture, listed token strategy, we run nodes, and we also have a money market fund on-chain. In terms of our venture fund, we focus on pre-seed up to Series A, and we are generalists in the space.
All right, and with the recent news, maybe I want to understand a bit more your thought on the crypto market right now, from the shift of regulatory approach on digital asset and the Trump's executive orders, and also the speculative meme coins that happened earlier this year. So just want to know, Greg, your view on the crypto market and the trend that you see.
So I'm probably a little more bearish than I should be as a crypto investor. I view the innovation cycle within crypto and boom and bust as running, approximately 4 years. I think that we are in a golden age in terms of regulatory. Obviously, the shift in the U.S. Has been a significant improvement. And I think that when you look at how token prices have performed, particularly recently, obviously the most recent pullback has been extremely rough, but the momentum has come out of crypto tokens, since early January, where crypto tokens, Bitcoin, all the way down to Solana, stopped really reacting to headlines. And so long term, we are still
obviously extremely positive on digital assets in general, starting with Bitcoin all the way down to high throughput L1s. But right now, I am concerned about this bull market, but it is an open discussion and a debate within our fund. We also have supporters of Bitcoin who follow the halving cycle quite closely and still expect the 175 in December at the end of this year. But again, we're in a golden age for crypto. The regulatory environment within the US has never been better. We certainly expect regulatory bills and stable coins, SAB 121 already here. And then hopefully we get a market infrastructure bill by the, maybe in the next 12 months. And these will all be positive catalysts. I think the thing to really watch for, though, is stablecoin adoption in reality versus the hype that is likely built into the market. I think there's still significant infrastructure on the enterprise side that needs to come along in order for stablecoins to take off.
Yeah, hopefully see the adoption in institutions and also more builders in the space coming, right? And what about you, Joey? Want to know, from this, news and events that happen, is it impact your fund thesis?
No, definitely doesn't impact our thesis because our thesis is mostly just centered around evaluating founders. So it doesn't really matter what market regime you're in for that. I think, but I think when it comes to the public markets, I'm quite bullish here. I think if you look at kind of the catalysts over the next 6-ish months, you basically have, I think my personal view is I think the dollar's topped here. I think we're kind of at maximum fear when it comes to tariffs. And as those deals basically get negotiated over the next few months, I think that fear starts to get mitigated. You mentioned the market structure bill. I think that will be a positive for crypto and probably a positive narrative thing kind of closer to the end of the year. And then, I'm kind of a person in my personal account. I do a lot of trading, and I think if you look historically at the correlation and price action of crypto versus gold, in many cases you actually don't see a massive crypto run for things like alts until after gold is topped. And gold's been on a massive run, over the last year. Although this morning I just sold all my gold, so I think gold is topped here as well.
All right. And any one of you has any other thing to add?
Absolutely. I'm going to follow up the second part of that where you mentioned the executive order piece. And I think every founder, every builder, everyone in our ecosystem needs to recognize this is our time. We finally have the pieces. If we were to just go back in our time machine and look at what we have now in place to go build from an administration perspective, from people that understand this technology and can actually offer opinions and insights. If you start looking at the different government agencies as well. So how I would, and how we perceive this is, it is a motivational time. We need to build. We need to build things that people actually care about. This is not incremental innovation of an L1 or an L2. I believe many of the folks here have funded the infrastructure that's going to get us there. What we need is to take advantage and recognize what are the products people want to use, what are the real world applications we're solving, and if we peel away all the words that we use to describe our thing, how is this impacting our data life? Do people love the products and the experience they're getting? And that's how we think about how we're going to move forward and the motivation we're getting.
And that's going to be my next question, as I see that AI and crypto is one of the key themes for this year and even from last year. And crypto and Web3 can help enhance open source AI in terms of ownership, privacy, and fair distribution. So just want to know, what's the use case or the verticals in AI crypto that you excite the most? Maybe start from you, Spencer.
Yeah, sure. kind of, so like a general framework I think about the market in terms of like large language models and disrupting businesses. I think the framework I use is if you look at trading volume in Wall Street, historically a lot of trading volume was like deep value investing, and then it eventually moved over time to algorithmic trading. I think similarly, enterprises will all be model-driven businesses. And when I'm thinking about the role that crypto could play in that, I think there's a couple of interesting things. I think probably, especially from a government perspective, you want confidential compute. So I want to know that the software that I run every single day hasn't been altered when I log back into my account the next day. Or the model that I'm running locally isn't exposing any sensitive data that I have. And I think crypto and blockchain could play a role in that. Currently, when you look at the market and the intersection of the two, there's been a lot of innovation around like decentralized training and fine-tuning, but for the most part, I'm not sure if there's a ton of demand for like another foundation model that's built in a decentralized way. I think hyperscalers or the large foundation model labs have a pretty big edge here. What I do think happens is I think the frontier model providers eventually all of their best models will not be open source, and they'll probably start to productionize those models and turn them into applications over time. OpenAI is starting to do this. You have like some UI components that you can play with. There's like some prompt engineering you can do. And I think eventually you might have like a lower grade model that's open source. And so maybe there's a place where crypto and AI, you could train like an open source model using decentralized infrastructure. DeepMind's released a pretty interesting paper with DLoco. You can now update the weights of a model and the parameters asynchronously, which is like a huge deal instead of having to stop the entire training job, update the parameters, and then resume training. I think to answer the question very directly, there's two areas that AI and crypto kind of intersect today. I think you're seeing a lot of people who are interested in like agents that can handle tasks on your behalf. I think if you look at intents, where a user might want to execute a trade and they don't really care how that trade is executed, you probably have agentic infrastructure that's searching for the best routes to complete that order. And I think that could be very like algorithmic, and a model could actually be the one that's routing that order on your behalf to find the best liquidity, et cetera. That's one area. I think the other area that's kind of interesting is data labeling in general has kind of hit a threshold. Scale AI and other companies are manually tagging images, literally drawing circles around images. Over time, that's not really scalable. I think you'll probably need models that are actually verifying images, and then humans are just like checking, because the rate at which these labs are ingesting data is astronomical, and there needs to be like some sort of gamification. So I know there's a couple companies that do like data labeling using crypto incentives and micro payments. So I think those are two kind of interesting areas I've been spending some time on. I'll stop there.
I think we are excited about different layers of the stack, mostly about the training and the data layer. So on the training layer, we have seen interesting companies, Pluralis, Genzim, Prime, all using different approaches for incentivizing compute and high quality model contributors. And on the other hand, on the data front, we did a couple of bets as well. I would love to see more. I think we have acquired many data marketplaces, but would love to see more on the data curation, labeling, as you mentioned, and verification front. And there is another segment that we're actively looking at is robotics and AI. We just had a panel on it with OpenMind and Casey. So that's another segment that if you guys are building in the space, we would love to chat.
Yeah, the only thing I would add, I think some of the kind of decentralized training and decentralized inference stuff is interesting at like a certain large enough scale, which is, if you look at kind of some of the mainstream like AI companies, a lot of them have plans to use like nuclear power to build data centers. And I'm actually pretty bearish on nuclear over a short time horizon. I just think it's always way harder than it looks. It's always farther away than it looks, and it's always a huge amount of red tape and permitting. And I think, Trump's going to improve some of that, but it's impossible to change all of the local permitting stuff. And so if you look at it from that lens, eventually to train large enough models, in my view, you basically have to solve distributed training. And historically, a lot of the kind of AI companies have kind of written that off. And so I think there will actually be some crypto-based companies that solve that problem, in my view. And then the other thing that makes that interesting is a lot of the kind of like companies that have spun up offering bespoke AI training like services and inference services are basically like brokers. They're not markets, and so they wrap things like AWS, or they wrap other businesses, and they add like a crazy premium on top of everything. And so I think as compute gets more commoditized, I think it'll start to trade more like a commodity. At least when it comes to things where there's massive amounts of commodity like demand, which is like if you look at like the training runs, they're basically like if you're doing a training run, you always want to run it for the most part on like whatever the state-of-the-art NVIDIA hardware that it is that year. There's obviously some edge cases where you don't want to, but there's like a reason why Elon is ordering these massive orders from NVIDIA. And then outside of the training thing, I think the other interesting area is like not like the memified AI agent stuff, but like very basic AI agents. Like we invested in a company, it's still in stealth, but it basically is a simple kind of English first AI agent that lets you like trade on currently centralized exchanges and eventually decentralized ones. And it's doing like $1 million in revenue a month. And so I think for certain things, like I doubt even most of the users know it's an AI agent like software architecture behind it. It's just an easy way for them to trade where they don't have to manually enter everything. And if you think about it, if you're a trader that's like a news-driven trader, speed matters a lot. And unless you're like a really expensive quant fund who has a ton of infrastructure, if you're just a retail trader, being able to kind of automate a lot of that and just like type exactly what you want and have it executed on the exchange is much faster than like opening a tab to like Binance or Bybit or whatever, and then manually entering your order. And by the time you do that, probably most of the alpha is gone. And so I think there's some interesting kind of low-hanging fruit agent use cases that aren't like what you see the massive hype around, but actually people do want them.
Yeah, I agree on niche models. It's one thing that we've been thinking about, and part of that is driven by the fact that over the years, I'm old enough to remember when Netflix didn't open competition for their recommendation engine because they are, particularly kind of annoying and difficult models to work with low signal noise ratios, and so. The unfortunate thing about that is that the winning team only got $1 million, right? And Netflix is a multi-billion-dollar company, and so to the point of why we think about companies like Sentient, who kind of, in a way act as a platform or a broker, is because historically us mathematicians and engineers have not been the best at maintaining price advantage and commoditizing our work. But so niche and difficult models, certainly as we move through the phase of these very large centralized LLMs being the main driver of innovation, and also principally we're super interested in alignment, to the point of privacy of data, particularly on an enterprise level, right? Knowing that your data is staying where it's supposed to stay and that the model is doing what it's supposed to do, and being able to evaluate that to the best of your abilities, right? We think that open source with blockchain provides, particularly interesting platform to create an optimal environment for alignment that enterprises want immediately. And we think longer term, retail, regular users like ourselves, as these niche models become more ingrained in our lives, and we're offering up, free personal data of where we live, so that it can open your garage as soon as you're getting close and turn on your lights and things like this. The convenience along, with like using a centralized exchange, but all these niche models, they will require a certain amount of PII, and so we think that long term, all of us will care about that alignment and control.
Anything to add, Brad? All right. All right, my next question is about, when you evaluate these startups, what kind of attributes or qualities do you see in the startups when you want to invest in them or you want to support them? Maybe start with you, Brad.
Yeah, so we take a lot of signal from our VC partners. We also look at the track record, the founding team, and ultimately what they're building, right? For us, we want to identify who is building hyperscale applications and make sure they have the tools and resources to keep growing and scaling on AWS. We have over 280,000 startup customers, right? So for us, it is both about ensuring the 2 coders in a hoodie in a garage are building on AWS, that same level of tooling, and also some of the largest now enterprises of the world, which began as startups. And as they continue to grow and need different resources, we support them at every step of the way with that journey. All sorts of different programs, from CEO education to CRO, CTO programs, to co-sell enablement, to technical workshops, right? And we map all of the different programs along the startup journey from growth through scale. So that's why we have over 4,500 providers. So those are ones that can issue credits to their portfolio companies or participants. And that is how we look for signal in a very large market.
Got it. What about at Theory Venture?
Yeah, Joey said something actually in the intro that was like one of our slogans, which is like technical discontinuity or some sort of unique insight into a market. And so usually we're looking for founders who are obsessing on some specific vertical. When you spend every waking minute thinking about a problem, you usually have some sort of like go-to-market advantage. And I think that's really important because the cost of acquiring a customer over the last 10 years has gone up like 500, 600x or something. It's very difficult to acquire customers now, and so you need to have an initial wedge into a market. And usually, I think what we're looking for is some sort of technical insight. So that's like the primary thing that we're looking for. Yeah.
All right. What about you, Anna? Just want to know your ideal teams. What was your ideal teams like, and what team to avoid?
Yes, so we are investing mostly at pre-seed, seed stage first. So team is, of course, like the most important factor. And we mainly only invest in teams that have both AI and crypto talent, which is very rare. So on the one hand, we want to have at least somebody in the co-founding team with strong ML expertise, both for the tech as well as to attract other ML talent later onwards. And on the other hand, we want someone who understands crypto incentives. So we have seen a lot of teams only with crypto talent only, or just pure Web2ML talent without understanding tokenomics. So that's something for us, that's the most important, to have like complementary teams. And of course, like all the other factors that the rest of the panelists mentioned.
Anything you want to add?
I'm going to say basically the same thing as everybody else, right? You have to have the technical skills to do it. And we're also looking for you to think about whatever product that you're attacking. We want you to think about it in a completely different way than it currently exists in the world.
Yeah. And for crypto and AI, like tokens right now, right? There's a lot of projects like AI agent tokens that price very volatile, and 90% of them doesn't make it past 2 weeks. So what's your take on that? Like, how do you value your project, your startups before you make an investment? Maybe start with Spencer. Sorry.
Yeah, kind of like 2 different frameworks. So if you're investing in liquid tokens, obviously there's certain thresholds. You can only invest in tokens with a certain market cap so that you can actually get in and out of a position, right? So a lot of hedge funds or trading firms usually don't want to be more than 10% of daily volume. On the venture side, which we're typically doing venture investments, valuing a company, was that the question? Was it kind of?
Yeah, how do you value the company, especially like crypto AI?
Yeah.
Maybe pre-TGE?
Yeah, this is kind of an interesting take. I think I think the market is very hungry for AI exposure. And in the public markets, it's kind of difficult to find AI exposure beyond NVIDIA, Microsoft, and a few other providers. And so I think one interesting thing that crypto and AI kind of offers and certain token projects offer is exposure to retail to AI at reasonable valuations or cheaper valuations than paying billions of dollars or trillions of dollars in NVIDIA's case. So I think from a valuation perspective, it could be attractive for retail investors to get exposure to AI through tokens. I think that typical vesting for a startup is 4 years, and the reason for that was it used to take 4 years for a company to go public. And now, look at Stripe, look at these other companies, it's 10, 15 years sometimes before a company goes public, and it costs $15 to $20 million on average to take a company public. And so tokens offer kind of an opportunity for a company to issue tokens much earlier, and you get these liquidity events much sooner. So I think it's an interesting intersection, and the two kind of play nicely together. But that's generally kind of how I think about token exposure in AI and crypto.
Anything to add, Greg?
I think the reality is you have to view it as a relative valuation game. Otherwise, you probably won't end up participating. ML, AI, it is a foundational technology. It's optimizations upon data built by data. And so it can be integrated into anything and everything in your life. Just with blockchain, where you can view blockchain as being a seller of trust, and every interaction that any of us have at any given moment, it requires some level of trust. And so blockchain is also a foundational technology and product. And so in our view, you have to view it as on a relative valuation perspective, whether you're looking at the equity because of some of these AI valuations or the token. And the retail participation certainly plays a role in these relative valuations.
Yeah, I was looking at the multiples on revenue of some of the popular DEXs versus the SEXs, and they actually trade very similarly. And so I think over time, some of these things are starting to trade on a revenue multiple, and you can kind of apply a traditional framework to evaluating them.
For sure, and Solana has come down towards there as well. I think when you look broadly at the crypto token market, you get multiples anywhere from 20x on true financial services businesses, whether it's a DEX or Athena or Maker, all the way up to, Bitcoin still trades at something like 5,000 to 6,000x just on fees, and other L1s trade at 10,000x plus. But so retail is not aware of these things. But that is also why it needs to be thought of, in our view, at this point in the life cycle of tokens as a relative valuation game.
Anna, want to know what kind of metrics or measurement you have for your startups in terms of evaluating the performance?
I mean, I can just repeat the rest of them. Given we invest mostly pre-seed seed, it's very they don't really have traction at that stage, and we try to be valuation sensitive. But on the other hand, given we do both equity and token investments, we evaluate the metrics and generally the teams very differently. So we also have colleagues who are doing Web2 enterprise AI, Web2 fintech, and they are bringing pre-seed deals sub 20 mil to IC, while I'm bringing pre-seed deals at 50, 100 mil. So it's a different evaluation that we are making. In terms of metrics, so what we are looking for, especially for those projects that we are launch protocol, is mostly strong network effects that they can achieve. So either to have a strong tech edge or network effects. In terms of metrics, again, when we invest, it's very hard for us to evaluate any performance metrics because most of them either maybe have some kind of pre-sign up or pre-traction, but mostly it's just a team bet.
All right. For this question is about the market landscape and also supply demand on infrastructure side and the demand side on applications. So you see there's right now we've seen active development in decentralized AI infra, but we rarely see the powerful AI applications that attract high adoptions or like sustainable, tractions, or even from the enterprise use cases. So, how's your view on that? What is the problems underlying on this? Is it infra or is it on the application side, Brad?
Yeah, I'll start on this one. This event was a success today, and it's exactly where our community needs to be and building. But I'm going to give you some data points. HumanX, which is one of the largest AI conferences, there is no crypto, blockchain, Web3 presence, right? Jensen's about to have this big NVIDIA conference. I think there's one keynote or session. So my motivation to the ecosystem is recognize, yes, we have a lot of friendlies here who are all looking for the same thing, but I'm in a unique vantage point when I go into the office every day of hearing what my colleagues are talking about, how innovation is hitting them. And I hear every day about a cursor or a new AI tool or some incredible innovation that's jaw-dropping that is just captivating the audience. So whether it is how we talk about the incredible work that we're doing, the simplification of the applications, we need to recognize to play at that same level where we are getting towards adoption, we need to go out to the audience, to the world, to get out of our bubble. And yeah, these are some complicated products sometimes, but that's fine, right? When there's enough motivation or the product is interesting enough, people will learn it. So when I think about where we are in this cycle, there's so much opportunity because Web3 cares a lot about AI. Spicy take. AI, so far, outside of our world, not really caring about what we're doing. And as each of us who are committed to this ecosystem, believe in this technology, need to go out and recognize the contributions we make need to be so much magnified, like multiples bigger, before we can achieve the level of adoption we hope to get to.
Thank you. And Joey, what's your take on this?
No, I mean, I totally agree with that. I think I think part of it is like the kind of whole crypto involvement, with minus a few exceptions with AI, is much earlier, along in its life cycle. And then I think the other aspect of crypto that makes it more complicated is like the infrastructure challenges with crypto are harder than, if you're building a Web2 startup. And so there probably is some like lag or lead time required to just get that stuff in place so that people can actually build interesting apps. But that said, I think, if you look on the kind of application side of things, I'd like to see more people start to build stuff that's like involves crypto plus AI, where it's useful today. I think you see a lot of people talk about like, oh, in X number of years, AI agents are going to all use crypto for payments or whatever, and it's kind of just this like very forward-looking vision. But I think, as the example I gave with like the trading, agent thing example, there is stuff you can build today that users actually want, and A, the more of that, the better, and then B, I think as there is more of that, like the AI world outside of crypto will start to care about it more, because they'll be like, oh, like that's weird, like we just had an increase in API usage and it's like from this random startup that's using like crypto with AI, that's weird. But if you don't have that, then to your point, like they're not going to care. And so I think it sort of comes from like, we'd love to see more consumer stuff in crypto. That's not just like pumped up fun. There's no good way to combine AI with pumped up fun in my view. So I think that's something I'd like to see more of, is kind of true consumer apps that use it more in the back end, but it's still really useful for users.
And I would just like add here, like look at BitTensor. Like many people look at BitTensor as infrastructure layer, but ultimately the subnets serve as the application layer. And some of the subnets have like real world use cases. So for instance, DP, they are developing a role play LLM, and their application was number one at many of the Play Stores in different regions. Or you have Subnet 19. They are one of the best verification inference layers, and they are supporting many AI agents. Some of the subnets have trained more than 5 billion parameters. So we have like these first early protocols that now reaching product market fit. So while we might be still early, I think like a lot of application layers are just coming now.
Yeah, just quickly, I've seen 3 interesting applications within crypto already. I've seen like a cursor for crypto, so helping code smart contracts more quickly. A friend of mine's launching a company that lets you build any application using a prompt. So like end to end, I want to build a DEX or whatever. Obviously, you still have to build an application. I just think that Together AI started as a crypto company. It's a $150 million revenue generating business that does model hosting. I do think there's an interesting overlap here, and we'll get more applications over time. Payment seems really obvious, order flow, stuff like that. But it does seem like we're starting to get like application-specific blockchains, like Hyperliquid is really interesting, and I think we'll see AI applications over time. The interesting thing is like you're still using like a big foundation model for a lot of this, for building an applications or a lot of this infrastructure. And so maybe you see an open source model that was trained, in a decentralized fashion, powering some of these things. But I actually think there's like applications are coming sooner than people think.
What about you, Greg? You want to ask?
Agreed. On the payments and stablecoin side, I do think for crypto native companies, there are interesting applications that we're seeing built out and leveraged just for automations. So you're onboarding a Web2 user, the back end is in crypto, but now because you've got them all the onboarding all the way into payments on crypto, you can have them use a bot that is crypto native, and it can automate their payment behavior. And then in principle, we are super interested in, again, consumer apps, because thinking about payments without silos that currently exist kind of in the Web2 tech world, where you would have to link up multiple payment venues in order to compare products across a number of different companies. That's a space that we're not necessarily seeing adoption, but we think is a significant opportunity for crypto, just in terms of a competition, price transparency, and payment flexibility that isn't possible, we think, in the near term, next 2 to 4 years. And maybe that's too long. Maybe Amazon will disagree with that for the enterprise world.
We have a long view, right? So we recognize it's going to take time.
Yes, very insightful panel today. And anything that you want to, give the last note to the audience before we part today? You can start with.
You've been kind of inspiring.
Well, thank you. Yeah, absolutely. So I didn't bring credits, but I do have bags. Get them on the way out. Listen, come find us, right? These people are here because they want to meet you, and we're here for the builders. I will go back and say, this is our opportunity to go build. We actually have the most ever venture capital dry powder that's ever existed. I think if you take away the 2 irrationally exuberant years, we're on track. Last year was the 3rd highest year. We're projected to be this is going to be that highest year. The money, the venture capital money, is ready for incredible founders. We are finally at a point where the infrastructure is ready. So when you look at these ingredients and the timing, right, to go back to kind of bring it all back together, regulatory environment, what we'll see, frameworks, and how it's going to work, it's our time. And we need to focus on building, spend time with each other, figure out the pieces that can help accelerate, and then go build incredible products that people want. This technology was meant to be used, and we should focus on that and figure out the absolute most incredible things people are looking for, and how can this technology do those incredible things around banking and payments, right, that we set out for it to do, and that's going to be a really exciting future.
Thank you so much, everyone. Have a wonderful night.
Let's grab a photo.